doesn't do anything. So watch out. Yeah, he's gonna hit you.
What was that noise? Ah.
Hey.
Holy dude. Oh.
Reese,
I was
hello. I'm surprised your thing made it through the storm.
I am too.
That was no.
You know what that means?
Yeah, if I made it through that, then you're good.
What
Adam.
happened?
What didn't
I
happen?
need some more balls. Gotta shoot it. Shoot it like a good one. Shoot it, Yanni.
Okay, make a rim.
Shoot it, Yanni. Shoot it, Yanni.
Oh, that's kind of fun. Okay.
Yeah, thank you.
Wow, that's it. You guys still. You know what's hard to me? He's putting Yoshi in the ceiling.
No,
The one that tells you to
Yoshi
run
was
out
not
and go down over there.
Yeah, like what in the world is Yoshi doing out there?
Oh, what happened?
I
Get
used
over
to
me,
my
Grant.
thumb and I think I damaged the nerve, so I'm thinking
Oh, that's not over.
I can't get it out of this
That was
position.
not over me. That was not over you.
That's
Yeah, I got this.
What are we
touching
doing?
somebody?
Yes.
Okay, thought so.
Fighting the bear,
Typical.
actually.
The bear also can't move its thumb.
What are we doing?
I'll-
Why you caught that?
We're doing warm-ups right now.
Are these warm?
They are.
I showed the trainer.
Good at that.
I knew that.
All right, guys. So go grab a seat for me.
To make that.
One sec. Guys, grab a seat, please. So plan for today, we're gonna do a game, as you can kind of tell. I'll reset the scores here for you. So we'll do a good solid game of grudge ball. Everyone's not take it personally. Try to leave as friends. But before we do that, the only other thing I planned is I want you guys to kind of just work through a few of these warm-ups. There's a number of them. So kind of get through what you can. If you get really stuck on one, there's a whole variety. So maybe try the ones you do know. We'll go through all these. We'll talk about them, see if there's any questions, and then I'll divvy you up in teams and I'll explain the rules of grudge ball. So I got it with the fish this time instead of the cards, so we'll be good to go there. But first things first, just go ahead and start warm-ups. Few things for order of business. We don't have this class Friday, so there's no quiz this week. Yes, and then I think next week you have a 3-day week. So
Thanksgiving.
no, that's 2 weeks from now, which is also a 3-day week. Yeah, November is it's a great month. December is also great.
Wait,
January is rough.
what
Yes.
did-
Grant, question and then Yanni. Okay.
Was.
He's in the restroom. Thank you for keeping track. I know where he is.
Wait, what's happening on Friday?
This Friday?
Yeah.
End of the quarter.
Oh,
So-
that's right.
Yep, so all the grades go in, nothing touches a transcript. So end of quarter grades that you're gonna see this Friday, no college will ever see, but your parents and you will see. It's the semester grades that get stamped into permanence. So this is just a pace check, like, hey, you're halfway through, so grades are gonna be final. You make some corrections or you're good to go, but nothing's permanent as far as this goes. What is permanent though is if you have makeup work in the past, you can only do it within those quarters because we have to seal the grades and send it in. One and then Grant.
Why is next week 3-day week?
Labor Day, and then there's a teacher training day. So it's Thursday, Friday, so you got a nice 4-day weekend.
Oh,
I got a 3-day weekend with some meetings, but it doesn't-
3.5.
is it a half day?
Well, if this Friday's a half day.
This Friday is a half day, and then the following Thursday, Friday, I think we're off. So the next 2 weeks
Oh,
are,
I said Monday.
Wait. So wait. Labor Day is Monday, right?
I don't know, someday next week. I still we have a 4-day weekend.
I thought you said we had Monday.
I know this week for sure, we have no classes, right?
Oh. okay.
Yeah.
I guess-
Okay, other questions?
That's fine by me.
It's kind of light. We had 2 full weeks and then now we're gonna switch it back. All right, so spend some time in the warm up. I'll probably give you 5-7 minutes, maybe a little longer. Don't expect you to get through all of it, but try to get through what you can. I'll get you checked in. We'll talk about this warm up, then we'll dive right into grudge ball.
This isn't gonna be on our final, right?
Say what?
I said this isn't gonna be on our final, right?
What's on there? Well, I mean, we're a long ways away from a final.
How big is the final?
Like the final?
It's the,
No,
it's in like,
I think that usually it's around 45 questions.
Like the final for 12. If I get above 50%,
And I do multiple choice for my finals.
how multiple choice? How big is the final for?
I have no idea. I don't teach fifth grade. Grant?
So the finals. I don't know, no, it's just.
So the final is end of quarter 2. That's your first set of finals.
I'm gonna be gone the whole week before the week of finals, and that is the worst week to miss.
That is tough. Yeah, review week.
Yeah.
Well, just keep doing what you're doing. Remember that last quiz.
Oh, yeah, that's great.
Okay, go ahead and try with a few of those. I'll wrestle through them with you, and then we'll get to our game. No homework tonight. We're just gonna focus on the game. I think it might be because these won't take a little bit. I'm pretty certain it's gonna take us until tomorrow for this game. It'll be like a period and a half competition. So yeah, I think it'll be fun.
Are you guys about to get ready for the result?
Just to spend time practicing.
The bear.
Oh.
Yeah, one of the feedbacks you guys gave on the anonymous feedback was too fast, and so I want to have more of these days.
You were the bearer of good news today.
I am.
Yeah.
Has there been
No
bearer of
home-
bad
no
news?
homework.
Yeah.
This is 3-day week, 2-day week.
What's
3-day
for
week,
lunch?
whatever.
Pancakes.
Pancakes.
That just makes it better.
Why'd you say that? God.
Why'd you have to ask that? All right, guys, good work on that. I'll get you checked in.
It's better- what's better? Any of this weekend, there's no tacos, like for this week. There's no tacos.
What? Oh, it's a soup one?
Their tacos are the best.
I agree. I do like the chicken sandwiches.
Oh, yeah, those things are good. I haven't had this is soup food. Oh, is this another soup food?
I don't know. Let's look.
I like their cheesecake.
I haven't tried the cheesecake.
I love.
I love
I like
cheesecake.
your cinnamon cake.
Okay, shh. Bring it back in, guys. Hey, guys, warm up for me, please. Let me work on this warm up.
You should put lunch on.
I know, I'm refocusing us. Oh, tomorrow's taco day.
What?
You liar! What?
Yeah.
My mom literally showed me that.
You lie.
Unless I'm looking at the wrong thing.
Is that this week?
Let's see, November 2nd. Yeah, tacos. Pancakes today, tacos. Yeah, chicken, I like that one.
Your mom must have looked at the lost one.
It might have been.
This was different than the one I had. I think my mom showed me this.
Excuse me,
Yes, Mr. Martin?
there's actually no today on Thursdays.
There's no what? Oh, did you just change that?
Are you putting in a new executive order that we can't have pizza on Thursday? Yeah.
I mind pizza.
I think it's good. Let's toggle them out of power.
All right, yes.
we can rise up.
Go, refocus. Warm up for me. So we need for a game.
I don't know what 2 plus I is. Well, I mean, I do, but
Yeah, I'll start you out with 2 real quick if you have struggling with this one. What is, I'll have more here. What is, what's a problem with number 2? Taylor? Yeah, good use of terminology. Yes, I have a square root in the denominator. Can't have that. What square roots is there? I don't see any square root symbols. Here, Grant. I have a negative root -1. So this is the exact same thing as this. Whenever you have 2 terms, you have a special tool which eliminates oi, called what? Oi. Close.
Oh,
What eliminates oi?
negative.
Starts with a C.
Conjugate.
Conjugate. Good. What's the conjugate of this guy right here?
That's not.
Conjugate of this guy.
Wait, what was the question?
It's
Done?
negative plus square root -1.
Yes. So this will be your first step.
What?
And it's really nice because yes, it's a FOIL situation, but no oi. So first time's first, last time's last. I'll leave that there.
nothing else.
Question is this?
It is not. It is the 1 to 2 steps away from the answer though. So you would want to multiply those and then see what happens. We'll have some like terms that will come together.
Why wouldn't I'm sure there's nothing you can decide. Yeah, I'm sure there will be.
Shh, guys, both out for me. Oh, there was other one. Let's continue quietly working, but each quarter we redo seam charts. You guys, I think, have done a pretty great job. So if you send me a request sometime before next Monday on any preferences you have to where you like to sit, I'll take that in consideration. Just on Teams. So if you have a preference, sit me on Teams.
Him on the other side.
It's your personal preference.
And then how many friends that-
Yeah.
Just the-
Wow, that's
I
offensive.
just have the whole puncher.
Wow.
He's a good listener.
He's a good puncher. He punches.
Why would you say this?
All right. We'll sit through some of those. If you're really stuck, let me know. I'll give you a hand. He is. Yeah. Yeah.
With Owen.
No. I think, why do I have to be with Bill?
These are all good teams.
Wait, where is he? Oh, there.
What are we doing?
Math.
Are we doing parabolas?
No graphing. Oh, Discord. Yeah. That's how WIA does their esports. Good.
He really likes it. He likes it a lot.
Lee.
All right, guys, let's talk about these, just so we can have some time. I know you guys are still working, you're doing great, but let's look into a few of these, just so we're prepared to kind of go through what we need to go through as far as just getting some more practice on some of this. Okay, first things first. What's the issue? Square root. Square root. Yeah, so cannot have square root in the denominator. And there's two other rules. What's one of those rules? Square roots in the denominator. Yeah, it's be as simple as possible. So is this okay? Okay, so no denominators in the square root kind of flips it. Yanni?
square root 2 over 2.
I agree, but what's our third rule?
So
So no roots, no denominator root,
you
no roots, no denominator.
multiply the square root 2 to both sides.
Yeah, you're right. We're talking about the rules right now, but we'll get to that. Nope, we're not talking about this problem at the moment. Talking about the rules for simplification of radicals. No denominators in the square root, no square roots in the denominator, and the very first rule we learned.
No square roots in one.
I agree, that's in there. Yeah, no square roots in the denominator. No denominator square roots. Is this okay?
Yeah, no.
Negative.
What could you do to this guy?
Because simplify.
Yes, no perfect squares left in the square root. So it's those three rules. And so here, because I don't want to do this, as Yanni was saying, you could just do the fancy one, multiply it straight across, giving you, this is your final answer. Root 2 times root 2 is square root 4. That always is going to simplify this because squaring, meaning multiplying something by itself identically. So squaring always cancels out square roots. Okay, this one, a little tougher, but not too bad once you have your conjugate. What's first comes first? Good. What's last times last? Good. So it'd be minus a -1 because the roots cancel out, but the radicand, the stuff on the inside, stays there. So those would cancel out. That would stay there. And so this would just be 4 minus -1. What does that really equal? 5. Good. Yes, because minus a negative, tricky, but that's adding a 1. And then the top, I have 2 minus root -1. Do those get along at all?
Yeah. Yeah.
Yeah, we just want to write 2 minus I. This is an imaginary number, that's a real number. Those are completely different. This is on the number line. This is on the other dimension of the number line. Those are not, they don't get along too well. Okay, so that's that guy. Questions on that one? Man, lots going on in Discord today. Discord is a gamers chat, but it's what esports is using to communicate. Okay, this one. So I'm going to solve. How could I solve this? Do we have an idea? Oh. Good. We move 77 over and perfect the square. See another way. That way would work. Okay. I could leave a square root with my x, and this would be a messy number. GCF. See GCF. Just a 1.
I don't know.
Yeah, Grant. Yanni.
You can do the parentheses. You could do X. plus,
Drum roll.
And then on the other one, X minus.
Okay, I like all that.
And then this one.
Yeah, what are the multiples of 77? Can we think of any? Anna?
11.
Good. Is that useful at all here?
Yeah.
Yeah, because then I could just do positive 11 minus 7. Now, if you did completing the square, it would still give you the right answer. Just might be a little extra work, which is okay. But it's always nice to kind of remember there's multiple ways to do these things. I'm almost done. Anna?
You set them both equal to 0.
Yes, set them both equal to 0. So I'll do the first one exhaustively so you can see my pattern. And then the next one, I'm just going to skip. So that would be, so then I could say, I could leave it like that, or I could say x equals set notation of -11 and 7. Now I'll do that. So this is solving by factoring. So if you ever want to solve by factoring, you use the box method, method 2, or something like this. How do you know when to use box method? What was that? 3, close. Did I use box method here? What would you say?
When A equals 1.
So when A equals 1, you can do factoring. If there's anything else here, you have to use either method 2 or box method. Good. Yes. All right. Let's bump over to this guy. This one's a little trickier. This is the most recent thing we've been kind of grappling with. We'll do a lot of practice with this week and a little bit today. Can I factor this? No. And because the only multiples of 1 are 1. So it's a very unexciting thing. Everything that multiplies to 1, and there's no way I can have 2 1s add up to 3. It's impossible. So what's the problem here? Yeah, this guy's my issue. I can't do anything with him that's helpful to the rest of the equation. So I'm gonna move him off to the side and say, okay, you're a problem, but I don't want to deal with you right now. And so my first step is gonna be move him over. Now I can do whatever I want as long as I play the rules of equality. How can I perfect this imperfect square? Make it perfect. Trinity? Yeah, so I'm gonna have a little sidebar here as I kind of think about this. So I have, here's your formula, b over 2 squared. My b is 3, so I have 3 over 2 squared. What's that equal? Good, 9 over 4. So I'm gonna add 9/4 to both sides because the law of equality. Now, this right here, this is ugly. Like if you had to sit there and kind of think, okay, what multiplies to 9/4 but adds to 3x? That is not a pretty place to be. However, you already solved it. What number goes here? Good, 3 over 2. So I have 3 over 2, x plus 3 over 2. Excuse me. So if I did x plus 3 over 2 times x plus 3 over 2, two of them, I would get this. Over here, I'm gonna go ahead and combine these two. What does -1 need to be in order for those to come together? You add fractions. What must be common? Denominator, right? And so this is technically, I'm just going to kind of just switch it right here. It'll be 4 over -4. So then I have 5/4. And now I'm ready to use my perfect square. I did this for this very step right here. What do I do? What's the most complicated part about this line? The x, 3/2 squared, 5/4. That's the root most sense. Because I don't want to have to FOIL anything. The whole step of this was to cheat the system and skip having to FOIL or do anything else. So I'm going to square root both sides. This would just give me x plus 3/2 over here. And what's the right side? I'll give a small stack of Starbursts to anybody who's going to answer this right side correctly, because this is a tricky step and we really wrestled with it in period 2. Let's see. I write it down. Let's see, I'll do a couple guesses. What do you think that right side would be on this next step? Close. Let's see. Here. Just do it a different way. What would the right side be?
Share my stack.
Very close, very close. Oh, so close.
All
All right, maybe if you yell out. Does anybody have a guess?
I got it. I got you.
Wait, anybody have a hand? What's it say? Get it? Very close.
That's what I know.
Well,
Take 3 plus or minus 5 and 2. Or square root
-3 plus or minus. I just want, what's just this right side? This is my left side here. What's this side?
plus or minus square root 5.
That's what I'm looking for. Plus or minus. Plus or
No.
minus. So
totally had
very
that.
close. All right, I'll have a few more I'll throw out here. So this next step, plus or minuses are so tough because it's like, it's not something we've dealt with before, but it's something that's so easily forgotten. Now, why is there a 2 down below? I didn't see a 2 in that previous step. Where'd that come from? That's right, square root of 4 is 2. I knew the square root of that. That way I don't have to rationalize the denominator or anything. This one's good to go. I have my last step, and there's 2 ways you're going to see this type of answer in math classes. This down right here is I'm just going to subtract both sides. And so what I would have is you would either have x equals -3/2 plus or minus root 5 over 2. Sometimes some math books do it like this. I don't know why they decided on a rule, but some of them will have them like this. And the other way that is totally acceptable that you'll see in some math classes is they will put these, since they have a common denominator, they'll put it like this. Both are fine. It's really a preference if you like stuff separated or if it looks better to you like this, but you'll see both ways. Questions on that one? I think that's a hard one. Any questions or comments? Great guesses, by the way. Let's do it. All right, let's see. All right, so this guy has really 2 steps. The first is you want to get everything to be alone with just a square. And then your next process will be square root both sides and then get x alone. So if I want to get my stuff squared all by itself, it's the first thing that's got to go. 2 is something that has to go. I don't know if that'd be the first. Yes, -1's gotta go over. When you're undoing stuff, you do the reverse order of operations because you're undoing this problem. So I go +1, +1. So now I have, let's get rid of this. So this would give me 2x + 1 squared equals 32. Is it squared all by itself now? Who's with it? 2. How do we get rid of that 2?
Divided your.
Yes, divide by 2. Now, distribute is a good guess. I like that we're saying distribute, except that we want to isolate this. That's our goal, because we want to square root it. So if we're distributing it, we have to FOIL first, because order of operations and distribute. We don't do all that. So divide both sides by 2. So now I have x + 1 squared equals 16. Is it by itself? Yeah, what's my next step? Good, get rid of the square root. You can FOIL, it would give you the right answer, just a little bit more work. I want to show you the quickest, shortest way. Okay, what do I put on the right side here? Trinity? Yes. Thank you, Trinity. So ±4. And then my last step would be what? Trinity? That's right. Don't make that a ±3, because we have to consider this in 2 situations. What's -1 + 4? That is 3, but -1 - 4 is not 3. That's a -5. And so this would just equal either 3, and it will also equal -5.
Wow, I did so much work. And I got it so wrong.
Oh, we're gonna practice these. Okay, last guy, the last one. He's a little guy. You had something like this with no context. What would you do to solve it? Looks like a first step. What don't we know here? What's our unknown? Oh, here, make sure it's not confusing. This is number 5, not a part of the equation. Yeah, I don't know what B is. What else don't I know? What is my unknown in this scenario? Trinity? Yeah, I don't know what X is. If it's unknown, what do? Oh, I like that. It's a different twist. If it's unknown, get it alone, or unknown, make it known. Yeah, so I need to get this guy alone. X needs to be alone. What's a good first step to get him alone? Reese.
Move the 1.
Yes, so I have x squared equals -1. Step 2. Square root. We got this one. We got it. Anna?
What?
Trinity? Oh, yes, there we go.
I'm so
Yes,
close.
you're half right.
I was.
Yeah, you're half right. So yeah, ±I. Because I is just a better way to write this right here. It's a symbol for that value. I know. Okay, all right, guys. So here, let me switch over here real quick. I'm gonna give you guys a moment to kind of get with your groups. I'll pull them up real fast just so everybody can see them.
I think grudge block questions tend to be like this.
Some of them, there was a whole spread. Some like this, some like the others.
Yeah.
Okay. All right, guys, go ahead, take a moment. Let's see. Owen, do you have your device with you today? Can you bring Riley in on an audio chat so you can hear him? And then who's my other online?
Me.
You're not online.
I'm not.
Brianna, do you mind bringing in Ruth? So it's just on Teams. I'll help you if you want, but on Teams chat, top right corner, there's a little phone call thing. All right, so you guys go ahead and get your groups.
Watch grudge.
So decide whoever, your first decision you need to make is I need to know, so you guys just have 3. So I need to know who's gonna be the writer, who's gonna be the one that tells me what the answer is, and who's the team captain. So team captain kind of makes the final call, and they are the ones that make the final call for either the taking or adding. So how the rules work is if you get an answer correct, you automatically get to have 1 X either add to your own or add to a team or take away from someone else. If you make a shot from here, you get 1 additional point. If you make a shot from here, you get 2 additional points. If If you make a shot from here, it's 5, and the last class wanted to add the 8-pointer back here.
I'll do that one.
So this will be an additional 8 points. That means if you get a question right and you also shoot from there, you can come close to knocking out a whole team in one round. The only catch is on the flip side, what you'll do is if you run out of lives, you have something that's called redemption where you cannot attack until you are back alive again, but you get double redemption. Meaning if I get a question right, I will have 2 lives that can come back. I cannot take any away. No one can take away from me if I'm dead, but you'll have a chance to kind of get back on there. So some strategize to get rid of theirs and then do the double points and just stack. So if you got to redemption and you made a double 8, that's a 16-pointer. No, because you got 2 right, so that'd be 16, 18. Distance. Questions?
That means you would have 18 lives.
Yes,
Is that right?
that's almost twice what you start with. Okay,
So you-
describe who your figure out who your captains are, figure out who your scribes are, figure out who your reporters are. I'll get you your gear.
Everyone vote me captain. Sam, do you want me to be captain? You want me to be
Yeah.
captain?
What do I do?
I would like to.
Oh, so go to chat.
Who wants me to be captain?
Type in, you guys said Ruth, right?
Be silent if you
Type
want
in
me to be
Ruth.
captain.
I don't want to be captain.
Well, too bad, that's one being free.
And then right here, and it should, yep, there's your phone call. options. Whatever you want to do. Okay, scribes. Who are my scribes? Scribe. Scribe?
No.
I'm a thrower. I'm a thrower.
You guys can switch. You can forward, Steve.
I'm the nominated thrower.
Now you're.
Okay,
I nominated myself.
scribes. I need 2 more scribes. Okay, scribe. Sorry, Grant. And Anna. Okay, so I have markers up here where your scribes, you grab these. So scribes will be the one that wrote down. Reporters are responsible for telling me. So if your reporter says one thing, but the rest of the team disagrees, I take the reporter. Captain will kind of make the last final calls. If you have 4 people, then there's a double checker. But captain is gonna, you guys have a lot of responsibility in that you get to kind of talk to your team about what you want to do up here, and then you will do the erasing or adding depending on your decision. So captains will be in charge of that.
All in favor for doing the captain?
All right, so find your captains.
I can't even call Ryan one captain.
You know, they
All right.
said actually, I said it first, so I won. I voted for myself.
All right, so this one's a little different with the fish.
Vote for
I got the fish working this time.
me.
So
Vote for Dylan.
beautiful sound effects are very hard in these animations. Okay, so every fish is a category. So what the categories are, but when you click on a fish, it'll tell you the method you should use to solve this. You kind of start figuring out which ones are for which. First order of business is we have to pick a number between 1 and 10. Those closest will be the one that goes first.
And
So,
10,
Stop, you're not the captain.
it's
3.
9, it's 9,
who are my reporters?
9.
You're not the
What are we-
captain.
I'm the captain. I nominated myself.
Who is
It's
who are my
9.
reporters in the first group?
Hey Siri, what is the number?
Xander, okay. Who is my reporter in the next group? Okay, reporter and reporter. Perfect, all right, okay. So decide in your groups what you want to do, any number between 1 and 10. If it's closest to my number, then you'll get to go first.
Oh, I just saw what he wrote. It was 5. He wrote 5.
Talk to your reporters. I only
It
listen to
was
reporters.
5. No, I saw what he wrote.
Nice, stop. No.
All
It was
right,
a 5.
Close one.
yep, all right, guys, it shouldn't take too long. Go ahead and write one down, what you guys think.
5. It was 5. I saw it. I saw it with my own eyes. I say. It's like an avid. But I didn't know they.
Reporter? Okay. Okay. Okay.
It's 5. See?
You guys get to go
Oh, you're
first.
welcome.
Hey,
All
I
right.
was closer than you.
All right, so it's a little tricky, but you gotta go do a little fishing. Who's my fisher?
Ooh.
Who's the fish?
I do.
That's
So,
a mouse.
here, let me get it on there for you.
Is that fish?
My animations. Well, it's a little easier to fish now.
Pick a red one. Pick a fish.
Pick a green one. Pick a green one.
Oh, it's like,
There are literally like 70 fish.
it's pushing.
Oh, just go ahead.
Yeah.
Yeah.
There.
It's-
I'm moving
Your
it.
fish are broken.
what-
They all died.
No, your fish.
At least they died smiling.
Here, let me see.
I don't think they can do anything about
Let me see.
Yeah, they-
What color do you guys want? I'll do it for you.
it. Okay, I want a red one.
A red one? All right, solve by factoring. So how it works is they get their first chance, but if they get it wrong, it's open to anybody else who gets it right.
Should we still do it?
Oh, yeah, I think so. Yeah, yeah.
Did you get it right?
I don't know how.
So your first step is gonna be factor. First step is set to 0, factor, and then something else. All right, yes.
I like all red.
Oh, factor would be 2x squared.
Yep, that's in.
Plus 16 and x.
That's
plus
not
48.
And your whole number.
Equals 0. Equals 0.
Yeah, I think so.
No.
What?
You have to have both answers correct for me to take it, if there are 2 answers. Yeah,
I like to use that, I think works. Clicking the dolls.
I think she can see it on her Zoom. Yeah, she can see him.
And then.
What are you guys doing?
I guess.
Wait,
I guess.
I don't.
brackets, by the way, these things that look like trees, they're brackets.
Close. All right, it's open.
No.
Does that mean that they don't get to shoot?
Correct. But nobody might get that to shoot. So let me know what you guys have.
That's
I'll
fine.
solve it up here once we're done.
That's fine.
Yeah.
I'm sorry.
Oh, yeah.
We need help.
We can't help you.
Can you give us the answer?
So let me know if you guys let's do it.
I'll put that down right.
This guy's looking.
Well,
No.
we have an answer, but.
You gotta.
Same issue, so.
So. I guess so.
So, yeah, I know what it is.
Oh.
Oh, we're
Sorry,
right.
guys, they were right. I thought it said 13. Yes, so you guys get to shoot?
Sorry, I'll work
Do we
harder
still
on my
get to
brackets.
answer one or no?
Whatever you like.
No, because I just misread theirs.
Look for the 8.
That was it?
No,
All right.
Owen's making.
8 points.
So go ahead and shoot. And then you guys will go next.
You don't get the answer.
Do a ball.
I was wrong. They wrote it right. Let's see. Reese, do you want to fish?
Oh, yeah.
Let's see.
I would
Here.
love to fish. but-
Out the way. Out the way. Move. Has anyone made it from back here though?
Only one person has tried. Corbin,
Hey,
I had a feeling this was.
yeah.
excuse me, Mr. Macbeth,
You guys.
can we shoot it from the 8 point and then just move it closer?
No. You guys don't get to shoot.
Oh, the
What team
animation,
are we?
no.
I think we get to pick next.
They get to pick next.
Why do you get another life?
Because we got it right.
We got it right.
Why do you get? Because
Okay.
got it right.
All right.
I want the red one.
Reese,
Oh.
get it. Oh.
All right, solve by completing the square.
Oh,
It's
boy,
not
I didn't
telling
do
you what
that,
method.
sorry.
What is that?
How do we erase stuff?
With your hand.
Yeah, here.
You shouldn't have done that.
I know how to do this.
You
Wait, are the R's like the same as X?
Yep.
Okay.
No, odds are radius.
But I think we should pick one.
Do
letter.
you know?
Just pick one.
Yeah, I'll give everybody a clue.
The flag.
It's this guy.
Don't give us that clue because I already knew that. So now you're just gonna pick us.
I did the same thing last class. I'll give you guys the first hand. So 0 is this.
Where'd you get that?
Just move the 82 over so you can do the 82. Put it on both sides of.
No, I'm shooting. I'm nominated to shoot. No. I'm nominated to shoot. I nominated you as. Okay, Dave.
No. Be very careful.
See, I thought I knew how to do it.
See, that's.
They get to shoot first. Oh, not shoot first. I get to see theirs first. If it's wrong, then I go. to
It is
the
wrong.
people.
It is wrong, I saw it.
First off, it's 82.
You know how to check over this.
And it has to be all correct.
Get out of
Who's
here.
my reporter?
We already wrote it.
What?
Yanni's
recording.
cheating.
We already wrote ours.
Hey, you can't cheat, buddy.
We already wrote ours.
Doesn't matter. You can go back and change it if you saw their answer.
Huh?
Okay.
No peeking.
We,
Minus points for peeking.
Yay.
Get out of here. Get out of here, Mr. Martin.
Are we trying to lose?
Shoot.
Yes.
Let's
Nice
go.
work, guys. Here is the answer, in case you're curious. -9 plus or minus I. You guys had it written as the -9 back there, totally fine. Okay, you guys go ahead and shoot. And you guys are up next.
Yeah.
My Fisher.
Do you feel confident? You can if you want. I was putting.
All right, one of you guys get fish next.
Go for like the.
Three or something. That's the.
Just three, here's one. There's three here. There's a number.
Oh, I don't know. It's 1, 2, 5, 8. 1, 2, 5, 8.
Oh, dude.
Let's make sure, yep. Oh, that was good. All right, so get, add one or take one. And you guys get to pick.
Take one of ours.
What? Yeah, gotta be good sport, but.
What can we do?
Be good sport.
Only
Take away
trying to
team
lose
ones.
points.
Take away their.
No, you're
Hey.
Those points win.
Take it away.
Hurry up, Reese.
Take it away. It's making it, by the way. I'm saying. Well, get out of the way.
Right here. Oh, nice. Solve by factoring. Switching it up a little bit. All right, so just keep it fair since I get the other ones. Factoring, set it all equal to 0. That's your first step. So if they get it wrong, opens up to everybody. Otherwise, you guys are up next. Helping on you? Be helping?
Yep, I'm doing it.
Oh, we got a red one. Really?
Welcome.
Important business.
Yoshi business.
Alright, we got first dibs if we get it wrong.
Well, it's up with anybody.
Okay, I'm just gonna keep my hand up.
Okay, you don't have to race against anyone to get the other one. If you get it right and they get it right and they get it right, you all get it.
I think, no, I don't think there's a. I don't understand.
All right, our reporter. Nice. Yes, all right, they got it. Got a stiff competition. All right, so there's the answer. You guys can go ahead and shoot, decide who wants to shoot, and then you guys are up next for fishing.
Who's up next?
You guys, far side.
You, Adam.
Who wants to fish?
Adam,
I'll fish. Who's captain? Oh, you second fishes. All right, I'll set it up for you here. I'll get the fish over. 1 sec here.
Huh? Like I said, guaranteed
You
free
should do
points.
that.
No, miss.
I believe that you can get the.
Oh, you still get to erase one or add one.
Team one, get rid of it.
What the heck? What did we ever do to you?
With this
Wow.
one, is this one over to
Team up, Adam.
Let's add.
No, they got it right.
Okay, I was just checking. I wasn't sure.
Yeah.
Yeah, everyone's reading this shit.
All teams are doing really good.
Which one is this one?
Oh, yeah.
I get one, right?
One.
Yeah.
Miss.
It is.
Yes, top buttons are quicker. All right, solve by completing the square. You guys get first dibs. Yeah, the green ones are tricky. Where are the other ones?
Are the yellow ones easy?
All I can say is that every color has its own category. So all the green ones are gonna say this.
What is this?
How do you always turn that light off? Because the outlet is so bad.
See how that needs to be put on button.
That's what's not even yet, but.
Yeah.
It's an orange.
Yeah.
Keep all the builder. Like.
I don't know.
That's tiny.
Just do it.
See, it doesn't know the outlet is so bad.
Right there.
Oh, crap.
Yeah, you should stick with 40,
Yeah, well,
I was like, this is gibberish. Okay. I guess. So you're like, it looks like math. It's solid.
Checks out, got numbers.
We got eyes, we got numbers, we got ends.
I have no comment. No comment. That's it. Nice work, guys. That was a hard one. You guys got a tough one. Here's the answer in case you guys would like to check.
Oh,
All right.
We're close. We're close. Getting close. Nah, we're close, but like.
Yeah.
I literally have
The first step
I'd say
is to
half.
move this dish. You got 5 minutes.
You can check against the young.
That's 11.
It's 11. So move everything over to one side, and then do the perfect square.
Show us the yellow one.
All right, here. All right,
Against the yeller.
let's see. Well, class is about to end here, so we'll start tomorrow. We'll do this a little bit tomorrow, not the whole time, but we'll finish the game tomorrow. So you guys will be first to go tomorrow. No homework tonight, and we'll do some more practice things of this tomorrow. Again, no quiz Friday. You guys have a good rest of your day. Sorry, so remember that you guys are first, in case I forget. You guys are first. All right. All right, you learners, have a good rest of your day. No homework tonight. All right, later, Reese. Did you bring Yoshi's to school today? Here. Someone other than Sam. I think Sam's got this. What's range? Up and down, right? That's range. Up and down. So range is up and down. Algebraically, it's what your possible answers are. So let's give them some application to this real quick. Domain would be like the amount of hours you are able to put in. Generally speaking, most people are able to put in about 40 hours a week because of other responsibilities and stuff. That would be your domain of a function. If domain of your function has to do with hours at a job, what do you think range is? No, you recant. If hours put in,
How much money you get paid?
Reese?
How much you get paid?
Yes, the dinero. That's the output. I put hours in. If I'm not getting money out, that's probably not going to mean I'm going to put too many more hours in at that location.
What did you pay to get to certain waitress job and you don't even make any tips?
Well, that wouldn't be an hourly domain then. That'd be a different situation. We're talking about hourly.
Does that ever happen?
I don't know. I've never worked at East Coast.
What's that?
That's where those jobs are. So range is how far up and down this is. So for this range right here, how low does this range go? Does it go to 0?
No.
Does it go to 1?
Yeah.
Yes, it goes to 1. So it starts at 1. So I'd say X or Y.
Why?
Y is good so long as Y is greater than or equal to 1. Okay. Now, inverse, what's your first step in solving any inverse problem that you have an equation for?
Oh,
Reese? Switch the X and Y. Perfect. You'd switch the X and Y. So in this case, I have Y equals root X minus 2 plus 1. And so now I'm going to do the little flipper. X is on the outside. Y gets trapped in the house. And then I needed to go step 2. It's my next and final mission on this. So, yep, that's right. And I'm going to isolate. My mission is to isolate Y. So I'm going to bring the 1 over.
why doesn't want any part of this? How about what to do alone in isolation?
What do I have to do next? Here. Square both sides. So X minus 1 squared equals Y minus 2. Now, your mission is what right now, generally speaking? Get the Y by itself. Do I need to FOIL this to get Y by itself?
No.
No. Yeah, you don't. That's an important note. You could FOIL it. I wouldn't mark you wrong if you FOILed it. But your mission is not FOIL and put in standard form. Your mission is get Y alone. So what should my next step be? Yes, so this right here would be X minus 2 squared plus 2 equals Y.
Why?
1, sorry. Here's for the bonus kudo points. What form is that?
What point?
Perfect squares.
Close.
Sloping.
Close.
Minus inverse.
Square.
You're in the right ballpark.
What? For me. Approximately. Math.
Y equals X minus H squared
I
plus
Plus or
see
minus?
that.
Quadratic formula.
You're in the right, you're getting closer.
Y intercept.
Rhymes with Vertex. Nice, you guys got it. Not any help. Yep, that's right. Because you guys got it. Okay, yeah, so this is Vertex form. Just to finish off some of these equations here. 7 squared, that's a toughie.
49.
Nice, 49. Little tougher, -4 cubed.
64.
Dead wrong.
Negative.
Not dead wrong. Very close.
No.
I want to give a chance for redemption. Nice work, Dylan. 3 to the power 4. Nope. 81. Yeah, good. Here's probably the most important one for today is 4 to the power of 0. Raise your hands.
Oh, I know.
Owen, haven't heard from you yet. Very close.
How is it not 0?
Anna? 1. To really push this, what's 5 to the power of 0?
1, no,
Reese?
1,
Oh, huh. What's 6 to the power of 0?
15. 1.
1.
No,
What's 1 to the power of 0? 1.
1.
Okay. Hopefully we're getting a little point there. That's one of your
I have a
properties we
question.
just briefed over.
Power of 0.
It's actually a controversial one. It's 1 over 0. We'll talk about that
Why?
in
It's
statistics.
unsolvable.
No, it's been solved. It just depends which math you're in, which is infuriating.
It's
Okay.
It's like 1 divided by 0.
No, it really just has to do with how are you thinking and using those numbers. But we'll talk about it in chapter 6. Yep. Great question. So what does a letter represent? I really like that question.
A number.
Yeah, a number. Any number?
Yeah.
Yeah, any number.
So this is a great one. What is any number to the power of 0?
1.
Good.
I have a question.
This right here, the question you just asked is actually the rule. That's the law. X to the power of 0, no matter what that number is, because X can be any number, is just going to be 1. Yes.
Negative is 1, 2.
If it counts as a number, it goes to 1. Negative counts as a number. It's a nasty fraction. Square root doesn't matter. Goes to 1.
I think we should just make every problem without 0.
I do put one that's like this really big one, but has a little 0 at the end. And so if you catch the 0, you can just be like, oh, 1. I usually make enemies on that quiz day
That's so.
because some people don't catch the 0 and they're over there just furiously.
Yeah,
All right. Okay, so here's what we got for today. I want you to pull out some paper for me. I want to talk about something that has to do with Albert Einstein.
There's the piece of paper on the outside the window. Can I use that one?
No, you're gonna want something that I'm expecting you to keep in your notes. So I need you to keep this in your notes. So piece of paper out for me.
That was funny. I thought it was pretty funny. Humor is. Humor is personal.
Okay.
Just like.
Humor is subjective.
That's racist. Whoa. People that come out, that's racist.
Okay. You guys heard of this guy?
Yeah.
Sort of.
Why was I saying is overcomer?
Yeah, he's like, get some of the light bulb or whatever.
Albert Einstein.
Oh, that was Edison.
So Albert Einstein, he has a quote, he has many quotes because he's known as kind of being in the geek, yes, among other things. One of the greatest minds of our time. Him and Newton are definitely up there. So Albert Einstein said this. And you don't have to write this down. This just sets the precedence for what we are going to talk about here really well. So if you want to just listen, that's fine. If you want to write it down, this is great. But here's what he said. Let me do this in dark so it shows up really well. Let's not maybe interrupt. So Albert Einstein has to do with this. So Albert Einstein says that compound interest is the eighth wonder of the world. There's two parts to it. Here's the second part. That's the second part. So I think the interesting part. Those who understand it earn it.
I thought it was going to say, are the night.
Those, hey guys, this is kind of last chance talking while I'm talking. No more, okay? Those who don't pay it. What's this saying? I know you don't know compound interest yet, but just generally speaking, what's going on here? Yeah, tell me what you think.
If you understand it, then you get money. If you don't, you pay money.
Right. If you understand it, you're going to be the one who earns it. If you don't, then you're going to be the one that pays it. Let me give you some numbers. Okay, these are numbers pulled from 2021.
from Washington State specifically. So in Washington State, the average, let's say, school debt, and this is not graduates, this is from 18 till death, is $24,000. So people at the end of their life are still paying off school debt. The average car loan is around $8K. The average credit card debt, which I thought was a little smaller than I expected, was around $4,500. And then home loan actually was about $54,000. This is the average debt here. So there's a lot of other debts that people take loans out for. So they take loans out for either like refis or purchasing a boat or something like that. In America, the average debt nationwide from ages 18 to the end of life is $90,000.
Low.
Yes. Yeah, he's been in and out several times. Yeah. So $90,000 is the average debt of the US.
Wow.
Who do you think we are?
We're the paying.
Are we paying or are we earning?
Oh, we're the.
Hey,
Yeah, it's not saying, does not mean that people have 90 grand in their bank account. That means they have debt unpaid on average, those who are just graduated to those who are at the peak of their careers of $90,000. Let's take this further.
Take Adam and Ruth with me here. Let's do a little tiny survey. This is fun. And Sam, unfortunately, you can't participate in this one. But hang tight, you can participate in the next one.
Yes.
So it's not your fault, it's my fault. But I want to talk to you about some numbers that we talk about all the time, but we actually are a little mysterious to us. The first one, not too mysterious. First one is 1,000. Okay, we've probably seen 1,000 before. We probably are comfortable working with 1,000. The next one is 1 million. Okay, one we've also heard of. The next one is 1 billion. And then the last one is 1 trillion, right? So these are numbers that are common language to us and ones that our brains often kind of work with. We either hear it in the news, we hear about people's success, Elon Musk, whoever it might be, like millionaires, billionaires, no trillionaires yet. But we do hear these other numbers here. Let's say we want to talk about this in terms of seconds. No calculators. How long is 1,000 seconds? And 1,000 seconds is not a valid answer.
I know,
How long?
it's 10 minutes and 40 seconds.
Okay, 10 minutes, 40 seconds. 10 minutes, 40 seconds. Another guesses. Let's just do some guesses.
I know I
No,
was
that's not
way
right.
under.
I'm not telling you. I'm just saying, let's see. I want to hear from you guys.
No, it's 15 minutes
Other
and
people.
40 seconds.
Other people.
Keep it
Yes.
15 minutes and 40 seconds.
All right, 15 minutes, 40 seconds. What's another guess? Just ballpark. No wrong answer. Let's be brave here. Or I can start calling. But just give me some guesses. Well, how long is 1,000 seconds?
I got it right.
Sander? 30 minutes? I like it. Oh, 13. I like it. Okay, give me just a couple more because we don't have just a data collection here. Dylan, 78 minutes?
17.
Oh, 17. Got it. Oh, and you had one?
Probably around 8 minutes.
8 minutes. These are
Not
all great
8.
guesses.
A
Let's
year.
jump it up. 1 million seconds.
A year.
1 year. All right.
No, it's
So 1,000 to 1 million goes from 10 minutes to a year. Yes, another guess?
I would say,
it's 1 week.
Hey, let's not interrupt. Thank you. Yes, what was it, Reese?
2.5 months.
2.5 months. So 2.5 months. Yanni, did you have something to share?
2 days.
2 days? Oh, we got quite a spread. I like this. Yeah, Dylan?
5 days.
5 days. Got it. Let's take just like 1 or 2 more. What do we think? Anna or Brianna, do you have any free guesses up there? Riley, you got one? 2 weeks? Ah, gosh, also great
Are you gonna
guesses.
tell us?
Oh,
For sure.
I know.
So I'm gonna give you context of why we're even talking about these numbers.
2 days, 4 hours.
2 days, 4 hours. Xander.
1 week and 4 days.
Ooh, I like that. 1 week, 4 days. Those are pretty close ones there. Okay, let's take it up a notch. Billion. Yes, this is 1 billion seconds. So if you're counting like 1, 2, 3, 4, 5, 6, 7, 8, how long would it take you to count to 1 billion if it's 1 second for every number?
5 months.
5 months. Okay, 3
3 months and 17 days.
3 months and 17 days. I like the specificity here. Reese? 50 years. All right, I love it. Yanni?
2 years and 3 months.
It would take, so if I asked you to count to 1 billion, you'd be here for 2 years. All righty,
No, and 4 months. 3 months. 3 months.
okay, Bo?
49 years.
49 years. All right. So if I said, Bo, start counting to 1 billion, I'd probably see you when I'm hopefully retired. Xander?
4 months, days, and 2 hours.
4 months, what was it?
6 days, 2 hours.
6 days, 2 hours. Okay, last one. Trillion.
133 years.
Okay, let's do one at a time. Raise the hands here. What would you say, Bo?
133 years.
Oh.
133.
Mr.
I'll get to you. 75 years?
Mr. McBeth.
Yes.
I meant to put a different one for the 2 years and 3 months. I meant to put 2,400 hours
It has to be in the appropriate units.
in the appropriate unit.
Yeah, so if you have more than 24 hours, it should be in days.
Okay, so 60 years.
So 60 years for it, take you 6 years to count to 1 billion?
Yeah, 6 years.
6 or 60?
6.
Okay, gotcha.
Can I
Big
guess for the
difference.
billion?
Let's go on to trillion here. You got trillion ones, let me know. Reese?
Let's go to like 200.
200
Yeah.
years?
Yeah.
All right, 200 years.
I know.
Xander,
1 year.
1 year?
Yeah.
All right, I'll take 1 year to count to 1 trillion.
Wait, what is 133?
Years.
Yeah, someone gets 133 years. So if you had to count to 1 trillion, it took you 1 second for every number, you'd be probably not alive. But maybe you could break the world record for oldest person. Riley? 25,000 years. 25,000 years. Nice. All right, then we'd be the dinosaurs, right? Yeah,
I'll say you have 25.
okay, followed up by 25 years. Okay, I'll take Yanni and then one more and we'll cut it.
6,000 years.
6,000 years. Okay, all right, one more.
33 years.
33 years. Okay, make sure I get this exactly right. Let me give you some context of why we're even talking about this. So, excuse me, Yosh. US debt. Anybody keep up with this? What US debt was last year?
Oh, it was a 21 trillion last year, and it's 30 now, I think.
Yeah, you're in the ballpark. The end of last year was, so started last year. So the end of last year, we were at 28.43 trillion. So you're right. That was the end of 2021, according to the US Bureau of Statistics. So to give you a little context of this number, that's 2843. It's that number,
A lot of numbers.
right? Right, it is a lot of numbers. So let's put some context to this number. This right here, it's about 14 minutes. Fantastic. You guys are all in the ballpark there. 1 million, make sure I get this exactly right here. 1 million seconds.
2 days and 4 hours. No.
So 1 million seconds is 11 days.
Oh, dang it.
And
Oh, somebody got
about
it right.
13 hours.
Somebody got it right. 1 week and 4 days.
Johnny, remember the interrupting thing?
1 week, 4 days.
So we have 11 days and 13 hours. Yeah, that was Xander's guess. Now we have billions. So billions is our closest here. I think this is our closest. Billions is 31.5 years. So if you counted numbers at 1 per second, it would take you 31.5 years. It's gonna be way older than me to do that. A trillion.
Can I take another guess now?
31,000.
I think it's gonna be
31,000.
So a trillion is 31,688 years.
wow.
That's 1 trillion. 28 trillion is our debt. Who do you think we understand better? Those that earn or those that pay? Those that pay. Our government down to our people in that government, our citizens. I mean, led by example, this is the type of debt we're in. And compound interest actually comes from one of the tiniest, simplest equations in mathematics that is overlooked, misconstrued, and deceivably portrayed to you in many different ways. Things like 7% car loan, 3% down payment, 3% interest. Numbers that are very small. I tell you, bought a house this last year, 3% is hundreds of thousands of dollars that you will pay the bank just for letting them borrow your money. These little numbers right here, they rely on you not knowing this concept. Because if you know it, you earn it. If you don't, you pay it. And Dylan, question?
Do you know like the average US debt, whatever, for the other categories?
I don't. I know this is Washington. I know this is national for all categories. That's all I know. So let me show you this equation. I'll let you write this down. So the equation that models all of these things is just this little guy right here. And you'd be expected to memorize this. So this is called an exponential equation. And it is just y equals a b x. That little guy right there, we'll expand upon it. But in essence, this little guy right here determines growth of all living things, the spread of all viruses, the investments of all money, and the debt of all the world. Can be modeled by some modification of this little fella right here. And people don't get it. So let me break this down a little bit for you. A, this right here stands for your starting amount. So let's say I had $500. I want to invest in the stock market. 500 would go right there. B, this is going to be your growth rate. And you're also expected to know these as well. So I would recommend writing them down. This is your growth rate. This is how quickly things are growing for you. X. Yeah, X in most applications, X universally is either time or events. So this will be time or events. Essentially, it's what you put in. So if I'm putting hours into my work, if I'm spending days watching the news about things spreading, if I am investing a certain amount of money each day into a college fund, this is the time at which that took place. And the last one right here, this right here is your result. Whether it's how much debt, whether it's how many rabbits, whether it's how many much money I owe or I have, this is the result. So this right here, this exponential equation can be modeled by finding out actual data in the world. Let me give you another example. And Sam, feel free to jump in on this one. This is the second example I was talking about. You guys familiar with the chessboard?
Yeah.
How many rows are in a chessboard? 8. How many columns? 8. Yeah, so I have 8 by 8, right? And just to kind of really, I'll do the first few. So 1, 2, 3, 4, 5, 6, 7. All right, so I have a chessboard. Let's say I have this really cool machine that kind of puts 1 penny on day 1. So I got 1 cent. Like, woo, 1 penny. Day 2, I have 2 cents.
10, 4,
Yeah. And I have 4 cents.
8 cents,
And I have 8 cents.
16 cents.
I have 16 cents. And let's kind of stop there for a second. So I have this board that's going through and it's giving me cents. So how much money will I have by the end of the first row? How much money will I have at the end of the first row?
$1.28.
Good, nice mental math, guys. So I'll have $1.28. All right, so this is, you guys seen this on TikTok? I know it was going around there. You have? All right, if you've seen it, just hold on for a second. So I'm curious then, if we continue this pattern, how much money would you have right here?
It's like 100 million.
100 million. All right. So you have $100 million.
Is that right?
I'm not gonna tell you. Dylan, have you seen the answer?
Yeah.
I'm gonna have you hold on.
It's like 58 million.
58 million. That'd be awesome. I would love $58 million. I don't know about you. I don't know if that's wrong to say, but I would not complain if someone's like here. I'm like, oh, okay,
Thanks.
Maybe
Yeah.
Keep that in mind.
yeah, okay. If you have 58 million to spare, Yanni, I would appreciate that. Should I
All
say,
you have
Mr.
to
Martin?
do is watch all of my pro tennis matches.
That's it?
Yep.
Done. Any other guesses? Throw some guesses out there. Pennies by the first row at $128. Let me give 3 more guesses. How much money would you have, do you think? Ballpark it.
10 million.
10 million. What was the other one?
5.
5 million. 5 million.
-1/12.
So you'd lose money? You've dipped into a whole different can of worms by saying that. I'm not trying to break brains today.
Break
Uh,
us.
No, you're not that. It's not for today.
And,
That one's for after break. Let me get one more. How much money would you have?
8 trillion.
8 trillion?
Yep.
That's quite a bit. So you'd be able to pay off, what was that, a fourth of the debt?
Yep.
You'd be a national hero.
You would be.
Except that they'd get the
Would
next
they
year.
give
put us
me
right
the
back
White
in the
House if
same
I did
debt.
that?
I don't know.
Wouldn't they just like-
I
That's
sup-
only 8 billion.
I'm sure they invite you to the White.
Okay. All right. So let's do a few things that are really good ways of problem solving, not specific to mathematics, but can apply to mathematics. First is called the brute force. Brute force is basically step by step. We did that. 1, 2, 4, 8, 16. Some of you guys did it mentally, 32, 64, 128. I don't know if you guys have played 2048, but this is really handy for that first row. So this right here, that's called brute force. And so if I wanted to figure out this one using brute force, what would I have to do?
Go through the whole thing.
Yeah, I'd have to do this 64 times, which doesn't sound fun to me. I don't know about you. I could do it. You would get the right answer if you didn't make any arithmetic errors. That's brute force. Brute force is really good for figuring out simple examples. So after you do brute force, there's something called base case. Base case, what this does is it establishes a pattern. What pattern do you see happening between squares here?
Double.
It's doubling. Okay, it's good. So it's doubling. So right here, let me write this out. This is doubling. All right. What did I start with?
1 penny.
I started with 1 penny. Okay. How does this apply to our equation? What's my A?
You can go.
Okay, so my A is 1. Anybody have a thought on what B is?
Yeah,
B
8.
is
What was it?
8.
Close?
2.
2. Yes.
That's not close.
It's a lot closer than 8 trillion to 2. So it's relatively close. Single digits.
1 time be 64.
Let's try it out.
Be 8.
So if I put in a 64 here, how will I know if I'm right or wrong?
It's just one of the whole thing.
Yeah, I'd have to do the brute force thing. Is there a way I can test run my equation where I can figure out if it works or not before going to the big guy?
Google.
Riley?
1 times 2 is 2. So that would be the next box is 2. So you can figure that out.
Yeah, that's exactly what you can do. Test one of the numbers you are for sure. Are we sure that this number is 2 if I'm doubling? We sure this number is 4? We sure this number is 8? Okay, so we had an idea of putting 64 in here, right? So if I'm putting 64 in for the last one, what should I put in for the second one? Yeah. 2, right? If I put 64 for the 64th square, my theory then should still hold if I put 2 for the second square. So let's put 2 in. What's 2 squared?
4.
Okay, so this equals 4. Is this 4?
No.
No.
Shoot.
You only gotta do 1.
What was that?
You only have to do 1.
Well, I know that I'm off. So it didn't work for this one, so why would it work for any of them? Do we have a 4 anywhere?
Yeah.
And the third square.
Yeah, it's right here. So the 2 is what box?
It's
Second box.
Okay, so then let's try,
Oh, it's-
what if I put a 3 in here? What's 2 cubed?
8. No, not 8.
8.
It is 8.
It's 8, right?
Is it? Okay.
Yeah. What box is this?
That's 4.
It's the 4th box. Okay, so how far am I off on boxes? I'm 1, so what should I put in here?
65.
63.
Yes.
What?
Yep, so the third one gave me the 4th box, so it's a 63rd. So your formula is going to be x minus 1 box, as I'm 1
Oh,
off.
I was listening to this one.
So let's figure this out. Let's see how we did. I'm gonna put a number up here. Unfortunately, I have to use a special calculator for this because Google can't even handle it. Let me see, where did I put this?
Why is that unfortunate?
Why is what unfortunate?
Be able to break Google.
It's not, no, it's not breaking it. It just gives you an abbreviation. I don't want an abbreviation.
Like smashing your computer.
No, because it still works, it just abbreviates. So let me pull up this computer real quick here. This is a language called Python. It deals with really big numbers and it really helps us with these things. So if I have 2 and I want to raise it to what power?
You did 2 multiplies.
I know, that's how you do squared in Python. So multiply is squared. Can someone read me that number? If I raise it? I see one person. Owen, you got it?
4, 6, 1, 1, 6, 8, 6, 0, 1, 8, 4, 2, 7, 3, 8, 7, 9, 0, 4.
Okay, that is how many pennies I will have right here. So we want to know, let's put it in dollar form, right? And so here's my dollar form. So 100,000, million, billion, trillion,
Quintillion.
quadrillion.
Quadrillion. That's one off.
So $46 quadrillion. That is how much you would have in money if you just doubled your pennies every day. Sam?
Why did you do times 62, not 63?
Oh, I just this typo.
Oh, darn.
Shoot.
Oh, come on.
Oh no, so it's gonna be even bigger.
Can I read it?
Yeah, give it to me one more time here.
That was-
Let me do this real quick. So I'll do share, this one, advanced. It's not gonna.
You know that Disney owns GoPro?
Makes me miss my GoPro.
Did you know that it's fun to look up things out of Joey?
So, yeah, let's see, someone, Reese, you got it for me? I guess I could just do it then, huh? Okay, so I have 9222337203685477508. So here's my number. I'll zoom out a little bit on this guy. So if I'm going in dollars, I have 100,000, millions, billions, trillions, quadrillions. So I have 92 quadrillion dollars. Close. I'm doing this to prove a point. The numbers that you saw in debt, so you have 3, 6, 9, 12. So you have 3, 6, 9, 12. So you're about close, yes, but I'd say quite a few digits off still. So you are the closest, so you get that award. So this right here is how much money I'd have just filling up a chessboard with pennies, our smallest measure of money. I'm doing this to prove a point. Mathematics isn't a discipline. It's a human sense. It's a human sense that us as Americans are doing really bad at. And there's certain people that are getting this sense that are doing really well with it. This unit right here, I love this unit because as you see, logic that comes stock is not enough. Mathematical sense must be developed. Otherwise, you're going to be in the pay it crew. If you understand mathematics, especially in the sense of the world around you, and especially with money, then you're in the earn it crew. Statistically, we're in the pay it crew. And in Washington, we're actually 48th in the nation in the pay it crew. We have some of the worst math scores that we have that are out there. We're 48th. I think there's just a few states that beat us. We're third in the nation for having the best math jobs in both finances and tech. So when we go through, we learn some of these things. I want to show you how to break down these patterns and how even our most extravagant guesses are still quite off from the actual numbers of reality of what exists in things today. So I want to go through this unit, and I want to show you some things that happened in the world that people thought weren't a big deal that became a big deal. Things like Scotch broom, sparrows, rabbits, things that altered ecosystems and put nations in desperate need of UN intervention. All because people misunderstood this. Today, we have the same crisis. We don't understand this because people are throwing money out when we don't quite get it. I'll show you how to make tens of thousands of dollars by the time you're 50 with doing no work except maybe for getting a few Starbucks each week. And people don't do that because they think, oh, what's $3 here? What's $5 there? It's 50 grand. It's 50 grand that you could earn. It's what costs you maybe 4 grand over 8 years could be $50,000 by the time you retire. We're doing nothing but avoiding a little comfort, but we don't get it. And so I hope after this unit, we'll start to get it. We'll start to get that these simple things, as Albert Einstein said, is the eighth wonder of the world that earns for those who get it, that pays for those who don't get it have to pay.
This right here,
Recording in progress.
we want to get more comfortable with these guys. They're very weird. But these right here, these are the basis for actually what a lot of financial institutions uses. And so at the end of this unit, we're gonna be doing a lot of talk about kind of the deception that financial markets do to people. Like they bank on you not understanding math. For example, I went to buy my house and they're like, hey, we'll give you a loan for 3%. 3%, that sounds great, right?
No.
Do you know what 3% cost me? $180,000. That's how much I paid for my loan. And people do that all the time. Now, so when they go to have a car loan, like, hey, we'll do 7% down or 2% down. They're not really telling you like, hey, if you buy this $14,000 car, we're gonna charge you an extra $10,000. That's what those percents are. And these weird little things are actually the models for all the financial stuff. So if you go into loans, if you go into the house, if you do investments, if you understand the stuff that's behind the numbers, it's gonna change how you make decisions.
1,000%. So 2% of what your house costs, 180,000.
Well, so every month that I don't pay off the whole thing, it builds interest. So I have to pay off a little more. It is not a mansion. It is not a mansion.
So like this stuff is actually like, we're actually going to use this in real life.
I hope that you look at loans and stuff by the end of the unit a little differently. Because when I was in college, I was like, sure, I'll take out a 3% loan and 2% loan here. And it cost me a lot of money. So
So what's a good percent?
3 is actually a good percent. 7's bad. So 3%, that was very low. It's about to go up again
All
right
right, so
now. No percent is the best. If you pay cash, you're ahead of the game. That's really hard to get there.
3% of $180,000 of 3% is only like 5.4 million.
So how the percentage works is every year I don't pay off my loan, more interest gets put on it. That's why it takes so long. If I paid my loan off today, I would have no interest.
I think
Like if
that-
I had $400,000 just fall into my lap, then I would have no interest to pay. But it's going to take me 30 years to pay that off. So, okay, so let's kind of dive in here. I want to show you just a little bit of why I think that I wish I learned that when I was in college about the deception of loans and debt and interest, because they use those little numbers on purpose. No dealership says, hey, we'll sell you this $15,000 car for $10,000 more for finance. No one. But that's how all of them work. And so I'm hoping that we can kind of digress that a little bit. But first, we want to get through the basic properties of this. Yanni?
Well, maybe one that got bankrupt might have.
Maybe. Okay, so these right here, they have the same base. Bring it. So these have the same base. If they have the same base, what do you do to the exponents? Add them. Good. Yes. So you add them. So I have 1/3 plus 4/3. So I have 2x to the 5/3. Is
One
that?
can go free.
Hey guys, let's dial it in, please. Let's show me that this is a good arrangement for seating. All right.
One can go free.
Yep.
That's right.
Two stay over.
So here, another way to write this, you don't have to show this step. I think some of you guys are beyond this step, but you can if you like. I just want to show you my thinking is I have one group of 3 that gets out, and then I have one group of 3 that has to stay in, and it's 2 of the 3. And so my final answer would be what?
2x and then cube root 2x squared.
Good. Yeah, you could write it in cube root or this. It doesn't specify. So if I wrote just this, or if you wrote it the other way, 2x, and then this would be cube root 2x squared, that would be fine too. Both those are okay. Since it didn't specify which one, either of these for final answer would work.
Does it matter if you don't put the parentheses?
It does, yes. So why do I have to have these parentheses here? Yes, work with, yes. So you know that it's not just going to the x. This affects the 2 and the x, and so that needs to be consistent with your final answer.
So
But then-
just put 4x squared and no parentheses.
Yeah, you could. Yeah. So then to go further, this would be cube root 4x squared. Yeah, that'd be fine too. Okay, this one right here, simplify the expression below. Yanni?
1/9, 1 half.
Ah, good. Yeah, so what do I do with these exponents? It's good, we can go further actually, but I like what you said there.
And then that.
Wait,
and then it could
doesn't
be
that just
3.
square root to 3?
1/3.
So this right here, if I did this subtraction, this would equal 9 to the -2/4.
That's not what I did.
So I said 7 minus 9, that's 2. Don't change the fours. Now, 2/4. Right, that'd be -1/2. That's right. So this is -1/2. Let's break this apart real quick. What does the 1/2 really mean?
Next.
Should he?
1/9.
Yeah, so the negative causes a flip, and then the 1/2, that is the square root. So negatives are flipper. So it's oddly probably one of the most missed rules of the exponents through this and pre-calculus. That negative, it's not a negative. In the world of exponents, they play by a little bit different rules. So this is called the inverse. So this would be 1/9 to the 1/2. What's that 1/2 mean?
Squared.
Close.
What?
Square root? Is that what you meant?
Yeah.
Okay, yeah, square root, squared.
I meant square root.
Okay, then you're right then. So this would just be 1/3. That would be our guy.
I didn't do it that way.
Did you get 1/3?
Yeah.
How'd you
I
do
did- I never did the negatives.
Oh, you left it down below.
Yeah,
You
That works.
just did
because I just got rid of the top and just made it 1 and then made 9 and then 2.
That works. Nice. Yeah, you can keep it down below. If you recognize this is going to be a negative and you want to jump to this being underneath, that's totally fine.
7 minus
All
9
right,
is -2.
let's go through a few of these. So I just want to do a few more of what I found to be kind of tricky examples going over these. And see if I'll do a few, I'll have you do a few. We'll kind of rinse and repeat. And then see if we can kind of go from there. So for the first one here, so radical form, just make sure we got this down. What is this in radical form? Yeah, I'll give you a
Oh,
hint.
I know what it is. It's A.
Oh,
A,
yes.
and
One on the
then the
outside and
N.
on the
All right, guys, let's
inside.
raise our hands here.
N is on the outside.
Yanni,
N is on the outside.
good. And then A, technically the one's right there, but you don't need to write that. Now we've developed that a little bit to say that, hey, this top one is what? It's the power, right? It's the exponent. So this right here, this is your power. And then what's the bottom one always? The root. Good. Yes, this is the root. In other words, it's a value for the index. So this N was always going to be the index in this A. And just to kind of get you familiar, if I did this like this, that's the exact same thing. And I'll prove it to you. We've done some examples where I've shown you an easy way and a hard way to do things. So for example, if I had 9/3/2, there's an easy way and a hard way to do it. Hard way is to start with the top. What's that top number mean?
How many people are trying to get through the door?
Yeah, right. I like that. Yeah. Mathematically, what is that top number?
Power.
It's the power, right? So I have 9 cubed. I don't know about you, but that's kind of a tough one to do mentally. I only, what is it?
It's 200, 780.
Close. I believe it's
790.
729, I believe. But that's, so I have 729, right? So then I have 729. And what does, I used up the 3, so now I just have the 2 down below. What's that 2 down below mean? Yeah, it's the square root, right? What's the square root of 729? Really tough, right? I'm doing this on purpose. This is the hard way. So it actually is 27. Now, let's do that whole thing again, except let's do it the easy way. So same thing, except I'm going to start on the bottom. What's that 2 represent?
Square rooted.
Square rooted, right? What's the square root of 9? Okay. What's 3 cubed? 27, right? So it doesn't matter if I start at the top or the bottom. You're just going to have a harder way if you start with the top. That's why this right here doesn't matter if it's on the inside or the outside, because it doesn't matter which one you do first. It's just if you start on the top, you're going to have really big numbers that get small. If you start on the bottom, you have numbers that get really tiny and then maybe a little bit bigger. So I always recommend starting at the bottom. It's nice, quick, mental math. Questions on that?
What? I was not.
We'll circle back. Like from the beginning of this.
I paid attention to that and then stopped paying attention when you finished writing the M on the outside.
Oh, okay, so from here down,
Yeah.
got it. Okay, here's the gist of it. Start in the bottom. Dylan, you start in the bottom. That just means square
Oh,
root.
right, work your way down and then back up.
Yes, that's the gist. Okay, let's do just a few of these here. So we want to write these in radical form, simplify if needed. I'm going to skip down to just, we're not going to do all these. So the 5 right here,
Easy.
I want to know, is this an improper fraction?
Yes, it is.
It is.
There's
So what does that
3K.
mean? Wait, raise your hands, guys. Raise your hands here. I heard a really good analogy at a teacher training that said, if you had ice cream and you're really excited about that ice cream and you had it in your hand and someone came and grabbed that ice cream from you, how would you feel?
I would be happy because that means that I wouldn't get unfit.
Well, and they said, well, that's what it's like to interrupt other people is just taking their ice cream. So let's not be ice cream stealers. Stop taking people's ice cream. That's the moral of the story.
So
Sam.
I'm making.
You can take 3 Ks out and it leaves 1 left over.
Good. Yes. Yeah, you got these. So these right here, essentially, I need to know how many groups of 2 can I take out of 7? So I have 7 people, but you only can leave in groups of 2. So one way to write this is I'd have, okay, K to the 6/2, and then K to the 1/2. Why would I choose 6/2?
Easy.
Yeah, because it simplifies to the whole number. That's what I want to do. And so this ended up being just K cubed, K to the 1/2. But is that the form I wanted in?
No.
Oh, what do I want it in?
You want the radical one, so it's with the square root symbol.
Good. That would be your final answer there. All right, let's try a few of these. Let's see here. Let's try 6. So real quick, with 6, well, no, let's do a variable. Sorry, let's do 7. Sorry if you started 6. So 7, right here. You guys got questions? Is this an improper fraction? No. Okay, right. So nobody gets out, unfortunately. So then what do I need to do for my last step?
You just put it in the radical.
Yep, you just put it in the radical form. Which one's the power? Good. So then I have 4th root, A, B, 3.
That's it.
I did something wrong.
What?
What have I
The
done?
parentheses.
Parentheses, good. I do that on purpose because those are the most common mistakes I see. So yeah, don't forget parentheses, very important because A, B both are affected by that cube. So you want to make sure that's true here. Without parentheses, only the B got the 3. Okay, let's do this next one here. This is a number, it's mixed. So I'm showing you these ways, but notice that there's a lot of ways to do it. You could convert to radical first, then do some work, or you could do some work, then convert. It's totally up to you. So I'm kind of trying to do a mix of them. So here, this 2/3, what would you want to do? Any thoughts on what you could do here? You could write in radical form. Yeah, let's take a look. So then I have cube root, and then I have -6 x parentheses squared. What's something else you'd want to do? If there's anything else to do. Good. Everybody gets the 2. So that just means -6x squared. Good, yes. So I have 36x squared, and I think that would be the simplest form we could do it in. All right. Let's talk about number 9 then, and then we'll switch gears and go different directions. What would you want to do here first? So we could keep it in this form, then switch it, or we could switch forms. And I'm really comfortable with you doing either. It's going to be weeks before we get to just this form. So feel free to kind of bounce back and forth to where you think best.
Oh, I have no.
Yeah.
Can you show us how to do 6 though?
Yeah, after this.
No, I meant after.
Oh, sweet. I could. I just have to do PEMDAS, unfortunately. So
Sir,
I know,
do
gross.
You multiplied 7 last.
Yes, so parentheses first, nothing I can do in the parentheses, exponents next, so I have to do exponents, then multiplication. So exponent's gonna be taken care of first. So what I might want to do is I have 7, then I have root 12w. There's actually not too much else to do after this, but there is one thing. Actually, we'd be okay because they're both to the power 1. Good thought. Anything else I could do here?
Wait, why is it 7 on the outside, not 2? Square root of 12.
All I've done so far, I just rewrote this in a different form. What was that, Adam?
Square root of
I
12.
know.
Square the 12?
Square root, yeah, that's square root.
Take a 4 out.
Yes, I think that's what you're saying. I'm not sure. So your next step would be, I know that there's a 4 in 12, so I can take that 4 out because 4 times 3 is 12. What's square root of 4? 2. All right, square root of 4 is 2, and 2 times 7?
14.
Yes, that's right. So this would be 14 root 3w. That would be your final answer for this one. All right, let's switch gears a little bit. Let me know if you have questions. Reese? Yes, I can. Oh, Sam requested this one. Questions before I do this one? Okay, so I have 3 to the 5/4.
So 1 can come out.
Yeah. Good. So if I wanted to rewrite this before switching it, I'd say 3 to the 4/4 times 3 to the 1/4. Yeah, 4 over 4 is just 3. And then this would need to be in radical form, so I just would 4th root it.
4 by 4. Why did I put it 2?
I just do 4 just because that's the bottom number. That's all.
Why did I take out?
I don't know. That's not one I can answer. Okay, switching gears a little bit for me, guys.
How would you write it in a non-radical form?
So in exponential form, if I want to do that, you could just do 3 times 3 to the 1/4. Okay, so I have, let's do a few switches here. So this first one, so cubes, that's something that we haven't done a lot of work with, is cubes. So what's the example of, because it's square roots, we wanted to do square numbers, 4, 9, 16, 25. Those are really handy. We took out that 4 and that square root of 12. In cube roots, we want to take out cubes. What's an example of a cubed number specifically? What was it? Good, 8. I like that. What's another one? Good, it's 27. Okay. Close. It has to be 3 numbers. So 3 times 3 times 3. A little bigger than 9. What was it? 64? Yes, nice.
8. How was 8? 125.
So this is 2 times 2 times 2, 3 times 3 times 3, and 4 times 4 times 4. You won't need to go bigger than that to really check things. But the reason I'm bringing this up is my first problem, 10, that's a cube root. Is there any 64s in 16? Any 27s? Any 8s? Yes, and so it's the same pattern as before. We pull those apart just like we did with square roots.
That leaves
Oh, I did not like that. That was odd.
Yeah, so 8 times 2, that's 16. So all I did was I pulled those apart. What is the cube root of 8?
2.
Good. Yeah, it's 2. The root of this. So 2 to the power of 3 is 8, and reverse that is the cube root it. So this would just be 2. But then I need to write this in exponential form. What would that be?
2, 1 over 3.
Perfect. Nice work, Reese. Okay.
Supposed to raise our hands, but Sorry.
Oh, yes, you're right. I'll need to enforce that more. Reese.
2, 1 over 3.
Nice. Way to not steal ice cream.
Um,
Okay.
I already spelled it, so you
Fourth
can't
root.
see anymore.
4th root. What's an example of a number that's a 4th?
5th.
16.
Yeah, 16. I would say we don't need to go bigger than that. Is 16 inside 8?
No.
No.
I can't. Well, yeah, the reverse is true, but so that means that I don't need to do anything here, but just write it in exponential form. What would that be?
So that would be
Let's raise your hands, Sam.
8 and then 1 over 4. 8w 1 over 4.
Nice, like this? I'm wrong.
Parentheses.
Yes, there we go, good.
Sorry for saying
Yes, I need to be better at that too. Okay, let me do just a couple more here and then we'll switch over to, oh, we got lots of time.
I think we should switch over to. What is?
11 is just 1/2. It's that guy. 13. So there's a couple ways to do 13. You can go right in, start multiplying and try to find cube roots. I think finding cube roots in numbers like 121 is kind of tough. It takes some time. So there's an easier way to do it. This is kind of why we're learning this new notation, is because I can do this without ever having to square 11. Trinity, what do you think?
11, 2 over 3.
Yeah, so I have 11, 2 over 3. And do any of those get out? All right, so now you know that none could get out. There's no cube roots in 121. Then you would have, you would show it in the math there.
Wait, but weren't you just, what were we talking about where you cube it and then square root it? Like what you did on the side if you scroll up.
Oh, so if they wanted us to solve this or do more than just write an exponential form, then you could cube root it and square it and cube root it, but that's just gonna, there's not gonna be anything nice there. Yeah, so that would be it for that one. Do any K's get out here? Let's see if we can kind of skip to the step where we just write the answer. How many K's get out?
One.
Good. How come?
Because it's a 5 over 4.
Good. So I know that 1 gets out. How many stay?
1 and 1.
Good. And what do I write in that exponent? Reese?
1 over 4. Oh, shoot, I'm sorry.
Yes, 1 over 4. All right. Try 15. We're gonna do 15 through 18, then we're gonna do the game. So if you get done with 15, go ahead and move on to the next one. Or if you get stuck on there and I can't get to you yet, I want to help you guys kind of one-on-one to see if we have some questions here on this one.
So you leave us with the hardest 4 questions.
I'm gonna circle back, but if 15 is not that bad.
It's already.
I mean,
16 is kind of rough, but I'm gonna help you. So 15 at least. If I don't get to you by 15, go ahead and work on the next few, but then we'll do these all together.
It has 3 numbers.
I'm stuck.
Yeah.
We just go through these. Okay, we'll try this again. Are we okay with the 15 part though?
No.
No.
How would you write this in exponential form? I think you're overthinking it.
3 and 7 2. 7 over 2.
What?
So I have 3m
Where are you getting this? Huh?
Oh, because it's squared into 2.
because there's technically a 2 right there. So I have 7 over 2.
Oh,
Do any of those get out? How many?
3.
3.
wait.
Yes.
Wait.
Question, Reese?
Then what's the difference with the whole thing being to the power of 7, but then just the parentheses with the 3 in it?
I mean, what's the difference between this on the outside or this on the inside?
Yeah.
None.
Oh, so just.
Oh. That would have been nice to me.
Well, he actually showed us that.
Oh, well,
It's okay.
Sorry, I wasn't.
It's okay.
Okay, call on.
Yes.
Would it be? Would you simplify to 6 over 2 and 1/2 because it's just 3?
Yes.
Would you do that every time it's 7 over 2 or anything that's simplified? to not be 1 over 2?
Anytime it's improper. Yes. You just got it. That's the whole idea.
So.
That's it. The whole enchilada with a few variations. So first step here is I'd say, okay, I want to divvy out all my 6 over 2 pieces. Why'd I choose 6?
Because that's what's left.
That's what simplifies, right? And then one guy, he doesn't get out. The 1 over 3 or 1 over 2 there. Because I have a total of 7. 6 over 2 get out. So this would be 3m cubed.
Okay.
And then this would be 3m 1/2. Now, can I do anything more on this side?
Yes.
Yes.
What can I do?
You can-
I can cube 3. That's right. So this, you could write it as 27m cubed times 3m to the 1/2. All right, let's try, maybe let's do these all together, huh?
Yeah, I think I got 16.
You guys want to try 16?
Yeah.
Okay, try 16 for me. I'll come around and help you guys and we'll reconvene for 16, 17, maybe 18.
It's the game on our computers.
So we have 5 over 4. Now, 5 over 4 and proper.
I think I did.
Yeah, so it's 8.
Wait, are you on number?
Yeah, yep. 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 See that thing? And then once you simplify that over 4. That would just become 1. It's the, so it's to the power of 1.
Negative 2a.
Yep. Yeah. Excellent. Once you get a few, it's not too bad. We're up there. Keep working ahead, though.
Yeah, but I don't think I did it.
Yeah, yeah.
So what did you get?
Try to write it in exponential form.
What?
I have like 10 to the box, somethings, and anything over to.
Yeah, perfect.
It's not what I have.
Now,
For 16,
What do you have?
yes. So. I'll do
negative 2a, parentheses, negative 2a, and parentheses 1 over 4.
If there was 8, yes.
Okay.
I don't know, you got 10 in pots.
Where's the
So I
3
got
over
one.
2?
4, and then 1 over 4.
16.
I have 17.
Oh, sorry, you're too far ahead of
Okay.
us.
That's what I got.
Where's the
Yeah, I don't know where it starts. Oh.
Because what I'm doing is I'm
Yeah.
pulling apart the pot. See if they got 4 fourths, 1. Alright, 0 is done. Just 4 fourths and 5 to 1.
That's what I'm doing.
Why should not go to
Those are my painting. This is the new crossover.
You can look at it from the side.
Oh, all right.
a first sequence.
Then how you go with another place?
Or would that not be wrong?
So then you have 5 over 4.
Why would you simplify that? You just
You
simplify
separate that.
it.
1 over 4. How many do you have over?
That's not funny. I think it's not funny. That was so detailed. That should hurt someone.
No.
Okay. No. Same question. Okay, let's go through. All right, guys. So let's bring this back over here real quick. I know, I'm sorry, but everybody kind of had the same questions. So right here, step 1. Let's write this in the other form. The other form is your friend. I know you don't think that yet, but it makes things a lot easier that this form makes very hard. So Sam?
It's negative 2a and then 5 over 4.
Good. So this is the other form. Okay, is that an improper fraction?
Yes, it is.
Okay, that means that at least one person gets out of the square root. You guys are trapped in the square root, but there's 5 of them, and the doorman can let 4 groups of 4 out. So how many groups of 4 are in 5 fourths? 1 group of 4, right? So basically what I'm doing is I'm making this, this be right here. So this is going to be negative 2a. So that's 4 over 4. Negative 2a. What's left over after 4 over 4 is used up? 1/4. Good. Okay. You're almost done. Yeah, Sam?
And then you just make it the final step, which is then just negative 2a on parentheses, and then negative 2a on parentheses.
That's exactly it. Where did my 4 over 4 go?
Oh, why don't you?
Yeah, it just became 1. Because to the power of 1 doesn't change anything. Has no mathematical power. So if these had power of 1s, both or either or none, changes nothing for a value.
Power of 2 though, then.
If I didn't have the second set, it would be.
But if you add it to the first one.
Oh,
Say you
I wouldn't
decide-
mark, yeah, I wouldn't mark you wrong if you did this. It's just, you just don't need to. Yeah, if you want to do that, that's fine. You don't need to though. Okay. So this one's a little trickier. So let's do this without having to multiply 10 to the power of 5. So who's the doorman?
Two, good. Two's out front. So what I'm gonna do here is I'm gonna take a look and say, okay, if two is the doorman, do any tens get out?
Yeah, what?
Yes.
Hold up,
There should be.
what?
There's a two here, right?
Yeah, like,
2 tens.
I just put the whole
Divide
thing in
it out.
parentheses and put 1/2.
You can do that. I'm just gonna see if we can analyze the problem before we start solving it. Do any A's get out?
You know.
So-
What's the 2?
Is it bigger than two?
Oh, yeah.
So if this is
Yeah,
bigger
yeah,
than
yeah,
two, it can get out. If this is bigger than two, this can get out.
Yeah.
B,
No, B's no.
no B,
It's
no,
not.
B cannot get out. So as you're kind of looking at this, so I have 1/2, 10 to the 5, A to the 3, and B.
Oh, I did that right, let's go.
What can I do with that 1/2 to kind of help solve my problem?
Wait, hold on. Wait, what?
This 1/2 here, I want it to get to all these things. What could I do? Just think of your properties of exponents.
You could.
Yeah, distribute, exactly. Yeah, so this would go, I would have 10 to the 5/2, A to the 3/2, and B to the 1/2. Okay. So I just multiplied everything by 1/2. So 5 times 1/2 is 5/2. 1/2 times 3, 3/2, and then 1/2 times, technically there's a 1 there, would just be 1/2. Questions on what I did there?
This is just like one problem, or 3 problems in one.
Uh-huh.
That's.
And
Yeah.
that's the answer.
So, so let's take a look at this. Does B get out? No, he's stuck. Just a 1/2. There's nothing to simplify. It's a proper fraction. So I know he's gonna be part of this crew. It's gonna be in the 1/2. All right. Do the A's get out?
Yeah.
How many groups of 2 are in 3? All right, so I know 1A gets out, but 1A gets left behind. And do any 10s get out?
Yeah, 2.
2, good, yes. So 2 10s get out, which is 100, and then 1 10 stays in. So my last step would be just to write this out as 100, and I am done.
See, I feel like
Just to
I'm
show my
so-
thinking, you don't have to show all these
I
steps.
feel like I'm so close to getting the answers every time, but I'm not.
Well, let's try this last one here, and then we'll play a game. So 18, last problem for today. So
Can you give me like a second?
sure, yeah, I'll give you guys a moment if you want to kind of wrestle through it. Remember what your first step was on all of these.
Would it be, in the parentheses, would it be 4/3 or 1/, or, yeah, 4/3 or 1/3?
You're talking about for the Y?
Yeah.
You will eventually get to 4 over 3 for the Y.
For 18, when you put the thing in the square root in parentheses,
Mhm.
would it be the power of 4/3 or 1/3? Because
The Y would get 4 over 3.
then-
So to show you every step. One sec
okay,
here.
okay, that
That's your first step.
yeah.
Since the 9x7 doesn't have a parenthesis, is it different? Or separate?
It's not, so the 7 only goes to the X. Is that what you're asking? It doesn't go to the 9.
Yeah.
The 9 is just there multiplying, but he has no power.
So when I bring the 1/3 to each of them, is 9 1/3 by itself?
Mhm. Good. We're not gonna do the back today. Oh. This is our last problem.
What's in the one?
We only have 15 minutes left.
I know.
Imagine the 1/3 crew is like the trailer park.
It's interesting.
Let's
like a
make
whole
that- yeah,
tail.
make it big.
Beautiful. All right, guys, last problem here.
Wait. I'm so close.
Ooh. Ooh. Ooh, ooh. I think
You got it? Okay, does the 9 get out?
no,
No, he stays in. How come?
because he didn't graduate.
Oh.
Oh, shoot,
Ooh.
I messed up the order.
Okay, so then, do any X's get out?
Yeah.
Yeah.
But one says.
Oh. Yeah, so 7/3 is improper, so I could do 6/3 and 1/3. So I have one X that got in, two X's that are out. Did any Y's get out?
One.
One got out, need to stay in.
Yes.
Reese,
One.
Good. I did few less steps on that one, but that would be your final answer there. All right, okay, let's play a game.
Are we done for today?
Besides the game, yes. Yes.
That's a good idea.
What's that?
That's probably not a good.
No, I think, wow, I think we should have like a chart that has like all pictures of ice cream. And every time someone takes your ice cream, you take them out. And if they can go through a whole week without someone taking your ice cream, you get ice cream card because of all the ice cream.
That's like a great idea.
I know.
Yeah, I'm not against that.
We will never get.
Let's talk more.
Right.
I don't know. I feel like everybody could be pretty motivated if I brought ice cream bars.
We got like a cert, like, if we didn't get more than 5 things.
Yeah,
I know.
so like we could do that. You get one a day.
You're welcome.
All right, yeah, you can market that.
Oh, my title.
Love ice cream sandwiches.
I got 144 yesterday. Yeah. I listened to 44.
Okay, here we go.
Yesterday.
Yes. Yeah, I was at home. No, it's. I have 74.
I got a new loading thing.
Yeah, you're gonna really put the dome and the.
Oh, are you still recording?
I am. Thank you for checking.
Others. Oh, it's so small.
Oh, I saw Owen up there. I was like, wow. For the, but no, there it is.
Cake Miss Princess Dan. He's had enough fun for one semester.
All right, 3 more. You won't need paper for these ones. These are pretty rapid fire questions. All right, guys, 3 more though. We're gonna leave you behind. Anybody need help logging in? Trinity, I feel like this is where your competitive side comes out. Doing stretches back there and ready. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14. One more. Who can I help? It's not working. Do you have your phone? Wanna try that one? Yeah. Huh? Yeah, and it keeps them from doing that same name.
It's the one way.
McBee plays Fortnite.
That was me. I think B plays Fortnite.
That's not true. I do not.
And then to say Mr. Macbeth plays Fortnite.
All right, we're in. Okay, guys. These are all pretty rapid fire.
You have to see.
Oh my.
Oh, that's a thing.
Yeah, we're just switching forms.
Like 40%.
I forgot.
I'm in first place. I'm in first place.
Nice. All right, guys. So just real quick, what's the top number? What's the top number represent?
1. That's the fruit.
Top number is power, right? Top number?
Is there a prize for the one? What's the prize?
PS5.
Yeah, PS5.
Okay, I'll take back words.
All right, unhappy face is number 1. Is that you,
That's a
Dylan?
Sad face.
As a golden.
Rewrite the expression in radical form.
Is that the same question?
Different numbers.
You need help?
I'm scared it's gonna get like into actual answering it.
Good. Yeah, the first like 4 are not too tough.
Look at Adam Stinks getting up
Nice.
there.
There you go, Adam. Stinks.
Uh-oh.
Wait, just.
Hey, he cheated off me.
It's mine.
Move your screen over
He
then.
waited for me to press.
So I just happened to finish the same time as you.
Mm.
You're still behind me. Why would I
Holy
be up there
smokes.
behind you?
That was a lot of movement. Yeah.
Dylan beat me.
Oh, not to.
I answered that one at a time.
Dylan made me slow.
Nice, guys.
Got it wrong. That was easy.
Yeah, it was me.
All right, Reese is on the rise.
Oh, Adam Stinks is going down.
Well, then.
Nice work, guys. Okay, I think we're getting these down.
I think someone's getting it on the.
That was a big jump, Reese.
Oh, this is an answer.
There's always one left to ready.
Nice work. Okay. I get just a few more of these and we're going to reverse forms.
Hold it.
So I'll ask for rational instead of radical.
Like getting
Whoa.
one wrong, my life.
You're
is
slow.
Yeah, this one's one of those
What?
ones.
You just got it right.
I'm 1 point behind Adam.
That's
Let's go.
crazy close.
Oh,
Oh, did you get that before me?
No, I got that wrong.
Did you actually?
Yeah, it's A, and I pressed. B.
Oh, that's going to be tough.
That's tough to come back. How you get that one? Bro, you got that one wrong. Actually.
It was
yes.
It's
As it
okay.
should be.
I know you better.
I'll reverse. Oh no.
Yeah, I think 10 or 11 reverses it. So we're close.
An answer.
Oh,
No.
it won't click. It's not clicking.
No. That's stupid.
You got it wrong.
I hate math. All right.
Yeah.
guys.
All right, nice work.
Wait, what?
Owen's on fire.
Let's go.
Who's
Oh,
Owen?
I'm on 8.
Oh, you're Owen? Okay.
I'm Adam Stinks.
I'll get my revenge on the. Oh, an answer.
Oh, no. Oh, my. Oh, no.
Who's number 14? Who's just,
No way.
it's just.
Yeah, who's so slow? You got it wrong.
Nobody got it wrong. It's all right. All right, I
Someone
think this one
get it wrong.
switches.
Get it wrong.
Yeah,
Oh.
so rewrite the brain. There you go, you got it.
Oh, I got moved down. Bye on.
Nice work, Amelia's on the rise.
What? Where is it? It's not there. Is it? There it is.
It's definitely there.
It's gone.
Oh my gosh.
Ruth's holding a strong lead.
Ruth has more than 2,000 Johnson. Oh, this has no answer.
They just
Wait, you pressed all of them?
I'm the only one who
Hey.
got it wrong.
Oh,
Yes!
sorry, Ruth, I jinxed it.
Yes!
Oh,
That's pretty bad. How dare you, kids?
I know.
How the
That's
terms
my
have
fault,
tables.
Ruth.
An answer.
Are you serious? I thought it was
classroom perfection.
Oh, come on, I'm so low.
Look at that. Everybody is in the 12s. That is really close.
Except for Josh.
An answer. There it is. No, no.
Dude, I had to take this.
This game is bad. Someone get it wrong.
I'm not gonna get the scoreboard anymore anyways. If you got one.
Well, I want to get.
You're kind of out of the game.
Wait,
You
you
didn't
didn't
even
even
answer.
Oh my god.
This is.
Oh, I'm 2 points behind.
All right, we just got 4 questions left to tie this off. 5 questions.
Oh.
Very animated.
Genius machine.
All right, who's running the clock on me? Mr. Martin? I don't believe you.
Come on.
Someone didn't even.
Let's go.
Oh, wow. Are you APM?
Hey,
There's always a
we
trick.
should do this one again.
No.
Okay, good to know.
Oh.
Oh my god.
Ah, where is it?
Wait, did I put the wrong one?
Where is it?
Wait, what? Oh, just.
Not there. There it is.
Oh,
Hey, we should do.
Is it C? Did I put the wrong?
It's C.
Yes, Adam Stinks is.
I just saw
gone.
6 and 3 and I just.
woo, that was controversial. Let's look at this just real quick. So,
Oh my god.
what's the power?
Oh, we know why you got it wrong.
Okay, what number's down below?
No, wait,
Oh, we
All
gotta
right.
finish, we gotta finish, we gotta finish. You fools.
I can't end it without doing this part.
Oh,
Oh, there it is, guys. Nice work. No homework tonight.
Fight.
Oh, and no quiz this week. And Brianna, happy birthday. She said you would be upset.
You're 16 now, right?
this is gonna be flawless.
People around me are getting older, and I don't think-
Another defeat for Reese.
Rest. All right. Okay. Oh yeah, neither am I.
Obviously, or Friday, but I mean, that's just it.
Sure. All right. Well, you'll be missed.
Yeah. Wait, have you ever done state?
No, I've always wanted to though.
Well, they only just say, hey, I'm not gonna be here. Go
Yeah.
find someone to
It's
teach.
really tough to find subs right
Wait,
now.
what was the prize?
Miss
Like
Fulton
we
had
gotta. She did. She's going.
one. No, I thought she's gone today.
I'll ask again. They tell me no every year, so I just stopped asking.
Why did you know?
I don't know. I've always wanted to go. Yeah. Oh, thank you. It is sad.
What do you need to do with that?
Like everybody's out having fun and I'm here.
What are you gonna do with that?
I'm gonna grade them.
Right, but they're right away.
Oh, it's a bummer.
Wait, so,
Since you're usually here with your state, is it like not a lot of people here?
No. In years past, I just like watching. But we only have one day that's not this year, so I'm not sure what we'll do. Try something fun.
Yeah.
We'll tic-tac-toe or something, competition. But no quiz at the end. You guys aren't very confident. All right, you guys, see you tomorrow. For this. Yeah, so I have -3 times -64. And I'm kind of go through this. This will be 16 and 10. This will be 192 minus 32 plus 10. If I'm doing my mental math right, how'd I do? What'd you get? I don't know if that one. Right. Sure. I'm right. Let's see, 192, 30, 60 plus 10. Yeah, I'm right. Okay, so this is the right answer here. So if you had a few of those later today, can you give me thumbs on how just evaluation things would go? Okay, good. Okay, we'll do a little practice with those, but I'm glad to see. Okay, let's go ahead and get started with today. So the last few days, we've learned the foundational properties to exponents.
Today, we're gonna learn the foundational terminologies. Once we have something we can talk about, and then once we have something that we can work with, then we're ready to go on. So I wanna make sure we have good foundation with our vocabulary, as well as a good foundation for the rules of the game. So the rules of the game we've gone over. Today, we're gonna talk about the vocabulary.
We're playing the game.
Yeah, actually, there's a little game today.
Is it good?
It is.
Yes, is there a prize?
Sure. Yeah. Hi.
And
I have not seen it, but there's a lot of papers around, so. Let's see. Okay. So I'm gonna do. Let's see. Okay, so your note guide, I gave you a paper to kind of go along with this. I'll just go through a few of these with you. We'll ask a few questions, we'll do a few demonstrations, do a quick little competition, and then time will be yours to work. That will be the plan for today. Friendly reminder, when's our quiz? Wednesday, yes. With this, it's a little different than normal. We're gonna do Wednesday. What's going on Thursday?
white elephant.
Yeah, White Elephant Christmas party, so we'll be doing no math that day. That'll be the kickoff for our Christmas. Cool. All right. So this first page, if you look at it, it's got a lot of stuff going on here. So I just want to spend a few minutes kind of breaking down some terminology of this stuff to make sure we understand what a polynomial is. You don't know this yet, but what we're in the unit of polynomials, meaning I'm just dealing with something where this could be something of power 2 or more, and it could have a few other terms. And that's going to be the ground rules of what we go through in this unit. So a polynomial has to have a few things to be true first before we answer any questions about it. There are rules to being a polynomial. The first rule is that if exponent must be a whole number. That's really key. Meaning a whole number, by definition in mathematics, Yanni, you with us? So by definition in mathematics is 0, 1, 2, or greater. So a little note, what it's not is it is not any type of fraction, and it is not any type of negative. Whole numbers by definition in mathematics are like counting numbers plus 0. That's your first rule. Exponents have to be whole. Second rule is coefficients must be real. Example of a real number. Good. What's an example of a non-real number? Count. Real is anything your calculator can handle. Imaginary. Good. Imaginary. So what you're looking for here is you want to make sure that we have no imaginary. So we're looking out for i's and negative ones. Now I used a math term here. Coefficient. Is that a new term for us?
I knew one.
Oh, once upon a time. Yeah, so a coefficient is the number next to your variable. So for example, if I had, let's say, 4x cubed minus 13x squared plus 12, coefficient of my first term would be 4. Coefficient of my next term would be negative 13. And then the 12 is not a coefficient of anything because it has to be something next to a variable. So what is my coefficient if I did negative 35x squared minus 10x plus 12? What's one coefficient you see here? Negative 35. Good. What's another one? For raising hands. Negative 10. Good. Is 12 a coefficient? No. Why not? No variable. Right. Good. So a few things to note. If you had to make the decision of what a leading coefficient is in the pink term here, what would you decide that would be? What's your reasoning on that? Because it's the first one. Okay. And what if I did this? So what if I did negative 10x minus 35x squared plus 12? Why? Yes, the leading coefficient is the coefficient next to the most powerful term. So leading coefficient is next to the x squared because x squared has the most power, 2. The leading coefficient in this case would be negative 35. So I have negative 35, and it's next to highest power. Now the next term, I think, might be a new term for us. Have you heard the term degree before? Outside of temperature? What's degree? Oh yeah, angles. Right, outside of angles and temperature?
Yeah.
What? What's degree?
I don't.
Yeah, right, a business degree. Good. So degree in algebra is the highest power of a polynomial. And this is really important to us because the highest power has the most impact on what that equation does. The other ones might wrestle and resist a little bit. You might see some waves up and down, but ultimately, at the end of the day, the highest power determines what the graph is. And so right here, a degree is highest power. That's all we care about. We don't care about anything less than the highest, just what is the highest power? What is my degree here? What was it? Close. Highest power. No, squared. Yep, you would just say 2 or squared. So you said the degree of this guy right here. So I'd say degree is 2. Now this last one, I'm hoping is a little familiar. Have you heard the term constant term? Yeah. Okay, what's constant mean in general? Yeah, repeating, like always. Always. What's another word for constant? Reliable, the same, unchanging. Good. So a constant term is something that does not vary. What's x considered? A variable, because it varies. So what do you think the constant term is here? 12. A constant term is something that does not vary, which means that it's attached to nothing that changes. So the constant term in this case is just a number with no variable. All right, and so in this case, it would just be 12. I want to add one more on here, and this is your leading term. We talked about terms before. The one we used was a monomial. What's a monomial? One nomial. What's nomial mean? Close. Close. So, is this a monomial? Or x squared? Close. Is this a monomial? Yeah. What defines a monomial? There's only one term, right? So this is one term. Is this a monomial? Right. The plus or minus is also another way to determine how many terms there are. If you have plus or minuses, that separates terms. Another way of looking at it is a monomial is anything that's connected by multiplication. 4 and x squared are connected by multiplication. So that would be, in this case, the first term would be 4x squared, the second term would be 3x. So a monomial means this. The leading term, if you had to take a guess, looking at our original example equation again, and you were in charge of defining the leading term, what would you choose as the leading term? Let me start with this. How many terms are there here? 3. Okay, which one of those 3 is the leading? I'd say the first one. Leading meaning the most powerful or the biggest. That's what leading means in mathematics. So if you had a leading term, it'd be the entire enchilada. It would be negative 35 x squared. That would be your leading term. So that'd be the last thing you'll see in vocab today. Any questions on some of that terminology stuff? Okay. All right. A few things about form real quick. So degree of 0 would be something like if I had an example, if I had 4x to the power of 0. What's x to the power of 0? 1, right. And so really what I have here is 4 times 1, which is 4. So what 4 is what kind of term? No. Oh, stop. Let's just right to the right here. Yeah, it's a constant, exactly right. So this would be a constant. And so the constant is just some number. And you say A, but it's really just A is representing some value. Degree 1. What's it mean something has a degree of 1? Is what? Yeah, what's 1? The power of x? Yes, the power has a highest power of 1. So highest power of 1, you've seen these before. So it might be something like mx plus b. What shape does that make? Close? Riley? Yes, it's a line. And so if you have anything to the power of 1, we call it linear. So an example might be something like 5x minus 7. So linear is anything you have to the power of 1. And if I have, let's say, a degree of 2, this one I'll give Starburst for. What type is a degree of 2? Johnny?
A linear.
Close. Standard? Close, not a variable.
Square root.
But it's funny.
Exponent, it makes a parabola, it's not called a parabola. No,
Give us the first letter.
Q.
Quadratic.
Right, you gotta raise your hand.
Gotta get it
Right, are you gonna say quadratic?
Oh,
Are you gonna say quadratic? Yeah. All right, you touched it now. Oh, yes, quadratic. Quadratic was in our entire unit last unit. And so, quadratic is anything that has a power of 2. So power of 2 here would be quadratic, and we've seen these before. Not that you necessarily need to write this down. I know you guys are very familiar with that form, but an example might be something like this. Saw lots of those last unit. Okay, this next one might be new territory for us, but it's a 3. What would you call a 3? That was 2. Power of 3. Yeah, I'll take that. Cubic, but yes, cubed. So the power of 3 is cubed. All right, so we have power of 3 cubed. It just means that somewhere along the lines, I had something that's cubed. It will be x squared and so forth. Now, there's 2 more I want to do because I want to add one to this. So let's see, you'll have 4 and 5. 4 is probably a brand new term for us. Any thoughts on what 4 could be called? Yeah, totally fine. This one might be brand new to us. Quartic. So 4 quarts in a gallon, quartic. This would be anything to the power of 4. And so this is just saying I'm going to have something with the power of 4 and so forth. I'll give a few examples there. And then the 5th one, which you might see in a couple homework questions, this one's called quintic. And this will be the extent of terms that we learn. After that, we'll just say degree 6, degree 7, degree, etc. So quintic is just saying something that has a power of 6. Okay, we'll do a few Q&As to see if this is true. We'll talk about in behavior, we'll do a Kahoot, and then that will be our day. Do a good time. I'm still ready. Okay. It's what? Yeah, the pink ones are my favorite. They're not my favorite? Those are my favorite. Yep. Interesting. I thought I made that call.
That'll be your boss.
Tell me what my favorite things are. Seems intense. All right. Can we zoom in on anything or anything?
Do we have to write this down?
You have to know this.
Yeah, I know.
Okay, find out. Okay. I'll come back to this here in just a second if you guys need stuff.
Yeah.
So it is in OneNote too, in case I forget, but let's go through a few Q&As real quick. Going back to the first thing we talked about, is this a polynomial?
Yes,
Why?
there's multiple of them.
That's true. Yeah, there's multiple of them. Yeah.
There's multiple of them.
Yes, good. Thank you. Are all the coefficients real?
No.
Let's see, is 1 real?
Yes.
Yeah. So real means does your calculator can handle it? Can your calculator handle what?
Yeah.
Can it handle -1/4? Yes. Can it handle 3?
Yes.
Yes, it can handle all those. Real is just anything that's not imaginary. Okay, so that's a polynomial. What's the degree of that polynomial? Wait. What's the degree?
Second power.
4. Good. It's 4. So it has a degree of 4. So let's see here. So I have a degree of 4. What is the leading coefficient, Grant? Careful. That's the leading term. So you're right there.
I have a question.
Yes.
Is it an imaginary number, not a negative number?
It's a negative in a square root.
Oh, it's a power.
Yes, it is I by definition.
Is it equals 1?
Yes, your leading coefficient is 1. And what type is this? Good memory on that. Yeah, so the type here is quartic. Good. Okay, let's try another one here, and then we'll switch to calling a few names. But first, we'll do a few open ones. Is this?
So we're supposed to write that down.
You want to know this? I'm not grading your notes, but you want to know this stuff. These are examples should be on your note sheet. Is this a polynomial? What's the thing in question? What makes it iffy? Yeah, can your calculator handle it? So, could your calculator handle a square root 3? Yeah, you could throw that in there. I know give you some numbers. It'd be messy, but that's okay. It's a real number. remember, what I'm looking for is it imaginary? Because it can handle anything that's not imaginary. Is pi imaginary? So could your calculator handle it? Yes. Calculator can handle anything not imaginary. So coefficients checked out. Are the exponents all real? I'm sorry, whole. Yeah, 1 and 2. Bingo. So yes, this is a polynomial. So this does check out, passes the test. What's the degree? Good. Highest to power is this guy right here. Let's see. What is its leading coefficient? Leading coefficients. It is pi. So leading coefficient is the number next to the most powerful term. So the powerful term's hiding back here. So this would be pi in this case. What's the constant? Let's throw a little twist in there. Yes, this right here would be the negative square root of 3. So what's not next to a variable. And then could you tell me the type? Quadratic. Good. This is quadratic. Questions on that one? Okay. Is this a polynomial? How come? Right. This is not whole. So right here, remember whole numbers. This is the symbol for whole numbers are 0, 1, 2, blah blah blah. So since it has this, it cannot have the characteristics of a polynomial if it is not a polynomial. Kind of a parallel example would be is, let's say we were checking out dogs, right? And what are some characteristics of dogs? That's a dog. So it has fur. What's another characteristic?
3 legs, 4 legs.
It should have 4 legs. What's another characteristic of a dog? What's it do?
Tail.
Well, yeah. Whoops.
3 eyes.
All right. It has a tail. I don't know where you buy your dogs. It's like a Chernobyl dog. So first you want to say, okay, is it a polynomial? And it only makes sense to check the characteristics if it's a polynomial. So let's say I'm checking through my animals and I'm going through and we see a fish, right? Is a fish a dog?
Yeah.
No, a fish is not a dog. So I don't need to check, does the fish have fur? Does it have 4 legs? Does it woof? And so when you have something like this, if it's not a polynomial, do not talk about its type or leading coefficient or degree. That is specific to polynomials for us.
A cat can be a fish.
Okay, so moving on here with this one. This one's kind of a tricky one. Is this a polynomial? What's causing the doubt?
The X is displayed.
Right. So an X, because we have no restrictions on domain, an X could be anything. So if it could be anything, we must consider every single scenario. Because in math must be perfectly true or it's false, which is kind of nice. Either it's perfectly 100% right or it is wrong. So that means if 1 billion different values for X worked, but 1 did not, fails. Math is very strict like that. Is there any values of X that you could think of that would cause a problem? -1, right? Or it could be imaginary, or it could be 1/2. It could be something not whole. So since there exists a possibility, is this a polynomial?
No.
No, it is not a polynomial. It must be perfectly in every single scenario true and workable. Otherwise, it is false. So this is not a poly. All right. Let's see. Okay, I'm gonna skip a few examples here. I'm gonna go to our last little deal. You gotta learn this. There's a few questions like this. Okay, so what's nice about polynomials and really all math equations is it's a language that we're pulling apart, meaning I can figure out what a graph looks like without ever having the graph. So you'll get to the point where you can look at just an equation and say, hey, I know what that ends up being. And it has to do with decoding the patterns of the numbers. So what happens here is degree and leading coefficient tell us a lot of information about what a graph will look like. What's degree? Yes, the highest power, right? So the degree, if it is a even number, so if it's an even number, we notice that the graph is going to go in the same direction, such as x squared. Parabolas always went in the same direction, whether they're going up or whether they're going down. Those are even numbers, right? And so this is going to be even and this is going to be even. If it both goes up, that's even. If it goes down, that's even. Now, what do you think causes it to go in different directions? Odds, right? And so this would be odd and this would be odd. So this means that I'm going odd one way or another. The ones you've probably learned in the past is lines. So lines, if I drew a line, you notice that, one direction is going to be going up while the other direction is going to be going down. Well, we're going to learn about a few things that are a little bit more than lines in this, but still have that same characteristic. Now, when you read graphs, you always read like you read a word, from left to right. So I'm reading through this, and as I keep reading through this graph, where does it end up going? Up, right? It's going positive. Remember that the leading coefficient has the biggest impact. So these little guys right here, you're seeing the lesser power to show some force. But in the end, the leading coefficient ends up going up. What do you think is true about that leading coefficient? It's positive. Very good. Yes, it is positive. And so I know that this is going to be positive. What do you think this one is? Negative. How come? Because it goes down. What about this one? Positive. How come? Good. And this one? Okay, good. All right, let's practice these a little bit. I made these. So tell me if this is even or odd. All right, so you're going to determine if it's even or odd. Even. Why is it odd? Even. Well, is it going the same direction?
No.
Yeah, so different directions. So odd, different, odd, different. Oh, that's for leading coefficient.
What are we doing?
We're just doing a degree. So degree is odd, different, even, same. So odd, okay. Odd. Oh, is it going the same direction? Yep. Even. Okay, good. Okay, good. I think we got that. Okay, now let's try positive and negative. So I want you to figure out if this is positive or negative. I gotta think because I'm backwards to you. Positive, right? Yep, this is positive and even. So just think positive or negative. Negative, good, because it's where it ends up. So positive, negative, positive, negative, negative. Negative. Which one determines positive or negative? Just this one, right? We don't care what this one does. It's about where it ends up. All right. Let's do one more odd or even. Let's do both now. So first we'll say degree, then we'll say leading coefficient.
Even. Positive.
Good.
Negative.
Good.
Positive.
Good. Yeah, but this would be even, positive.
Even negative.
What is this one?
Negative.
Okay, one more.
Negative.
Okay, good. Okay, let's try our skills in a Kahoot here.
My brain's not been
We'll switch gears a little bit. I can do the flagging? Yes. If this teaching thing doesn't work out, maybe I will. All right, so let's go over to Kahoot. Let me share real quick. There we go. Kahoot.rock. All right, let's try a few Kahoots here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Oh, it's one of those math songs. You guys don't hurry up. I'll turn the music up. Oh, you can't? That makes it hard. Sorry. I was like, no one's letting in.
Yeah, that's because we want to listen to the song.
It's not popping up. Oh, there we go. I do not want to turn the volume up on this. This looks so awkward and cringy.
Turn it up.
Do it.
Ugh.
Dylan. How did Dylan get in so well?
He could see the screen.
Yeah. Turn it louder.
Turn it up. This guy's actually got a lot of YouTube followers for math stuff, I think.
Was your dad there last night?
He wasn't. He did knocked it out though. Can't believe he got it done in the evening.
Oh, no.
All right, one more. Guys, these are getting a little further and further every day. Okay, here we go. There's two Dylans.
Actually,
That's tricky. Is there four Dylans? Polynomial function in behavior. Name the function below by number of terms and degree. How many terms does it have and what's its highest degree?
Oh, yes.
Are you kidding?
Yes, I got it right.
Yanni, don't yell us the answers, but. All right, yes, this was a cubic because it has a power of 3 and binomial because there are 2 terms. Nice work, Amelia. Alone. Oh. Dylan, Macbeth, and Anna. Okay.
Not Macbeth.
Oh. Same question, different term. Different equation. Good, yes. Oh, was that perfect? Nice work, guys. Oh, Dylan on the move up. Oh, nice work, Dylan.
Which Dylan is it?
I don't know. In the function, a little extra time on this one.
That was a pure guess. Pure guess.
Yes, quartic and poly just means many. So we have binomial, trinomial, and everything after that, we just say polynomial. So it can mean any number. All right. Amelia's holding down the top. Nice work. Name the function. By number of terms and degree.
Dang it, I got that wrong. It's green, isn't it?
Or yelling. It's fun. It is green. So it is a constant and there's just one term there. So. Nice. Oh, is that you, Reese? Yep. Yes. Name the function by the number of terms and degree. I tricked you. Nice. Yes, quintic is the power of 5 and binomial.
I'm giving up. There's no way.
Riley on the rise. Not with that attitude. You've gotten 5 wrong over the last 6 questions. Tony wrote stuff down. Nice. Quadratic. That's from last unit.
I got that correct.
Oh, nice.
Coming down.
Amelia is not playing around.
I am.
Describe the leading coefficient, degree of the following function.
Oh,
Yes.
It does the thing. It does the thing. Oh.
This situation, both going down.
That definitely helped me twice.
It's going down on both ends, and because this one is negative, because it's the same, it's even.
Oh, would you look at that, the one person that picked right with.
Dylan, which Dylan is that?
Me,
Is it you?
me,
I don't know if I believe you.
there's four Dylan.
I know there's 4 Dylans.
Me,
All right.
this right with-
Oh, I didn't teach this part.
I know, give me the answer, give me the answer.
Sorry, guys.
You're gonna mess a lot of people up.
Well, you're all in the same boat, so at least it's fair. I'll teach this real quick.
Eeny, meeny, miny, moe, catch a tiger by its tail. It's Lila, it's Lila. No, it's Lila.
I knew I forgot
What are you
something.
doing, Dylan? What are you doing, Dylan? You just lost your place. Quiet, Dylan.
Go ahead and answer this one, and I'll show you guys this one real quick, and I'll finish the last few questions. Oh, nice. That's a high number that got it right. Okay, let me show you this real quick. My bad on that part. So for this thing right here, it's the last piece to this. So what you can do in mathematics, there's some symbols to describe left and right. So if I'm traveling, let's say really far to the left, what direction am I heading? Negative, right? Negative what? Negative. Yes, negative x, right? And so what you can say, if you want to say, as you look to the left in mathematics, it's really abbreviated to as x goes to negative infinity. This right here is left in pure logic form. So as I'm going to negative infinity, to talk about in behavior, you want to talk about y values. Y's are always our answer, and so y values are going to be our end result. So as I look to the left, is your graph going up or down? The further I look left. It's going down, right? The further I look left, it's going down. So what you'd say is f of x, what's f of x? Y? Yeah, no. What is f of x? Yeah, it's y. Good, so you're saying as y is going to negative infinity. Now, if I want to describe to the right, any thoughts on what that would be? Yes, it would just be positive infinity. So it's saying as I look to the right, and I've looked to the right of this graph, what's happening? What's my graph doing? The further I look to the right, it's going up. So you'd say f of x goes to positive infinity. So what's nice about these is there's something that's always going to be true for this section learning these. We're always going to look to the left, and we're always going to want to figure out what's happening when we look to the left. And then we always are going to look to the right. And so I always want to figure out what's happening as I look to the right. Oops, I didn't want to do that last part. So I didn't even have to look at the graph to fill out this first piece. I say, okay, as I go to the left, is it going up or down? As I go to the right, is it going up or down? All those will have this piece. The last piece is the only thing we want to fill in. And in this case, as I look to the left, so the further I look to the left of my graph, what's it doing? Going up. So what would I put? Yep, you'd say infinity. As I look to, what's this mean? Yeah, it means right. As I look to the right, since my graph is going down, this would be negative infinity. Now, just to kind of really add emphasis, I will do this last one here, and then we'll go back to the Kahoot and see if I can do some reteaching of this. How do I write as I look to the left? Someone other than Grant. Grant's doing great, but I want to hear good. How do you write left? Negative infinity. Okay, good. What else? Yep, x, and then one more piece. What's the piece that's missing? I'll wait you guys out on this one. What is missing in this last piece if I want to look left? What was it? Close, that's the next part. Just the x and negative infinity and missing a symbol. Just this guy. As x approaches, this means approaches negative infinity. X can never be negative infinity. We can only approach. Negative infinity is not a number, it's an idea. So as I go to negative infinity, then I want to say, okay, f of x is going to what in this case? As I look to the left, where does my graph go? Grant's got this down. Someone else though. What do you guys think? It's going positive infinity because it's going up, right? You don't have to write positive. And we'll do this last one here before we switch back. As I go to the right, what's happening to my graph here? So if I look to the right really far, what's going on with this? Right, it's going up. Good. So just be positive infinity. All right. So that's just some terminology about in behavior. Let's switch back over real quick to those last few questions. Sorry about the mix up on that. Where'd my Kahoot go? I know, I have an issue. It's not. I got it. Let's see. There it is. Okay. Okay. Now back to this. All right. Next question.
Dylan. Dylan. Oh, I know this. Oh.
There you go. Sorry, guys. I'm looking at it. I gotta look with it. What is this? Different directions, but this one's doing something. Good, really good, excellent. Let's go. All right. Describe the end behavior of this function. All right, let's just take a look at this just real quick. So as x goes to negative infinity, what direction is x to negative infinity? Left or right? Left. Yeah, so as x goes to negative infinity, what's the y doing? Good. As x goes to positive infinity, what's the y doing? Going down. Yes. All right. We'll do a few practice ones like this, but this will be this.
The last question brought me all the way down to 5. No way. No way. Oh, I still. Dylan.
Which Dylan?
Dylan. Dude,
Can I see the screen? Hey, all right. One of the Dylans. All right, guys. All right, nice work. Okay, so homework is just a couple questions that represent this that we did in here. So Polly's intro. Yeah, so you can head over to Delta. They don't take very long. First, you're just asking, is it a polynomial? Is it not? Then it's going to ask some things about degree. Then it'll ask some things about leading coefficient. And then it'll end with a couple in behavior questions. All right, and let me know if you have any questions with those. Maybe start on the topic that you found the toughest. That way I can answer and help you. Let's see. All right, Dylan. So let me know if you have any questions. Otherwise, you are free to hop off if you like. It's just a Delta assignment for Monday. Just a reminder, Wednesday will be our quiz. Thursday is our Christmas party.
And to go over what we're going to do today. So the second one right here, let me throw this guy up here and then I'll take a reading and then we'll see if we have some questions come up on this. So reading of the room to see how that went. Okay, so first one, that was kind of the freebie. Oh, I think that's wrong. That's not the first one, is it? Is that a different equation or just a different answer? It's a different answer. So good thing we did that one. Answer on the board's the first one. Here is the second one. That explains, is this also wrong?
Yeah.
Well, that explains why last period was so frustrated. Okay, so let's do this one together real quick. These don't take long. So if I want to do this one right here, what's my starting point? Good, 3, 2, nice work. What other numbers should I throw in for my x's? Good, 2 and 4. Okay, so I've really just got one math thing to do before I can start graphing. What do I do? Yeah, let's plug the 2 in. You could plug the 4 in, doesn't matter. Get you the exact same answer. So this would be -1 squared. So this would equal 3. What's the other one? Good. So I have 3 and 3. Since we've been promoted to 3 points, that's all I need. So 3, 2, 1, 2, 3, 1, 2. That's my first answer. Then I have 2, 3, and 4, 3. There is my guy. Okay, that one probably looks a little better than the other one. How does that look for those that did some graphing? Okay, see some thumbs up, see some nods, see some blank stares. Okay, good mix. We'll do a little practice with that. The last part is this one right here. So I want these to be grab and goes, meaning take a look, you understand the problem, you interpret it, write the answer. Nothing else needed. But that only works if you understand 2 things. What form is it in and what those numbers mean for that form. So what form is this in? What form is that guy in? Close. Yes, vertex form. Okay, so what do I get for free in vertex form? The vertex, right? So remember, and my vertex here would just be 3, 1. Now, to talk about the vertex, because I'm interested in max or min, just to refresh on the vertex, what's that 3 mean? Just the 3.
AOS.
Yes, the X and the AOS and the line of symmetry, all great answers. That's my AOS. What does that 1 mean? The minimum or maximum. Okay, so that's the min or max. Notice that I haven't done any math work yet. I've just kind of interpreted with my eyeballs, knowing the patterns for that form. Does this graph have a min or a max? My first question. Minimum, very sure of that. How do you know? I just know.
Because it's positive.
Good, yes, because what's positive?
The 1.
Right, the one that's right here. The A is positive, meaning that I have a lowest point, which is a min. So that lowest point right there is going to be my minimum. So I would just say my min is 1. You didn't even need to write the other stuff. I was just showing you my thought process. So let's kind of go this other way, a shorter route. Does this one have a max or min? I think I heard both. What was it? What do you think? Max, right? Because my A is negative. So it has a highest point. That's my A right there. So what is the max? 5. Max is 5. Done. There'll be a couple of those questions on homework. I don't want you to spend too much time on those guys. So remember that the K is always your max number. So this is my plus K right there. That's my plus K here. That'll always determine if it's max or min. My A will tell me if I'm dealing with the max or min. And then that will be that. All right. Let me switch over here real quick. Let's see. Share, stop share. Share screen. Wish there was a hotkey for this. Okay, so real quick, just a friendly reminder that we are getting very close to needing these. So if you don't have one of these yet, I do need you to pick one of these up. It's on the back of your syllabus for the specific details. You can't see anything. One sec. Switch the screen. Okay. We need a graphing calculator of some sort. We're going to need it soon, not this week, but come, this next week, you won't be able to solve certain problems without this. This is a really powerful tool. So it can be an 84, it can be, we have an 83 up there. I've seen a lot of you guys use yours already. So let's see, there's an 83, but TI-83, TI-84, TI-84 plus, TI-84 plus CE, they all work exactly the same. The only difference is, you see this one's about $120. You go and offer up and you get the TI-83 for about 30 or 40. You get shipped to about the This one does have nice organization for color and stuff like that. All of them will last you through college. It'll be the last calculator you'll ever need for any math class, whether you go just for the basic math classes or you get a doctorates in math. This is the last calculator. They're kind of spendy. If you're having trouble getting one, please just let me know. Shoot me a message on Teams because come next week, I want the only reason for you to not have one is because you just didn't tell me or you didn't go get one or didn't get one from a sibling that doesn't use it anymore, something like that. So just friendly reminder, we're going to be doing lessons where you can't do any of the work unless you have this and you need to have it. It's a requirement. So come the quiz at the end of next week, if you don't have a graphing calculator, there's gonna be some points that could be at risk. So I just want to give you plenty of heads up. Okay, moving back over to today. So today is, I'll record it on here. So today, we're gonna do just a little bit of book work. I'm gonna show you the final form. So the final form, if you wanna pull out your notes. So over here, here's my notes. This will be the last of our forms. So view, paper style. 9/21. Get a good view on this. Stop share screen. Okay, so here is our last form. So if you want to title your notes, this is 1.2b, and this is called intercept or factored form. And these have two names, simply because this is named by what it does visually. This is named by what it does algebraically. So we spent the last little bit talking about the difference between factoring with different ones. And this is the reason why, because the next lesson in our book doesn't teach factoring. And so we want to make sure that we have a good knowledge base of at least knowing how to factor some basic stuff. So factored form, just to start it out, our main guy is going to be this little fella right here. So y equals a x minus p x minus q. This is intercept or factored form. So it's just a x minus p x minus q. What do you think that a does? Anybody know what that a does, Trinity? That's right. Tells you concavity, tells you if it's a min or max, nothing new there. It's the same A as the other ones before, same in standard, same in vertex, same in factored. Now, the P and Q, those are the things that are new in intercept form. So P and Q, ironically, give you a certain part of your graph. So just a quick recap on the stuff that you have learned so far for a graph. Does anybody remember what in this case what the highest point is called? Good, and it has a name. What point is that? Most important point. Yep, good, vertex. So that's my vertex. Yep, and it is a max or min. You're right, the y value of the vertex does have that. What's this dotted line called? Good, AOS, axis of symmetry, excellent. And then there's other ones that we've kind of hinted to. What would like these points be called?
What? Oh. Those are excellent.
Yeah, let's raise our hands. Make sure we raise our hands. Done? Really close. Yes, good correction. Yes, so these right here are our x-intercepts. So this is an x-intercept. This is an x-intercept. Well, in standard form, that's the most useful for formulas, but we found that it actually was the most work. We had to find 5 different points. We had to use negative b over 2a, plug back in and do all that. Then we went on to vertex form, and we found vertex form gave us the vertex for free, but we still had to find 2 points. Factored form, though it does need the skill of factoring, gives us 2 points. And now since we only have to find 3, we just got to find 1 to make the difference. The 2 points that it gives you are your intercepts. That's why it's called intercept form. Again, mathematicians are not super creative, they're very functional. So the intercept forms of these guys are found by your p value and your q value. So your p and your q. Someone shut that door back there for me. So your p and your q are always your intercept values. Now, with an x-intercept, every single x-intercept that exists on the Cartesian plane, which is our x and y here, is always what value? What is this y? 0, right? Because it doesn't go up or down. It's on the axis. So if I want to find my x and y intercepts, so let's say, let's do a little example here. So example 1, I'm saying y equals 2x plus 3, x minus 1. Yeah, we'll do this one. So if I want to do this, remembering that I always said something about inside. What is inside? Opposite, okay. So if I want to look at this, which is in that form, could you just find the P for me? Anybody have an idea what P is? 3 guesses, Dylan? 3? Yep, good. So my P is, well, let's see here. So it has something to do with the 3. What do I always remember about inside? Yes. So what would I do with that 3? Perfect. So my P is just -3. And then what is my Q? I think. Owen? Yes, nice work, 1. So then therefore my coordinates for my first 2 points is just -3, 0, and then 1, 0. So to kind of show you on my graph what's happening here, I have 2 of the 3 points already, and all I did was look at the graph in a particular way. So then this, I just go -1, 2, 3, and then 1. And then does that graph open up or down? Reese? Yes. Now, I don't know exactly where the vertex is. That's okay. I have a really good idea of what's going on with my graph though. So questions on that? I'll do a couple more, but I want to see if you had questions first. Yes, Dylan. Yeah, the P and the Q gives us the intercepts of anything that's factored or also known as intercept point. So if you factor an equation, you're supposed to graph it. They're actually been hiding right here the whole time. Yeah, good. Other questions? Okay, so trying another example. So let's try example dose. Example 2. Let's do y equals -2, x minus 3, x plus 3. Could someone maybe tell me what my P is of this one? Yeah, Ruth. Yep, good. So I have 3. Excellent. So P is 3. And then for the bonus, what could someone tell me what the Q is? Maybe someone I haven't heard from yet. What do you think Q is here, Riley? We got +3, good. Do you see the other one? Yes, -3, perfect, nice work. So open to anybody. What are my points? Thank you. Grant? 3, 0, and what was the other one? I like that there's a 0 in there. So 0, -3. Just one little adjustment. Dylan? Oh, yes, good. Okay, good. So yeah, you got the right numbers. So nice work on that. Just remember that for x-intercepts, this is to everybody, x-intercepts, y is always 0. So y's are a non-guessing. So to give you a visual, for those who like to understand visually what's happening here, 1, 2, 3, 1, 2, 3. I have my intercepts. Does the graph open up or down? Down, right, because that 2 is negative. I don't know exactly how far up or down it goes. We'll get to that. I want to make sure we get our P's and Q's first. All right, let me do one more. I'm gonna walk around and help you guys with this one. So let's see, example, let's do y equals, do -1, x plus 4, and then x minus 2. Could you find your P's and Q's and then also just give me a rough graph, because I know you don't know the vertex yet, what this should look like. Find your P's and Q's, rough graph of what this should look like. I'll come around one-on-one and see if you have some questions. And then we'll see where we're at with this one. All right. All right, let me draw just a rough graph of what this thing is going to look like. So if you try to graph this guy, what it's generally going to look like is, I'm going to skip to just writing in my intercepts. Where's one intercept at? Oh, Dylan? Good, so I have 1, 2, 3, -4, 0. So it's right there. Where's the other guy? Someone else, Reese? Yeah, just 1, 2. Inside is opposite. So it's not asking you to find the coordinates, we're just graphing, so you can skip to that step. So now that I've got to that step, does this graph open up or does it open down? Huh? Down. Good. The reason for that is because I just have a negative a. Okay, let's take this to figuring out what that last step is here. And I bet you your gut might help you kind of figure out what this is in this case. So example 4, I'll walk through this with you. We'll just do y equals, we'll do x plus 3, x minus 3. I'll keep it kind of small. Where do I put my 2 intercepts? Yeah, good. 1, 2, -3, 1, 2, +3. Okay. Where do you think, if you just had to guess, my vertex might end up? In the middle of the 2. Were you here last class? Did you sit in last class? That's good. That's exactly what I was looking for. So it's in the middle of the 2, but how come? How come that you can say that the vertex is in between these 2? Huh?
Because they have.
Owen?
Those are the same numbers.
Right, they're the same numbers and they're just opposites. I like that.
Parabola has to be symmetric.
Yes, because of the same numbers and every parabola is symmetric, which means that in between 2 points is going to find my middle point, which in this case is my vertex. So to find your vertex, to find this middle right here, you've actually done this in a different form. Has anybody found the average of 2 numbers? I guess a better question is, does anybody remember how to find the average of 2 numbers? All right, Trinity, what do you think? How do you find the average of 2 numbers? Yep. Yes, exactly. So what I would do is I'd just say, okay, here's one x-intercept plus another one and divide by 2. But in our case, we have names for these x values. We call them p plus q divided by 2. That's the average. That was what it was taught back in Algebra 1. Well, this same exact formula finds my AOS, also known as the x value of your axis of your vectored form. So this is the one form needed to figure out where your vertex is. So real quick, what was my P? What was my P and Q? Yeah, -3 and 3. So what's -3 plus 3 divided by 2? Yeah, 0 divided by 2. I always get a little weary when I see a 0 in division, but I think we're okay here. What's 0 divided by 2? 0. Okay, so I know that I just found my axis of symmetry is x equals 0. That is my AOS. It also is the first point to my vertex. Thinking back to how you found all those other vertices, how do you find that y? What was that? Well, I kept what you said. I think you said the right thing.
Plug it in.
Plug it into what? The equation right there. Yes, yes, good, good. You can just point, shoot if you want. Just that one, plug it in. Good. Yeah, so you just plug it in just like you did before. Nothing different. So I would just go 0 plus 3, 0 minus 3. So this would just be 3 times -3. What would that be? I didn't expect to pause on this one. What's 3 times -3? -9. Whew. Sweating up here. Okay, good. Yes, -9. Yes, that one's -9. So I found a whole bunch of information just now, just by figuring out what is the middle or what is the average of these 2 numbers. So that would just be 0. And since I don't want to draw 9 tick marks, you can just name the point. You're welcome to draw it if you like. That would be 0, -9. All right, I want to give you one that's a little similar. So y equals 2x plus 2, x minus 2, and I would like you to graph, and I would like you to identify the AOS and the max or min. Hopefully it's something you can do kind of all at once, but try this one right here. I think where are we on example 5. So E5, and then I'll come around one-on-one helping with any steps of those, but I'll leave that up there. Try to find those 3. If we find those 3, I'll do a little more playing around with this one and then start working. Well, ooh, there might be just one other piece to this, but we'll be done with these type of examples unless we have lots of questions. Okay. Any questions on that first? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 1 If you have some questions, I saw some great starts from everybody. Bo, do you have any questions on this one? Okay, so let me know if you have any questions. Yeah. Okay. Yeah. All right, I'm going to put mine up here quietly. Feel free to look up and let me know if you generate some questions. You don't want to look up.
What?
So. What was my,
Something
what's,
is not right.
yeah, what's my P and Q? Dylan? Right, so I have 2 plus -2, so I can just do -2. What does that equal?
0.
Okay, great. That's good. We're almost there. That is correct. So we got everything down to 0.
Oh my.
So my AOS is x equals 0. Great news. Yes.
I got it right, but I did the whole thing wrong. So I don't know. Yeah.
Oh, well, come look and see what you did. Maybe you found another way.
Okay.
You made a breakthrough in mathematics just now. Who knows? All right. So this 0, what do I do with this 0? Plug it in. Okay, and this is a tricky part for a lot of us, and that's good because that's totally normal. We're just learning this here. So I want to plug back in. For some reason, 0. This guy gets forgotten throughout the years. He just gets forgotten. So I got to do parentheses first with PEMDAS. 0 plus 2. What's that?
I think that's 2.
Hey, oh, good. Thank you. I think you're right. What's 0 minus 2? Trickier. -2. Good. Okay. If you just got -4 for your minimum, then you forgot your other 2. Because you want to multiply all 3 of these together. 2 times 2 is 4 times -2, -8. That gives me my last point needed. Questions on that? I've heard a lot of great things for the axis of symmetry. Getting to this first part, can you give me like a thumbs up, like I got the 0, this one I got close to 0, this one, I don't know what axis of symmetry is. Okay, good, so good. I see good things for the axis of symmetry. All right, and then Give me a quick read on understanding how I got this -8. Thumbs up, I get it. Thumbs down, don't get it, and in between,
Get
kind of
it,
get
but
it.
I got it totally wrong.
Okay, that's okay. We can work from there. Okay, I'll come around. I'll give some extra examples for this in just a minute. I want to do the last piece here, and we'll use the same equation just for the sake of keeping it simple. So I'm going to use this guy again. It's going to pull him down. So the same equation, I'm going to ask a different question. So I'm going to ask, what is this equation in standard form? What's standard form again? Dylan? Perfect. Still in the guess, right? That's good. Know what you meant. Yeah, so ax squared plus bx plus c, that is my standard form. So if this is my standard form, and I'm looking at this equation right here, and I know I need to do some math of some sort, more than two. If you just saw something like this, if you had to guess what you had to do mathematically, what might you try to do?
Right.
It is a form of distribution. It has a kind of a special acronym.
Foil.
FOIL, yeah. So what happens is if you FOIL a factored form, it moves it back into standard form. Now I wanted to do this example with you though, because that 2 throws a lot of people off. And so I think it can be tricky. So for the moment, ignore the 2. I'll put them in pink for now. So we're going to ignore the 2 and we're just going to do the inside first. And always start with the 2 factor stuff first. So if I want to FOIL just what's in the black ink, what's my F? What does F stand for? How about that? First, good, yeah, first. Yeah, so first, so I just have what times what? X times X. So I'm gonna go, what would that be? Okay, good, X squared. And so I got F done. What's O stand for? The outside, right? So here, O is on the outside. So I'm gonna have X and -2. Those are on the outside of my binomials. What's X times -2? Yeah, right? And so then I'm going to do inside next. So I stands for inside. What 2 terms are inside? Good. The X and 2 here. What's 2 times X? Good. Right. Yeah, we're kind of seeing a pattern here. And then L. What's L? Yeah, the last terms. So then it's just 2 times -2. We know that one. Perfect. -4. Now, you're going to deal with this 2 here, but on every step of every math equation outside of statistics, we'll get statistics at the end of the year, you always want to simplify if possible. Meaning, can I reduce? Can I put together like terms? Any like terms? Yeah, what like terms do you see, Anna? Good. What happens to those when they get together? They become nothing, right? Right. So then if I'm still having my 2 on the outside, what am I left with on the inside? Yeah, Anna. All right. And then if you had to guess, what do you think that last step is? Open to anybody. What do I do with that 2 at the very end? Dylan? You just distribute. So what does it give me? Okay, so just a reminder, leave the 2 out for the end. I don't want it to mess you up. So just do your regular FOIL like you know before. 2 just hangs out. And then once you do your FOIL, do your like terms. Then the 2 gets to everybody. And now you have something in standard form. If I were to ask you to graph this guy using your -b/2a, you would get the exact same thing as if what you just did to graph this guy. So all your equations can go to all 3 forms and be the exact same thing. Transitioning between those is what can be tricky. But for the sake of today, we're just gonna make sure we're using our factored form to transition one part to the other part. Questions on that one? I do want you to do just one of these because I do find that that number on the outside can be tricky. I'll make it small. And then I'll come around and just make sure, see if we have any questions. This will be our last example for today. So that's our last example.
You want us to turn that into standard form?
Yes, let me be specific. So yes, can you turn this into standard form for me?
Okay.
And I'll leave my last one up there. So can you turn this last one here into standard form? Let's see. Okay, let me know if you have some questions. I'll come around and help you. Or I'll just check your work if you like. So then, put parentheses, put the threes. And then yeah, so positive x and negative x. Close. I had an x, then I lost an x. So I gave you an x, took it away. Nothing, right? Good. So this would just be 3 parentheses. X squared. Something with that 3, you're on 3. All right, guys. The homework assignment is on the board up there where it says Algebra 3-4, page 15. I'll also put it on the big screen here too. But I see a lot of you guys have finished. Can I check anybody else's or answer questions on this side? Good, good, good. Okay, so if you got 3x squared minus 3, you're good to go. I'll come help with those. We have still some questions on this. In the meantime, if you want to, where's my teams? Teams, there you are. Here's the assignment. I have in the content library, if you don't have your book with you, I did copy this page, but I ask if you're going to do off of this page, please write down the numbers because I do not want you to do this whole page. You're just going to do a small piece of this page from your book. So the numbers are in teams if you want to reference it later, but here are the values here. And I'll come around and answer some questions in just a minute. So it's just 2, 9, 10, 13 through 15, 20 through 22, 30, 36 is 38. Looks like a lot because I broke them up, but I really just took a lot of problems out off that page. So go ahead and start on that. I heard some O's when I wrote that answer. Do you have questions? Yeah. What's this say? Oh, there you go. All right, it's on, if you're looking for the digital copy of the textbook, that one page I copied was just titled 921, page 15, content library. All right, yeah. Yeah, that's not due until Wednesday. Yeah, so if you are stuck on it, you want to work on advisory, or you have it tomorrow. So, yeah. All right, Bo. So our assignment is just going to be these guys here from our textbook. All right. If you don't have your textbook, do you have your textbook?
I do.
Okay, perfect. So you're free to stay on in case you have some questions, but you can also hop off and work on this as well.
All right. Thank you very much.
Yeah, you bet, Bo. Let me kind of start on, let's start on 3 to kind of really emphasize this right here. So on 3, I have kind of some complicated stuff going on, but I also have some non-complicated stuff. Start with easy. Dylan?
Power at 2, 4.
If there was an equals, yes, I could. That would definitely be the first step. I don't have any equals to justify that, which is a bummer. This 3, does he have a buddy? Yeah. Done? 7, right? So I have 3 and 7. Well, still ice cream, Sam. So I have 3 and 7. What's 3 times 7? Sam.
Wow.
That was kind of justice. It's 21, right? So that right there. So I know that's going to be at least some piece to my answer. And I can already start looking at less things. Now, fourth root's really significant because it tells us what to look for. So we're going to learn how to interpret these problems. And so we can figure out what we need to find. So if I have a 4 index, that tells me that I'm going to be looking for certain numbers. What numbers am I looking for?
16,
Yeah, so I'm looking for 2 to the 4th,
81,
which is 16, 3 to the 4th, which is 81, and 4 to the 4th.
156.
You do that in your head?
Yeah.
Well done. You play like that, was it 1024 or 2056?
2048.
2048. Yeah, that's what did it. Yeah, it is hard, but that gets you the numbers down. Yeah, so these are the numbers I'm looking for. I don't need to keep going. Like 5 to the 4th, I'm gonna bet that 625 is not gonna be in there. Good, you got your 4ths down. So my next step here is I have 3 and 7. So I have 3 and 7, and then I want to multiply this 8 and this 32. The reason I can do that is they're both 4th roots. They get along. 8 times 32 just so happens to be 4th root 256. What's the 4th root of 256? 4. What's 4 times 21? Done. So it is kind of a tough problem if you kind of try to do it all at once. But if you break it down into little pieces, it can simplify a little easier. At least I hope so. All right, so let's take it. Let's kind of do this at 2 now. So can I subtract 32 from 162? No, I cannot. These do not get along. So what I'm going to do again is take this in one piece at a time. And what kind of numbers am I looking for here? By raising hands. Anna? Looking for perfect squares. So it's a little smaller than these other big guys. So I'm looking for things like 4, 9, 16, 25, 36, 49, 64, 81, and so forth. That's as far as I need from this one. So when I'm looking for perfect squares, is it a better idea to go big than smaller or small than bigger? Dylan?
And small,
Big and small, how come?
because if you do big, then you don't have to do as much work.
Right. So if I pull a 4 out, but really the 16 was the biggest one, I have to pull a 4 out again. It's 4 times 4 is 16. So I start with smaller ones, I'm going to have more work. You can, but I recommend try doing the bigger ones first to save yourself some time. So I know that 50, this isn't 50, so 25 definitely couldn't go into there, but 16 might. Does 16 go in there?
Yes.
Good. So this would be root 16, root 2. And anybody see the biggest guy on this one? Owen?
We know.
Ooh, go bigger. Yes, nice. So this would be root 81, root 2. So I really like what's happening here. Because 81 times 2 would be 162. So I'm just rewriting these in multiplication form. Like if I did, okay, 12, I could rewrite that as, like, what's a way to rewrite 12? Yeah, 4, 3. What's another way? Yeah, 2 and 6, right? And you can even do like 12 and 1 if you want to be annoying. So that this would all be accurate ways to rewrite that. That's all I'm doing here. So what's the square root of 16? Good, nice, Adam, quick draw. And then square root.
You didn't even ask the question. Wanna do the-
Yeah, good, that would be 9. Are those by raising hands like terms? Or even a thumbs up, thumbs down? Yes, thumbs up. These are like terms. These are both root 2. So then I can treat this just like I would treat something like 4x minus 9x. It's no different. We first learned this rule with x's. This is just a different value. Different values do not mean different situations. So this right here is going to act just like this. What's the answer to this? This would be negative 5x. So what would the answer to the top be? Yes, and so that would be the answer to this. This would be negative 5 root 2, and then just kind of make sure this is 84. All right, I just want to set up a couple real quick, and then I'll let you kind of work, and then I'm going to circle around the room, but I'm thinking I'm going to come reconvene here for a couple of these guys. So for this one right here, yeah, Sam. That's right. And so if I'm distributing it to this first term, the first term means everything in between pluses or minuses. Does that 15 get along with the 2 or the 6? The 6. All right, so I know my first act here is gonna be 2 root 90. And then same thing with this one. What would this one interact with? Yes, so -7. You're right. All right, I'm gonna let you work on a few of these. I'll kind of circle the room to help you one-on-one. I'm gonna leave a little clue up here for those who get to 6 before I get back here. But these are some of our practice ones I'd like to go over, make sure we're well and ready. I want to see lots of A's on Tuesday. Trinity. Number 8, come help. Oh, okay, so. Those usually don't get on. Yes, and so when they have the same base. they divide into- Yep. Yep. Don't forget to check, see who gets out. Yeah. Done. They like terms? Yeah, so since they're not like terms yet, just look at, and do anything with 9.
So with 9,
I would. Good, nice work, Sam. Riley. So 9, so it's all about doing a square root. It's all about going out 4, 16, 25, 6, etc. Right, and so 90 just has this intent. So I have root 9, 10. That was a 2. So that'd be my first step. Yes. If they end up getting like terms and then go further, if not. One second, Sam, I have a question. Yeah, next up. 75. I don't know. Right. Brain and magic. Yes. 100%. This combination, this is nothing to do with this. It has everything to do with this. All of this is just-
Oh, here.
Technically, it's alphabet order. You use square roots last, but what do you have there? 3 on the inside. So how do you do a circle square? What's a perfect square? Yeah, so 4, 9, 16, 25, 36, 49. See if you can find one of those. Yes. So we got, so this became a 9 and a 10, right?
Root 9 and root 10.
Yeah, let's start at 9. 3. 3 times 2?
Yeah,
6. So that's 6 root 10
10. Yeah. So I have
minus
-2 root 3.
So this is 5 came out of here, right? So 5 times 7.
Oh, I don't know why I didn't say.
Yeah, these aren't like terms at the end. So you can have that.
Oh, that's it?
That's it.
I'm done here.
Okay. Yes. Yeah, that's it. Yeah. All right. requests? Right? The end of 4? Sure. Yeah, so looking at 4 right here. So if I have 4, I want to pull out perfect squares. So I have 2, I got root 9, root 10, and then I have 7, and that's root 25 and root 3. So this would be 3 times 2 is 6. And this would be 5 times 7, 35. And I'm done. So all I did was I pulled out perfect squares. And I pull out perfect squares because I know the answers to perfect squares. And the square root of 25 was 5. 5 and 7, those are the same type of numbers that get along. 3 and 2, that's the same type of numbers get along. Root 10 and root 3 are not like terms, so my job is done. Dylan. Sure. But first, any questions on that, Riley? Okay. Yeah, the temptation might be to go further, but no need. This is going to be your final results on your practice quiz here. Yeah. What perfect square is in 192? Close. Good. So 64. And then here's basically what you have going on here. You are dividing your numbers into 2 groups. Those that get out, those that have to stay in. And so those that stay in are the ones that we don't know the perfect square, or they're not enough to get out in groups of 2. So if 64 gets out, does the square root of 3 get out? Where'd square root of 3 come from? 64 times 3. That's right. I just separated this 192. All right. So technically there's a little 2 here because that's the definition of a square root. If I have m to the 9, do any m's get out? Yeah, that's right. So I know to rewrite this, I'm going to rewrite each detail out just so we can catch all this. I know that 8 get out, but there's going to be 1 left over. Because think about it, what's the better way we've learned to write square roots? Yeah, it's fraction. What fraction is a square root? Yeah, so technically, if you have a square root, that is x to the 1/2. And here's what we're doing. We're saying, okay, half is in the exponent. So we're saying, can we take half of 8? That's what we're looking for. I can't take a nice half of 9. That's a decimal. I don't want decimals in my exponent. I just want nice whole numbers. If it's not nice and whole, you stay in the house. So this comes out, does n squared.
Yes.
Yeah, do we know half of 2?
Yeah.
Yeah, so we know that gets out. I'm going to write each step out rigorously here, just to kind of show. So then these guys stay in. So I know part of my final answer will just have square root of 3 in m. What's the square root of 64? 8. What's 8 times 7? 56. Okay, so I know that's part of my final answer. What is square root of 8? I'm sorry, square root of m to the 8. Another way of saying that is what's half of 8? And so that would be m to the 4th. And square root of n squared. Yeah, canceling out. 2 perfect enemies right there. The squared and the square root. Those both cancel out. So this would be my final answer. Nothing else to do. All right. Noted. Dylan?
Number 5, you FOIL and
Yes. Yeah, let me start you out with this one. So for this one, this is a FOIL situation. So I just do first, remember, take this in pieces. What's 3 times 4? Good. So I'm just going to say, okay, this is 12. I also need to handle these 3's though. What's root 3 times root 3? Yes, 3, which is also root 9, which will get you to 3. So this would be 3. I'll make a little note there, which was a root 9. So that's first. Outside. Does the square root 3 get along with 5?
No.
Does the 3 get along with 5? Yes. 3 times 5 would just be 15. Root 3 just kind of hangs out awkwardly. So I got the outside. So that's just the rules of FOILing. After each F, O, I, and L, there's a plus, or if you put a minus, it's a negative value. Yeah. So now I got inside. What's negative 2 times 4 root 3? What does negative 2 get along with? Good. So negative 8 root 3. So I got the I done. And now I just have the L. Negative 10. So If there's like terms, I put them together. If not, I'm done.
12 and 3.
This would be multiplication.
Oh.
Yeah, so then this would be,
36,
yeah, here, and then 15 and -8, do those get along?
7 root 3. So it'd be 26. 7 root 3.
Got it.
7 root 3.
Yeah.
Oh, no, 26 would be 46. Maybe. No, maybe 26.
26. It's on the same side. There's no equal sign, so you're not flipping. You're just combining that terms.
So you have the 26 and 7, or not, you can't.
If this 26 had a root 3, you could, or if the 7 did not have a root 3. Yeah, just because there's no equal sign here. Everything's on the same side. So I have a positive 36 and a negative 10 that just comes out.
Is the answer 26 plus 7 would be right?
This. Yeah. Good. All right. This work working, guys. You guys are on it. Yeah, let me circle around, help you one-on-one, then I'll come back if I see a lot of the same questions here. Yanni or Ruth, do you guys have any questions on this? It's in your homework
Would
section
you
there.
subtract the 10 from the 36?
You would, yeah. So your final answer here, Yanni, would be 26 plus 7 root 3. That would be it. Let me know if you guys have some more questions. I got the volume up. I'm gonna circle around the classroom and see. I'll be back. Yeah, Dylan. Yes. So your first step with this one, see if you can look at it like this. It's -20/5. That's the. Well, what's going to be? Yeah, got it. That's work. All right, Sam. And Dylan, which one are you asking on? 7, same. 6. Did you start it with this? All right. Dylan, look at 7 like this. Okay, give me just a second. Nope, only because you're following these rules. So you have 5x plus 5x. This would just be 10x. The x doesn't change, so your root 12 shouldn't change. A little note though, you're really close to being done. There's a nice perfect square inside 12 that you want to pull out. All right, Dylan, you had a question on, was it just a check question or a stuck question? For which number? What'd you get? Reese? Yeah. Which one would you like?
I was looking at 1.
Okay. All right. Here, I'm going to do 8 here real quick. I think I'm going to get a lot of questions once you guys get to that one. Here's what you want to do with 8. You want to remember 2 things. First, these are 2 different notations, different forms of notation. Different forms of notation, they don't get along well. And so I can't make a squared into a square root, but I can make a radical into an exponent. How could I do that? I'm going to rewrite cube root. Anna? Oh, don't do any math yet. I just want to rewrite it. So I'm not changing it. I'm just saying exponent. What do you think? Perfect. Yeah, m to the 1/3. And when you divide bases, what do you do to those exponents? You subtract them. Yeah, you cook it. Yeah, that's it. That's exactly it. So I go 2 minus 1/3. Now, can I just subtract exponents like that? Yeah, I'm doing fractions. So what's that rule for fraction subtraction? Common denominator. Very good. So then I need this to be m. This would be 6/3 minus 1/3. What I did here is I just multiplied by really just a fancy value of 1, giving me a common denominator, meaning I'm going to have this. Now, if you got this far, I'd give you most of the credit. And what might help you see is, since I didn't tell you which form to write in, is a way to write this. I won't tell you the answer, I'll let you kind of guess, but the way to write this, the exact same thing would be this. Why is that not done? Anna? Yes. Perfect. Whenever you have an improper fraction, alarm should go off. If it's any value bigger than 1, then at least 1 gets out. Another way of looking at it is if I have a group of 3 that can get out, but I have more than 3 variables inside, then at least 1 group can get out. So you can look at it either way. So this could be rewritten as either m to the 3/3, m to the 2/3, or if you've switched over to radical, this could be 1 group gets out. So I'd have m, but then how many are left inside? 2. So I could simplify this to just m, or this. Either of these would be 100% correct. This would be like 90% correct. Just don't forget those few things. Common denominators, switching over the same forms, and making sure anybody who can get out does. So, Sam. Yeah. 6. Let's see. Are you on second step, third step? Okay, I was going to take a look here. Once you get out, nice work, Sam. Yes. Owen. For 6, yeah, that's exactly what you do. How do you foil one of these? Owen's got, or Dylan's got you. Anna, question? I can. Being the topic is rational fractions, there might be a couple. I'm not, depends on which inverse you're referring to. Oh, yes. Yeah. Okay, I'll set Anna up here real quick. Anna, take a look at it like this. This is the same problem. And if you can reduce or simplify, always reduce or simplify. Okay, what did you get for the next step? No, the 6 is just up top. You're 2 steps away from doing that. 6 square root what? Yep. And that 6/3, send any alarms off? Perfect. Trinity, you have a question? Yes, yes. If you can't reduce, it's always nice to reduce. 1. Yeah, 6. Let me write out what I got for the next step. So let's see, I'll go through mine here and see where we differ. So I have 25 plus 10 root 12 plus 12. And I have 37 plus 10 root 12. Oh, perfect. You're there. Is there any perfect squares inside of 12? Perfect. Good. Yes. Oh, nope. Yeah, multiply them and you're done. Yes, Adam. I can. You betcha. Let's see. Yes. Yeah. let's do 12 together. I'll come back to this, Adam, but take a look at that if you want to look at that. But 12 is a really good one because it's been a little while since we've done the conjugates. So the problem here is root 5 is down below. We don't want roots down below. It's already a messy number and it's really messy when it's a fraction. So I would go 4 minus root 5 over 4 minus root 5. I look to the problem to find my solution. So this bottom stuff was the problem. Therefore, I do the conjugate of it. But there's something really nice about conjugates when it comes to foiling. No oi, that's right. There is no oi. So I just need the full, just the first and the last, no middle stuff. So I go 4 times 4. Okay. And I go root 5 times negative root 5. Good. And then up top, I just distribute the 7. And then I'll let you do the rest. In about a minute or two, I want to do 14 with you guys. 14, you get through 14, that's the hardest one on here, I think. So we'll do that in a minute. Come around and help you guys one-on-one. Yanni or Ruth, is there anything on here that I can help you with?
I think I'm good.
Okay, let me know if I can help walk through anything. All right. Okay, checking them out. All right, Adam.
So, know how to get there. I don't know.
What's the square root of 9? Okay, it's 6 over 3. Because 3 is now outside underneath the 6.
Oh.
Yep.
Wait. Is the 10 just inside by itself then?
Mm-hmm. Yes. Yes, went on 11. So do you see how I separated these? And I reduced them. You always want to look for reducing whenever possible because it makes the rest of the problem always easier. So 20 over 18 reduces to 10 over 9. I know the root of 9. Yeah, and so now what I'm looking at here is I have 6 square root 10 over 3. Now, whether there's a square root of 10 here or not, that doesn't change the behavior of 6 over 3. There we go. Trinity? Oh, once you get that, once you get as lone as much as possible, you can flip both sides. Yeah. All right, guys, I want to do 14 with you. I think it's a tough one, so I think it'd be worthwhile kind of listening to this one. You get through this one, you can get through any of them like this. So what's tough about this is simply that I have 2 terms up top, 2 terms down below. So the problem here, is there anything with the problem up top? No. Is there anything problem down below? Yes, I cannot deal with this square root. So I need to do the conjugate. Dylan? In a minute. Yeah. So I'll scoot down 12. I'll do that for you. So I have this right here. And so then I'm going to go 5 root 2 plus 2. And it's going to be 5 root 2 plus 2. Now, I really like foiling the bottom ones. Why? What's true about conjugate foiling? Done. Yep, full. No oi. So I'm just doing the first and the last. Why do I not do the O and the I? They always cancel out. That's the properties of conjugates. Good. So I just go first times first. So 5 times 5, that's going to be 25 root 2 times root 2. That's just 2. And then the last would just be -4. I'm going to finish up the bottom before I do the top part. What's 25 times 2? -4. Okay, so the bottom, unless I have to reduce later, is done. So I want to kind of focus just one thing at a time here. Now the top, can I do full on the top? Why? Right, there's no conjugate here. So I got to do the full deal, the full meal deal. I have to do FOIL. So the firsts would be 20 root 2, because 4 times 5 is 20, and the 2 just tags along because there's nothing that's like it that it gets along with. Then the outsides would just be 8. What would the inside be? That's really the hardest one. Anna? Yeah, really good. Yeah, so root 2 times root 2, what is that? Yeah, square root 4, which is 2. Yeah, it's just 2. And 2 times 5, that is just 10. I'll make a little note above this here that I did 5 times square root 4, in case you're interested about what I did to that step. And then the last one is just root 2 times 2. Yeah, that one's a nice one. They don't get along, so you just kind of tack them next to each other. My only job here is simplify, meaning like terms or reducing. That's all I need to worry about. So I'm going to start with like terms first. Anybody get along? Yep, so I got 18. Anybody else? Yep, so I have 22 root 2 and 18 over 46. And it would hurt me to not give you full credit because you were so close and you got the hardest part down. How come you would not get full credit if this was your final answer? Trinity, a little bit. What was it? Yes, everything here is reducible by, yes, good. So this is everything reducible to. So this is 9 plus 11 root 2 over 23. That's our big boy of the day. Big guy. You'll probably have something more like 12. Yeah. Okay, I'm gonna do some questions here. So just when you guys get done with those, make sure you hand them in to Mr. Bishop. What I want to share with you today is I just want to share one idea with you. So you're going to need just a few notes for this. I'm going to break up today's class into 3 parts. So the first part is going to be me sharing some shortcuts and the big idea. The second part is I've created a mini Kahoot just so I can see if I need to give more examples on certain questions or less. Since I'm not there, I can't see what you guys are writing down. So it's a quick way for me to get feedback. And then the last few minutes will be, or last 15 will be allowed for homework and stuff. So homework or notes out for me. What we're going to talk about today, you can title it as 1.4a, and this will be special forms. And specifically, we're going to talk about just one of them called the difference of squares. Okay, I'm going to shorthand that. So special forms, the difference of squares. And I want to talk through a few things with this. So it's a factoring situation. So when we're talking about special forms, what I'm going to show you is by the end of class, you guys are going to be able to solve a problem like this in one single step. So right now with our current skill sets, if you were given some problem like this, you would look at this and say, okay, I don't have anything in the middle. So then it's going to be something that looks like this. I don't have a GCF. And so then you would be forced to use method 2 or box method, multiply the first times the last. And your first step on this problem is going to look something like this, which I hope you agree, that's really ugly. Figuring out all the factors of 784, that's going to take a while. And remember, mathematicians work very hard to find an easier way, and they have. And so by the end of class, I challenge that every single one of you, just like the last class, will be able to solve a problem like this instantly with one step. That is my goal. So before I get into that though, we need to understand some constructs about what we do when we think about numbers. For example, if I were to give you an example of, let's say, this is just going to be a little bit of a background. If I'm going to give you, let's say, the number 4, right? We look at the number 4 and it represents something. It represents a set of objects that I can count up. Now, the number 4 has many different forms. For example, I could also write something like this. This is just an irreduced or undivised 8 over 2, excuse me. So that's the same thing as number 4. If I just did 8 divided by 2, that would be the same thing. And I could continue on. I could say, well, this could be, 2 plus 2. That's also the number 4. Or I could do, 16 divided by 4 and so forth.
you've come to quickly realize that there are an infinite number of ways to write out the number 4. Now, up to this point, the most useful way that we write 4 has been this. On occasion, you guys have had to do common denominators where something like this might be useful. Today, I want to show you another form that's going to be very useful when it comes to solving problems like this in our heads. And that form right there has to do with the perfect squares. So the perfect squares. So perfect squares are just simply, if I were to write this in the form of a perfect square, I would just say 2 to the power of 2. So 2 to the power of 2, that's just 4. And there's actually a whole set of perfect squares. And if you're not familiar with these, it might be useful for you to write these down. But you have 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, ... It keeps going on. I think you see the pattern there, but that's just 9, 16, 25, 36, 49, and so forth. And our goal is we're going to be looking, we're going to be on the hunt for these guys so that we can write them as this form. So this right here, this is going to be the useful form. So for example, if I had, let's say, some number that wasn't on this list that was even bigger than this. So let's say I had the number 169. Let's say you're like, this feel like that could be a perfect square, but I'm not sure. Remember that there is a calculator trick to figure out some of the bigger ones. If you want to figure out if something is a perfect square, meaning it has a root or a certain angle it began to at, you would just find the square root of this. In this case, it would be 13. So if this ever ends up being a whole number, I know that I have indeed found a perfect square. So if I wanted to rewrite this in the form of a perfect square, I would just write 13 squared. So it's all about squares and square roots. That's going to be kind of the first skill set we need. So if I have a situation where I wanted to write, let's say 4/9, and I wanted to say, how can I write this as something squared? Then you might say, okay, the first pattern your mind might see is that I have a 4 here. Okay, I know that a 4 is one of the numbers I'm looking for. And so I could write that as a 2. And then I see a 9 here. Well, the 9 is one of my numbers that I'm looking for. And so I could write that as a 3. 2 squared is 4. 3 squared is 9. Everything in the parentheses gets squared. So that would be a version that I could write out. To give you another example, if I had something like 16/25, then I could do the same thing. If I were to write this as something squared, well, I just say, okay, what squared equals 16? That's 4. And what squared equals 25? That's 5. If you can master this skill set right here, then you have all the skills you need to solve something like this in your head. So there is the part with the numbers, but since we're in an algebra class and not an arithmetic class, we're really interested in the relationship of variables. The most famous one being the x. And so the x also is something that we'll be looking for in squared form. Now, here, we'll title this as these are our numbers, and then we'll also look at variables. So the easiest of the variables, if I were to write x squared, this one simply put is my x is just in the parentheses and I have a squared. Now the reason that I want to identify that is because the stuff that's inside the parentheses is the key to the shortcut. And so if I had x squared, that could simply be written as x is the inside and the square is up top. But where it gets a little tricky is if I had, let's say, x to the 4th. Now, the non-negotiable rule in all these situations is that I always have to have a squared there. If I can't find the squared, then it's not going to be useful for me, which we'll see when we come across our formula. So then when I have something that has a variable to the power 4, I got to think to myself, okay, how could I rewrite x to 4 as x to something squared? Well, in this case, it would just be x squared squared. So to put it in some messy English terms, what I have right here is I have 2 x squareds, which is the same thing as having 1 x power to the 4. And that pattern will continue. So this right here would be x to the 3 squared. This one right here would be x to the 8. So this would be x to the 4 squared. And perhaps you're starting to see the pattern. So long as I have that non-negotiable squared on the outside, I just figure out, okay, 2 times what equals my original amount. So I have x to the 10, that would be x to the 5 squared, and so forth. So the key piece that I want you to know is first, these squareds are non-negotiable, whether they're on variables or numbers. And second, if they're on variables, notice that these numbers have a pattern as well. So all of these guys right here must always be even. So this is kind of the predecessor to the secret shortcut, not the secret shortcut, but just the shortcut. So the shortcut is the formula here, and this is the big idea of today. So this is called the difference of squares. Now, kind of lucky for us, but not so lucky in an artistic sense, mathematicians are very practical. We don't name things to be creative, we name things to be functional. So the difference of squares is a special way to factor something where it literally goes a squared minus b squared. And this is always going to equal a plus b, a minus b. So a couple things to know. First is that both items here are squared, but then when I write out the answer, they are not squared. Second thing to note, and the most missed thing in this lesson, is that the difference, which means subtraction, is the other qualifier. So one, both terms must be written as something squared. Second is that it must be a subtraction problem. If both those things do not exist, then you cannot use this method. Let me show you a simple example to kind of start. So let's say you have a very small equation, such as x squared minus 4. This will be our first example. So x squared minus 4, here I'm looking at this, and your first job is, can I write both things as something squared? So the first one's not too hard. That is just x, I do the parentheses, squared. How could I write 4 as something squared? I know the mics are kind of hard, so I can't really hear you, but 4 can also be written as 2 squared. Now, the reason I'm doing this step right here is what I'm looking for is I'm looking for my A and I'm looking for my B. Because if you have your A and your B, you can write your answer. So then I can just say, well, my A is x and my B is 2. So this would just be x plus 2, x minus 2, and I'm done. Now, to parallel this with the formula that you are very familiar with, to step 2, write A and B. So to do this the old-fashioned way, if I have the exact same problem, so I have x squared plus 0x minus 4. So this right here, x squared plus 0x minus 4. So the old-fashioned way is I need to multiply something to the -4, but I need to add something to the 0x. So I'm looking at my ways. I'm like, okay, let's do out the multiples. I have 4, 1, 2, and 2. Well, I get to choose one of these to be negative. So this would be my answer. And so then I would just say, okay, x plus 2, x minus 2. Now, you look at these two examples and you think, okay, I'm not sure that the second one was really a lot more work or less work than the first one. So why do we have the shortcut? Well, the shortcut is really great for tougher problems. For example, the problem that we had at the very beginning. This is a much tougher problem, as we saw that it immediately goes to -784, which I don't know about you, I do not want to find the multiples of. So to do one example before we do that tough one, if I had something that, let's say, looked like, let's say I did 4x squared minus 9. Step 1, write each one out as something squared. And this is actually an optional step. If you see the squared terms, feel free to go forward. But if you're getting them wrong, then I recommend doing this step. So I look at this and I say, okay, how can I rewrite this term without changing value to have something squared minus something squared, the form of difference of squares? So the second one is actually the easier of the two, because I look at this and I say, okay, what squared equals 9? You guys are pretty familiar with something like that. That would just be a 3. So I just found my B. Now, this first term, that's where it can get a little tricky, because I need to have everything in that term be something squared. What's often forgotten is the 4. The 4 and the x both need to be in there, meaning 2 squared is 4, x to the power of 2 is x squared. So that would be my a. And that's where it gets a little tricky. So then in this case, now that I have my a and my b, I can immediately write my answer. So then I would just say a plus b, a minus b. And that is my answer. I want to do the problem that we started with as a tough one, but first I wanted to pause. Since I'm not there, I have trouble kind of getting a feel of facial expressions and stuff of how this is going. Does anybody have any questions or things I can clarify on these 2 examples? Okay, so let's do that. Feel free to raise your hand or let Mr. Bishop know if you have a question to me. I'm happy to stop and clarify it, but let's do that tough problem at the beginning. So that tough problem at the beginning, that was 16x squared minus 49. So remember, patterns and process, those are the 2 big things that we focus on this year. So when you think about patterns, you look at this and you say, okay, what patterns do I see? Okay, I see a 16, I see a 49. Okay, I know those are familiar numbers. And if you're familiar with your squareds, you'll see that 16 and 49 are both perfect squares. Those are things that we're looking for, which means we want to write them as their squared form. So 16 and 49, we know the square versions of those. 16, I can just write as 4, and then the x squared, well, the x will go in there. And then 49, well, that's just 7 times 7. And a lazy way to write that would be 7 squared. So now that I have these 2, remember, once you have your A, and once you have your B, you're good to go to write an answer. So in one step, we're able to jump to the answer of 4x plus 7, 4x minus 7. So now we just turned what was originally a very difficult problem with a negative 784 into something that took us 1 step to do. And I would bet some of you could probably even skip this step to write the a plus b, a minus b. Questions? See some nods, no. So here's what I want to do. I want to make sure you guys are getting this. And so I'm going to have you do a little Kahoot, and I will stop and go over the examples that we miss as a majority. I'll talk about the ones that some of us miss, and we'll just go through the ones that we don't. So if you could pull your devices out, I will pull Kahoot up here. I'll share this. So let's see. Share screen. Should generate here in just a second. Oh, and if you guys could, turn the volume down here. If you guys could please, if you use a nickname, please put parentheses for your name. I won't put up if you got it right or wrong, but that way in the background, I can see who might need just explained differently or who's missing stuff. So just please, if you use a nickname, put parentheses by something I know you by. Can't tell how many people are in there. Do we have 13 in there? To wait on somebody?
Well, you got 14 in here.
Okay, one more. Let Mr. Bishop know if you have any questions.
You don't need a fancy name. I think we're waiting on Yanni to get in there, Josh.
What about Yanni?
Getting in right now, I think.
Sorry, I can't hear you.
He's getting in. He's just getting in right now. Can you hear me?
Yeah, I can hear you.
All right. I think it'll be a second and he'll be in.
Oh, I see him. All right. Okay, guys, let's go through a few of these and we'll talk about the ones that we're mixing up a little bit. All right, x squared minus 25. Now the formula on there too is a nice little reminder. Really good. Great. Okay. So first step is find your A. Second step, find your B. And just remember it's A plus B, A minus B. Now, remember in multiplication, 4 times 3 is the same thing as 3 times 4. So if you did the plus first or the plus second, that doesn't matter, just so long as you have a plus or a minus. Good. Nice work. That was really good. Really strong turnout. All right. Number 2. Be very careful of order. Ah, yes. So this one is a good one. This split the last class too. So notice that I have 16 first, but X is second. So because the 16 is first, my 16 in this scenario will be positive and the X is negative. Now you think, okay, what's the difference? Is it really a big deal between positive and negative in there? Yes, it's a huge deal. If I came in and gave Yanni $100, but then I said, oh, no, actually, I'm going to do, Mr. Bishop a negative $100. Those are very different scenarios. Negatives mean a whole lot. So be very careful. If you have 16 as your first value, make sure that that's your A in your solution. So that's why this would be 4 minus X, 4 plus X. Okay, nice work on that. Oh, big upset. Good. Got a whole switch up. All right, this one's a little trickier. I did give you a little bit extra time on this. How could I write that first term something squared? Really good, guys. That's awesome. I thought this would be a really tough one. Looks like we did well. Good. So this first one could just be written as a 3y. So that would be your A, but that's awesome. Nice work, Dylan. Okay, this one's tricky. I didn't talk about decimals, so I'm curious what you think this would be. Be very careful with this. Calculator's okay. What times what would be 0.09? That's the hard part here. Really good, good, yes. So yeah, you might think, well, 0.03 times 0.03, that should make sense for 0.09. One of the characteristics of multiplying with decimals is your answer has the total number of decimals, meaning the reason green is right is because I have 1 decimal here times another decimal here. That's a total of 2 decimal places, which I see represented in my answer here. If you don't believe me, if you type in 0.3 times 0.3 in your calculator, that would be 0.09. That's a tricky one. Oh, a lot of movement on this one. Good. Okay, here's a bit of a tougher one. Can you factor this one completely? Extra time given. I was very subtle with some of the answers, so be careful. Really good, guys. Yes. 9C is your A, 12M is your B. Excellent. Nice work, Amelia, moving up to the leaderboard. Okay, let's try one now with some tricky variables. This one also has extra time, so take your time on it. How could I write n to the power of 6 as something squared?
Oh my God.
What am I doing?
Oh, no, it is.
Ah, yes. So this one's a tricky one. I might do another example after on this one. The tough part about this is understanding that n cubed squared is the same thing as n to the power of 6. So what's that saying is I have 3 n's and then I have 3 more n's. That's what the squared means. So it's a total of 6. I'm happy to go through that here. Let's see, what was the runner up? 2ab minus 11n, 2ab plus 11n squared. Oh, okay. So you guys, that might have been just the error of looking at the second part being a squared. And I wonder if we kind of got the idea after that. Good. All right, Reese, nice work. Number 1, Mike, number 2, Anna on the way up. Okay, a couple more. Factor this completely. I got a fraction at you now. How do you handle a fraction? Really good, guys. Yep, 4/5. That's my B. P, that's my A. Good. Oh, nice. Dylan, huge rise on that one. Reese hold number 1. All right, number 8. Factor completely. Be very careful. Ah, yes. So I remember this is the most missed thing about the difference of squares. The key piece to the difference of squares is it has to have a difference. If it doesn't have subtraction, there's nothing else you can do with this. So very careful of that. No, you're not alone. Last class had a tough one on this one too. Having a perfect square plus a perfect square, part of the pattern is there, but we're missing that other key tiny piece is that we need a subtraction. Okay, second to last one. Nice work, Bree up top. Remember what you do first. What do you always do first? Always look for something first. Good, yes. GCF first. Pattern. What's something that these all have in common? In every polynomial, I want you to start thinking that's always what you're going to look for first, because it makes a tough situation easier. So if I didn't take the GCF out, I would have to use box method or method 2, and those both involve doing 18 times 8, which is a huge number, and you don't want to deal with that. So GCFs, good. Okay, last question. Nice work, Reese up top, Mike right behind him. Last question of the day. Can you factor this out completely? Good, yes. So this indeed is our formula. This is the big idea of today. This is the difference of squares. So that means it would be a plus b, a minus b. I think that's Owen in the back. I'm not sure if I see hands going up. All right, let's see how we did. Nice work, Bree. Nice work, Mike. Nice, Reese, good job. All right, guys, I'm gonna switch gears here a little bit. So for the last part, what I would like you to do is, if you want to head over, I want you to have some one-on-one time to work on this. But if you want to head over to Delta Math, let's see, you sample student page. So 3. So you guys can see my, can you guys see the Delta Math thing on my end? Okay, let me share again. Okay, there we go. So here's what I'd like you to do. I can look and see the progress that you guys are making on my end about who's missing ones and who's getting them. So I have Teams open. I'll go in and check questions there, but let me know if you have some questions on this. The rest of the time is yours to just work through these one-on-one. So let me know if I can help, but the rest of the time is yours to start on this assignment. Friendly reminder, Friday, we still do have a quiz. It's just going to cover our forms of factoring and our 3 parts of our quadratics: intercept, vertex, and factored. So again, I'll have Teams open. Feel free to use that as a resource. I can send personal videos over based on the problem I see working on Delta, but the rest of the time is yours to work.
All right, so we're talking about Brenda and Leah and some investments here. Just make sure we understand how to set these up. Really, these problems are, if you convert your percents, if you write your equation out correctly, and you tap the right buttons on those calculators, you are good to go. The key part is knowing what equation, how to convert those percents, and how to mash those buttons. So right here, talking stuff about Brenda, what type of interest rate is, or what type of equation does Brenda need to use to figure out this future stuff? Compound, how do you know that? Because it says it. Yeah, this is great. Finally, math gets something like explicitly right as far as communicating things. You don't have to learn a certain term or anything. You just got to say, oh, how is it know it's compounded? It says compounded, which is great. What's the compound formula? Might as well follow up.
Oh.
Done?
P parentheses 1 plus 4 minus R. Other parentheses, P times R. No, P times N.
Perfect. Anything else?
A, I'm trying to type E.
That is if it's continuous. We're doing it. A-E. Good, yeah. So this is it right here. So then if I have, okay, Brenda's investing $4,848. I would just simply throw this in my calculator and say, okay, this is 4,848 times 1 plus rate. What I put for rate? 0.5? 0.05. Nice work, Sam. So I go 0.05 over in. What the heck is in? Sam again. Dose. Perfect. And then this would be 2 times 6. If you'd entered those in correctly to your calculator, hopefully you have, see, I entered this in correctly. $6,520 and 2 cents.
Wait, what?
Did I do something wrong?
Years? For 6 years? Let's get that, can you keep that up there real quick? I'm trying to figure out what I did wrong.
Let's see.
Can you
4848.55.
scroll over the, Whoa, where did the bar?
It's not letting me. So it's just, I think, so it's 2 times, should be 2 times 6. There it is. I don't, but some of your calculators you do.
Same thing. Oh, no, I put times 1 instead of 4.
Oh, there you go. That's the difference. Yes.
Wait, why is she still so broke? Dude,
Why is she so broke?
or why is she still, like, why did they make, why did she barely make any profit?
It's only 5% and it's only over 6 years. So
It's a long time.
it's not, unfortunately, a compound. All these things I'm showing you, these are the long games. So for example, let's say if I did this again, but let's say she waited till retirement. So let's say she waited 40 years, right? That's an early retirement. Now she's got 34,000. So not that great. So let's say she waited just 10 more years. So a little later in retirement, almost doubles.
Now it's starting to make it look.
That's why
If she waits.
if you wait, so most of America starts thinking about retirement when they hit 40. So they're like, oh, I got to figure out how to retire, because usually the 20s are more concerned with like, what does everybody think of me? 30s are like, I don't care what anybody thinks of me. I'm just gonna do what I want. And the 40s are like, I'm halfway through life. What am I going to do for the second half? You know, and you don't want to do that because, I mean, look at that. If you waited 10 more years, if you started 10 years earlier, so if you did something different than what Mr. Macbeth did, and you start 10 years when you get out of high school, that's doubling your money. I can't go back 10 years. So the amount of money I have to make up for not starting it in my late teens, early 20s is substantial. Where all you have to do is just make a choice that costs you nothing a little bit earlier.
This is gonna be enough though. It's like, I invest $5,000 now. When I'm 57, I'm gonna 60,000.
That's $5,000 one time,
Yeah, but like.
and that's
I need
one
more money
thing.
back.
Totally,
Yeah,
I
you don't
agree.
have to do-
Yeah, so if you had a job, you'll have, depending on the job you get, so if you work government, you'll have multiple retirements that get taken in your paycheck on that. And so this is just one thing. This was $5,000 that you put 40 years ago that turned into 57,000 for no work.
See, like, what if like America like collapses?
Then I think retirement might not be your biggest concern.
Survival.
Yeah, learning Chinese might be up there. Question.
What makes it 5%? How do you?
So that's just, there's a couple of reasons for that. So one is it has to do with you invest in something that's growing, so it has an average growth rate of how much it's worth. Another thing is if you invest in certain bank things, they pay you a certain percentage to use your money. And so if you're giving a bank money, what they're doing with that money, they're not keeping it. The average bank is like, if I go to try to rob Wells Fargo right now, they'll have about 20 grand. They have millions on the books on their accounts, but legally they only have to have about $20,000. You know what that other $800 or $920,000 is doing?
Go invest it.
Yeah, they're loaning it out to people for percentages. And so if I have, let's say, this is hypothetical, if I had 100 grand in my bank account, I go to Wells Fargo, okay, hey, I want to withdraw it. One, they'd be like, no, don't do that. We've got this. Two, they probably make me wait 5 to 6 business days because they have to collect that money from somewhere else, bring it in and say, okay, here's your money. So all the money they're putting in there, they only have a small percentage for you to withdraw because they are making a lot of money off of it. Yeah, for example, an average home loan in Tacoma, if they have someone that has good credit, they go in when the interest rate's low, they're making about $180,000 in profit just by letting you use their money. Now it's over 30 years, but you have in 300, 400, 500 different home loans. That's a lot of money that they're not working for. So they're paying you a little slice of the pie. Yeah, it's a pretty good slice when we use time on our hands. They're still getting a big slice of it. So that's how we make money, and that's how they make money. So yeah.
So what would Brenda need to do to get her?
different investment. I would say, yeah, 5% is lower than the index funds has ever been on average throughout. So the index fund is the average of the stock market over the last 100 years, including the Great Depression. It was higher than that.
So Brenda's just a terrible investor.
Well, she's probably just lazy. That's probably a savings account. Yeah, that's probably what that is. So that's a bank. That's a dumb. A little harsh, but okay. Glad that's on the recording. Okay. All right. Okay, so that's the first one. And then the next one's the same kind of idea. Did you guys get a chance to throw it in your calculator? Okay, because I'll just show you the result then if you just threw it in the calculator, just to see if we can compare answers. What on earth? Not what I want. Boy there. All right, so the second one is I had $21,360 and a penny. Does that bring up any questions for that button mashing? Okay, nay, we're good. Okay, I have kind of an important question here because this is the whole topic that we're on. Is can someone explain to me the difference between simple and compound interest? John?
Simple.
Simple. Thanks,
Who
Reese.
said that?
Front row over here.
Let me start with compound. Compound is like something multiple times. Like gather multiple times or something. So like the interest gather multiple times.
Mhm.
Simple and in months.
You're on the right track. Yeah, I like what you're saying. There's some few details there, but yeah. Yeah.
I don't know exactly what is the defined, but I know the first one on simple is just like and multiplies by the latest one.
And what do you mean by latest?
Just got. So it increases more.
Okay, I like that. Trinity?
Nothing other than the year. Compound is the same thing. Compound twice a year, and then you count the year.
I like that. Good. Oh, and you had something as well. These are all really good answers. These are great.
So compound, you put it up a certain amount of time during the year.
Uh-huh.
And when you do that, the percentage goes on to that amount. And so that amount then gets compounded by the next amount. And it keeps going throughout the year like that. So you add on the pile, but in simple, you only get the percentage starting amount that you spend.
Yes. So here, I like that. Let me give you some non-mathy visuals. All right. So simple interest. These are great answers. I want to clarify, just make sure everybody's on the same page for this room because there's a big difference. One's an eighth wonder of the world. The other one's just kind of cool. So simple interest does this. If you have, let's say, $1,000 invested, and let's say it is 30% that I'm getting. So after the first year, what is my interest? 30% per year, 1 year goes by. How much money did I make? Yeah. Yep, $300. So that $300 goes in a separate pile. All right, after year 2. So this is year 1. I made $300. And then let's do year 2. So year 2, 30%. How much money did I make on year 2? Just year 2. $300, right? And so I have $300 again, and that just goes in this separate pile. And then just to really emphasize it, so it's 30% still off the original 1,000. And then the third time, nice, you getting it. Yeah, so 30% on year 3 is again just $300. The two piles are kept separate. It keeps it simple. I have my money I invested, and then I have this right here. And then I don't get this until I withdraw at the end. And so I only draw interest off the $1,000 every time. If I do 100 years, it's be a long time. I only draw in $1,000 on that 100th year. Now, where it differs with compound is compound adds to the pile. So here is my pile, and here is my interest, and it throws it onto the pile. So my interest that I get each year is not going to be 300 every time. So this part, if I have this, let's do the same numbers. So if I did, 30%, and I did 1,000, this is 30%. But let's say it's compounded, well, let's do it once a year, just for the sake of it being the worst version of compound interest. So it's once a year. So how much money did I make my first year using compound interest? $300, right? And so I made 300, but here's what changes. Year 2, what's my pile? 1,300. Yeah, so what's 30% of 1,300? 1,300, it's $390. So year 2, I'm making $390. This is just compounded yearly. It's the worst of the compounds. Year 2, I made $100 more. Remember, it's a long-term game. Year 2, I'm already making $100 more. Think about retirement. That's great. So year 2, I have this right here, and again, it throws it on. And so what do I have in my? Yeah, so I have 1690. Again, I'm just pulling 30% off, and this is the worst compound, so I'm doing it just once a year. So if I do that, so let's see here, 0.3 times 1690. So now I have $507 on there. So that's 1690. So now my pile is $2,197. So compound means you're adding one thing to another, literally just as the English word. And so what I'm doing here is I'm adding my interest into the pile that makes my interest. That's the difference. Simple, separate for the whole time. At the end, you just kind of cash in and say, hey, I made the same last year as I did the first year. Still good, $300, that's great. Not that you're going to find a 30% thing. Let's use that for simplicity. But if you find compound, you can see that it very quickly grows at a lot more. This is only, year 1, 2, 3, 4, year 4. Now, granted, it's 30%, but you can kind of see the dramatic change between compound and simple. One is at long term going to take off and leave the other one in the dust. Yes. Okay. Just like that. Yeah, I didn't. Questions? Hand, Sam.
So, what if like some years are like worse?
I would say most ones will lock in for you.
Like it'll stay 30%.
Yeah, so like my home loan's locked in. And if you're doing index funds, index, those are ones that vary. So you're doing stock market type investments, those ones for sure vary, but long term, they balance out an average. So yeah, if you're doing it for 1 year and you have a bad year, for sure, not making much money. But again, even with the Great Depression, over the last 100 years, we have a consistent value. So we have a long history of being able to invest in something. Yeah. Yes. Oh, if it says continuously, you use this guy, APERT.
Is there a place for all these like equations? Like a place? Well, I don't know. Like it just seems like you have like your quarterly and then your annually and then your cumulatively. It's like
Yeah. Here, let me just put them out real quick and then I'll let you guys finish some work here. So. So basically is if you have simple, what's simple? Yep. Yeah, and sometimes you can do a 1 plus or minus R if you're doing with the rate thing, but those are, you can use both. And then you have compound. That's what we did for our warm up. So that would just be, total amount equals principal 1 plus R in T. And then you have continuous. What's continuous? Yeah, a PERT, just make sure that the ERT is in the power. Yeah, the only part you have to remember is when you're doing the ends or the compounds, just think about how many times that occurs in a year. So like biannually, how many times is that in a year in this class? Biannually. Biannually. That would work technically, yes. We'll keep it the other way.
No, wait.
So annually, what's annually? It's once a year. What number associates with bi? 2. Okay, so twice per year. Biannually would be twice a year. It's synonymous with semi-annually. Semi-annually is also twice a year. How many times is semi-monthly? Yes, and what number would I put in for N if it was semi-annual?
24.
24, good. Semi-weekly?
108.
108.
104.
104, good. Semi-daily, just kidding. But it's just twice, whatever that one. So semi or bi means twice. A little note, in the world, English screwed this up, but bi means twice a week or every other week. I will always use it for twice. Nice. Yeah, good. Okay, here's all I'd like you to do is I want you to just do some practice. I think you finished probably early, if not on time. This won't be homework, just judging by how last class went and stuff. I just want you to do some practice going over a few of the compound problems. I have multiple ones printed out. It's 3 times all over the place. Let me circle around to kind of help you as needed. And that's the plan for today, just to get you some review on those things. Any questions, Reese?
Is there a difference between the young and the people?
Nope. Ready?
So
Yeah.
it asks us to find
Mhm. Yeah.
There's certain equation.
Yeah, here, let me show you real quick. So it's actually the same equation. We just got to do one thing different. So let's say I want to set a goal. Let's say that I want in 40 years to have an extra 30 grand. Let's just say, yeah, I want to buy a boat when I retire. A nice one. 30 grand should give me a halfway decent boat. So that's my total amount. I don't know how much I want to start with, but I found this investment that, let's say, it's a pretty good one. It's a hot market. It's got about 12%. It's going to be compounded, let's say quarterly. And so I have 4, and then I have, what did I say, 40 years? 30 years. Yeah, really 30 years would be more realistic. Not down quick. And then this would be this. So this would be an example of like, okay, this is my goal. I want to have an extra 30. What would I have to do? Kind of side gig would I have to pull or whatever to kind of have a nice extra 30 in my pocket to retire with a nice boat. So how you figure this out is if it's unknown, what do you do with unknowns? You get it alone. And so from everything over, is that known? Yes. So I can do this little trick where I can do this exact same thing. What happens if I have something up top that's the same as something down below? It cancels. Yeah. So the whole thing cancels, and then who's left? A. What do I need to do in obeying the law of equality though? Because what do I do over here? What do I have to do over here? Yeah. So in my calculator, I would just throw this in. And that'll tell me how much I need to save. So let's see if I get in a boat or not. So let's see here. So this would be 30,000. So 30,000. It's money that I want for having extra money for a boat. And then I would just go divide and then just throw this in parentheses. 1 plus 0.12 divided by 4 to the power of 4 times 30. Oh, cool. $864.
No boat.
Well, if I throw in $864, that's like a couple weekends of door dashing. I can do it. Yeah, if I could spare an extra 864, I'll have 30 grand by the time I retire. That's a couple side gigs. Yeah, I'm kidding. Created a bunch of accountability monsters. It's great. I'm like hide my Starbucks thing. Ready? Yep. That's a one-time investment. Yeah. That's what you need to start with. Yes. Yes. How many years is that? 30 years. Yeah, 30 years I can turn this. Now this is a little bit better than a normal investment. So let's say I have a low end. Yeah, let's say I had there's a bad 30 years in the stock market. So I had a 0.07. So I had a 7%, the lowest the index funds has been over the last 100 years. So if that was the worst. So on the very low end, then I have to put in about 3 grand 700. That's it. The market is bottom. That put in about 3 grand. Now that's doable. I could scratch around if I did like 6 months worth of side gigs. I could throw in that. And if you told me, hey, if you just work a few weekends and work $3,000, I'll actually pay you 30 grand. I'd be like, yeah, sure. You just gotta wait. Oh, yes.
Do people put in like huge lump sums of money in that stuff? Like,
So what people usually do is they continually put money in. So like what I do with my Roth IRAs, every paycheck, before I can even see the money, $200 goes right into that. So I don't even have a choice. So I just pretend like I get paid less.
theoretically, you only get $200 that week, but oh, shoot.
Luckily, I'm on salary, so every week's the same. Yeah, so that's what I do. So instead of a one-time investment, it's a lifelong investment. So, and that's a little more advanced math than what we're covering. So we're covering kind of like the base model of this stuff. Yeah, that's called series and sequences that cover that
So
stuff.
people end up having that $12,000 they put in, stuff like that.
Yeah. So not only is your investment growing up, but your initial amount is also growing. So you have a double growth, which is nice.
So that's like double the growth of compound.
It doesn't double the growth of compound because compound is way more powerful than me just putting in $200 every week. Because it's taking that 200 and then adding interest. And so it's growing more where mine's consistently being 200. Yes.
Can you keep adding stuff onto like the compound, onto the compounding thing?
Yeah.
That's not the.
Yeah. So if I add $200, the compounded interest goes into that pile as well as my 200. So the
Okay.
pile is growing. Yeah, absolutely. There is no, that's true. There might be some exceptions that have higher interest rate that say, hey, we just need a lump sum now and leave it alone. I don't think so. Actually, I've not encountered that one. There is ones where if you pull your money out early, huge penalty. So my Roth IRA, if I pulled out early, I would lose a huge chunk of money. But if I wait till I retire, then I'm good. Yes. Yeah, it's a choice. So you can get paid. So I can get paid my normal salary throughout the months that I work, and then I won't get paid over summer. Or I can take a cut during my weekly ones during the school year, and then I'll get paid over summer. I choose that one. I don't have to, it's less work for me. Yeah.
Do you paint houses over the summer?
No, I'm not. I pressure wash. Okay, guys, let's use this time to kind of work around. I'll answer more questions, but I want to give you time to work. Then start working on the compound things. They're all over. Start whatever number you want. 10's the hardest, so if you want to get that out of the way, start there. 1's the easiest, so hope you start there. Scales as the numbers go along. Brianna, you have a question?
If you don't get this done, is it homework?
It is, yes. Yes.
Like if there was no yellow or pink.
It hasn't been homework yet. Everybody's gotten it done so far. Yes.
Kelsey said she broke math yesterday and I'm confused.
I don't know if she broke math, but she challenged that this does not equal this. So that's the current debate. How does it not equal?
Yeah.
Well, she's saying because this number is always continuing on, it's always changing by a little bit where this is not changing. So she says, how can something that always change be the same as something that does not? It's a good question.
Like one
I actually have like a 6-hour drive after school and then I have a college. I have a college tour from like 8 a.m. in the morning until
Oh
like
my
3
gosh.
p.m.
Well, we got 25 minutes.
Beth, I actually have like work today and then I'm going to dinner and then I'm going to a play and then that's it.
Oh, that's it? Nothing for the rest of the weekend?
No,
Oh.
actually tomorrow morning I'm not allowed to do anything.
Well, I don't think these are too intense. It's really just set equation and recalculator. So if there is some homework, I don't feel like I'm doing a lot of hard.
And then Sunday I go back to work, yeah.
Nice, yay. It is hard to balance school and work. That is a challenge. I always forget on this class. Okay. That was my fault. When you divide bases, what's the operation that happens to those exponents? Subtraction minus, yes. And so I have 4 up here, 3 down below there. And so what it kind of means is I'm canceling out 3, but really what results in the pattern is subtraction. So I have x to the 4th minus 3, which is, as Mr. Martin said, x. All right. Questions on any of the warm-up stuff? Sorry if I went fast. I think it looks like you guys are facing. Usually I can see the look. I don't want too fast, but okay. So here's the plan for today. I want to talk about a synthetic division. There are there's two ways to go about this. We're only going to talk about one today. And then depending on how it goes, we may play a game. You ever played dots and boxes?
Yes.
Okay,
Yeah.
I'll explain it in case you haven't. I think it's a fun game. I like it, but we might play dots and boxes, kind of a new element of a random factor in there. Depending on how this goes. So before you kind of get into these other methods, and Riley, if you're interested in following along on notes, these should be in your class notes section or content library. Just FYI, it's not an assignment, but just notes. But before you get into the complicated methods, you can always rely on some of the simpler ones. Meaning, if this first method right here, what this means down below is that I'm dividing this by 3x squared. I'm dividing this, oh, that's not a highlighter. I'm dividing this by 3x squared, and then I'm dividing which number am I? This by 3x squared. So it's just a lazy way to write 6 to the power of 4 divided by 3x squared, negative 15x cubed divided by 3x squared, and plus 3x squared divided by 3x squared. They're just lazy. Mathematics strives to be the most efficient way to do something. So if I had, let's say, just the first terms, 6x to the 4th divided by 3x squared, any thoughts on what that would be? What was it, Grant? Yep, good, 2x squared. What about the pink one? Minus 5x, and then someone else for that last one, kind of the tricky one, but not too tricky. Just 1, good. So this would be just 1. Let me real quick, if I gave you one of these sometime next week, give me like a 1 to 5 on how that would go. 4, thank you for the verbal. Okay, I'll skip to the next part then. If you have questions on those, I'm happy to go through it with you. Now, the other shortcut, which I hinted to in our warm-up, was you can figure out the ingredients of something and hopefully maybe cancel. How do you find the ingredients of, let's say, a trinomial?
Looking at the recipe book.
And what do you do? What's the math version of recipes?
Well,
Words, equations. Words, equations. Starts with an F. Factoring, good. Yes, you factored. Yes. So what it is it breaks down this equation right here. This equation is made up of something. A whole bunch of things came together to create it. Just like flour and water and eggs and salt. I don't know what else. Yeast, bread. Yeah. So just like those things make bread, there's certain binomials and variables and numbers that put them all together will make something in standard form. So this is, let's see, W. Good. I have minus 5, minus 2. All right. Do you notice anything? Oh, wow. That's funny. That tone. Yes. So you can do things like that. That will be a shortcut for you. Just to keep in mind, in the back of your mind, I'm going to throw a few of these that could save you some time. This was hopefully not a long process, pretty quick, as well as that one. I say that to say because I want to show you a process that's a little longer than this. It deals with a little more complicated situations. It's called synthetic division, and it's weird. So synthetic division, before I show you synthetic division, I just want to do a quick little refresher of some good old-fashioned division. Way back when. What's my first step that I do something like this? Great. Good. So I multiply this and I go below, and that's 8. And then I switch the sign. And then technically what I'm doing is I am adding a negative in this case. But yes, it's which is the same thing as subtraction. And then I'd have a 3. And then if I wanted to write it out exactly instead of having a remainder, does anybody remember what you'd do with that 3?
yeah.
Trinity, and then Yanni, maybe? What was it? Oh, I see. Yes, you do the 0.0. That's one way. Good, I like that. Is there, Yanni, do you think of a fraction way? What's the fraction way?
Put it.
Put this 3 right here.
You multiply by other mark.
And then maybe this 4 right here. This is old. This is a really old idea, and I don't even know how often they teach us in arithmetic anymore. But have you guys seen this before?
No.
Kinda? Okay, so
Well,
we're gonna see today. So this is one way to divide. If you did Trinity like you did, you'd get 0.75. So that would be another way to do it. What you do is you put the remainder up top and you put the divisor underneath. So I just move this 4 over here. So what this is saying in English terms is if I want to have groups of 4 out of 11 people, I'll have 2 groups of 4 and then 3/4 of a group left over. That's what's happening. I was able to get 2 groups of 4, but then not quite a complete group for that last piece. So I've written this out rigorously because we're actually going to use that multiplication, switching the sign, adding the negative in this right here. So here we have a synthetic problem. Letters, powers. So what we're going to do is we're going to get rid of all that. And what I'm going to do is I'm going to write this weird box. Some math books teach to put a little tail there. That's totally optional. And what I'm going to do is I'm going to take my divisor and I'm going to switch its sign. Kind of like what we did here. We switched that sign. So if it's a +8, it should be -8. And then the other piece I'm going to do is I'm going to write out all the coefficients. What the heck are coefficients? Yeah, exactly. That's right, man. The numbers right before the variables. You know what leading coefficients are, but it's not leading, it's just all of them. It's just 1, 3, -43. So I'm leaving all my variables behind. I'm going, okay, 1, 3, -43. All right. And just like underneath right here, we were adding, and up top here, we're multiplying. If you're in the, we'll call it the house. If you're in the house, you add. If you're outside, you multiply. So the first step is I just bring the 1 down. Since there's nothing to add with the 1, it's just 1 plus nothing is 1. And now that I'm outside, he gets pushed by the -8. So -8 times 1 is just -8. So he gets pushed back in. If it's inside, you add. So then this would just be -5. Because 3 plus -8 is -5. And on the outside, I multiply. So this would just be 40. What do I do on the inside? We'll do several of these. Inside, I add. So then this would be -43 plus 40. Yep, -3. So just recap what I did. 1 plus nothing is 1. If you're inside, you add. Outside, you multiply. -8 times 1. -8 is pushed back in. That's the answer. Inside, you add. 3 plus -8 is -5. What do you do on the outside? Multiply by what? Good, yeah. -8, which is on the outside. What's -8 times -5? 40. 40 gets pushed in. What do you do on the inside? You add. You add. -43 plus 40 is -3. This is actually the answer to our division problem. If I had an x squared and I divided out an x, what might the highest power of my answer be? You have x squared, but you divide an x out. X. Good. So I can automatically write x to the 1, x to the 0, and here is my remainder. So this would be x plus 8. So I'd have x minus 5 minus 3x plus 8. I'll do several of these. Not too soon for questions, but any questions to start? How did somebody come up with how to do that? That's a great question. They basically pulled apart this guy and tried to figure out how that would parallel this, but took out the variables. So this is a weaker but much quicker way. So like factoring and quadratic formula could both solve the same problem, but factoring was usually nicer. This is our factoring when it comes to division. I'll do just these examples today. So I promise the next Tuesday you guys will do these in seconds. Ready?
What's going on with the x's?
So since I have just an x here, and I have an x squared here and x and then nothing, since I started with the highest power of x squared, and I know I'm dividing x out, I always start with 1 power less. So if I have an x squared divided by an x, The highest thing I can have is just an x. So it always goes in order, just like this is the coefficient for x squared, this is the coefficient for x, this is my constant, this will be my x, this will be my constant, this will always be what's left over. So I always know that this first one is going to be one less than my original starting one, power-wise. So if it starts with an x squared here, my answer has to have an x at the highest. I'll do a few more, and then I'll take some more questions. Other questions though before I move on to another problem like this? 3 problems. Let's do, yeah, let's do this one. Okay. No quiz. Yeah, there's no quiz this week. So first step is I put in all my coefficients. I'll write out the steps here a little more, maybe that'll help. And then I do the opposite of my divisor number, meaning that's a -7. So I want that to be a 7. And then on the inside, I'll have 2, -16, and 19. Questions on how I set it up? Okay. Opposite on the outside, coefficients on the inside. What do you do on the inside? Add, that's right. So inside you always add. Since there's nothing below the 2 to add, it just comes straight down. That always happens. What do you do on the outside? You multiply. That's where we're going, yeah. So you multiply. So then I have 7 times 2 is 14. What do I do on the inside? Someone else? I know you got it, Owen. What operation do you do on the inside? Add. What's -16 plus 14? -2. So -2 comes out. Please.
Are you recording?
I am. Thank you. Yes. What do I do on the outside?
You get the multiply.
You multiply. And Yanni? What do I multiply the -2 by?
The 7.
Yes, good. The guy that's outside. Who's outside? These guys are all inside. So if you're outside the house, you get multiplied. So 7 times -2, what does that equal? Okay. 19 plus -14? Yep, just 5. I'll put a little tail here. Some people like to put the tail there to know that, oh, this has a remainder. Sometimes it doesn't have a remainder, so you don't need to write anything. Plus a remainder of 0 is insignificant. Okay.
Over 10 minus 7.
You're right. What do I put right here? N, right, because this was n squared, I divided 1 out, so this is going to be n into the 1, into the 0, which is no n, remainder. So then my answer to this division problem is 2n minus 2 with a remainder of 5 over n minus 7. Yep.
So why is it the 7?
You mean as a setup? Great question. So right here, what we're doing is we're kind of pulling this apart in a little bit of different order, but we're seeing some of the same flavors of this. When I did 2 times 4, that's on the outside, right? Outside is multiplied. 2 times 4 is just positive 8. What do I do to that 8? Yes, I switch the sign. And what do I do after I switch the sign? How do I get this? I added a negative. So on the outside, I have a negative. I'm multiplying it by a negative. I send it in to be added. So that's this. It's the same process. We just Frankensteined it all around in a different way. So that's why I have to switch the sign. In division, when you first learned it, you were switching signs. You were adding on the inside and you were multiplying on the outside. I just kind of flipped it upside down. Well, not me. I didn't invent synthetic. But whoever invented synthetic just kind of flipped it upside down. And so you want to have that same process, just in different steps here. Yes, Reese.
So why do you divide 5 by 7?
So this is just the remainder, and the rule for remainder is going back to this guy right here. So since this was my remainder, you can always find the exact equation of a remainder by doing it 3 over the divisor. Usually they taught in most schools that they're in with math. But yeah, so it's always 3 over 4. Which makes sense because I'm 3 away. Because 2 groups of 4 make 8. I'm 3 away from really filling the whole group. I only have 3 to fill the group of 4. Okay, let's try another one. I'll start with less and less steps. What do I put in that yellow spot? Good, yes, exactly right. Nice work on in Trinity. So this would just be a positive 2. What on earth do I put in the top over here? You guys are doing good. I want to see if I can press someone else for it.
1 5
Raise your hand. Yeah, hey. Xander, I haven't heard from you yet. We're right here. What'd you say? I do the 2's here, so you're right to think of the numbers. What's the coefficient of this guy? Close. Closer. This number is hiding right here. Yes, perfect. So this would be a 1. What's the coefficient of this guy? Yep, coefficient of this guy. Pretty close. Perfect. And perfect. So that's exactly what you would put down. Nice work. So then I would have a 1, a 5, a -7, and a 2. Yeah.
So even if you put like the 2 outside,
It would if this was a plus.
oh,
You always would. Yeah.
I missed that.
Yeah. Good question. Okay. How do I start this party? Yanni?
You put in the arrows for.
Yep, and I'm putting the arrows just to show you my thought process. You actually don't have to put any arrows. You're welcome to kind of just go to the numbers, but you're welcome to do this. So I just have a 1 down below. One. So I'm multiplying, so that's 2. What do I do on the inside? Add, so it's 7, 14, 7, 14. Perfect. Good. I think it's starting to click a little bit. This is my answer. It's just missing something. Oh, the letters. Oh, yeah. Yeah. And yeah, well, I think you're about to say something else, which would be correct. What goes here? Good. It starts with y cubed. I've divided 1 out, so that means my answer has to start with y squared. So my answer is going to have a y squared, a y, a constant, and my remainder. So to write it out a little more cleanly, it would be, oops, that's not it. Y squared plus 7y plus 7 plus 16 over y minus 2. Now, there's one more. It's the only other thing you have to watch out for this. It's not a hard thing. It's actually literally nothing. In all these problems, I've given you a very nice standard form, meaning I got a y cubed, a squared, a constant, or a linear, or a degree 1, and a constant. Or I did a squared, linear, constant. In this next one, does this follow down all the steps of powers? No. So this is a very delicate process, meaning it really relies on knowing every single coefficient. What's the coefficient of this guy? 1. Good. So the coefficient of that one is definitely 1. So oops, don't look at that. You don't want to look at that. So this is going to be a coefficient of 1. What is the coefficient of k squared? Very close. K squared. Is there a k squared?
No.
There's nothing there. Huh. 0. What is 0 times k squared? What if I threw that in there? What's the value of that? Okay. 0. So I added nothing to it. So there is a coefficient of k squared. It's just nothing, which mathematically is 0. So then I would need to make sure that I have a 0 here, then a -17 and a 32. That's the only trick you got to watch out for. They have to have every placement, including the constant. All right, now business is normal. What do I put here? Good, -5. So I got -5. How do I kick this thing? Standard? Yep, the 1 stays a 1. Perfect. And
You take the -5 and you multiply it by 1.
that's right. The 5 fights the 1, multiplies it back in the house. The house adds together. That's just -5. The 5 multiplies again. Good. And this would just be 8. This would be -40. And this would be negative. Yes. All right. What do I put next to that 1? Good. K squared. So this would be K squared minus 17K plus 30. Oh, what am I doing? What am I doing? I'm looking at the wrong problem. So this would be K squared minus 5K plus 8 minus. Good. That's it. And you're going to find next week that this is a very messy division problem that we are taking tons of shortcuts on. No variables, don't have to worry about any of that stuff. We're just doing some good old fashioned arithmetic in a weird form. And bring the variables back in. To the so you guys all get a scorecard. Yeah. Who needs one of these? Let's see. We'll just do one every 1, 2, 3, 4, 5, 6, 7, 8, 9.
You have to do math. What? You have to do math.
We do. No, not in that class. We'll have a power. We have a power of 3. We have a 3-power team. So you guys. You guys will be my 3. Oh, you already have one? Okay, great. Okay, great. So here's how this works. Riley, I'll explain what I have for you here in just a second. This is just a little different for the class part. So how this works is it's just dots and boxes. It's just dots and boxes. And how dots and boxes work is, let's say I go here and then I go here. I'm going to do a different color. I guess it doesn't matter. Let's say Yanni goes here, and then I go here, and then Yanni goes there. So, so what Yanni has to do is he would just have to go through this problem, and all you got to do is get to the remainder. So whatever the last number is your points. So for example, if this, I'm not going to do that one because I don't want to give away what that is. If you ended up doing this one, you would lose 8 points. If you ended up doing, let's say this one, you would get 16 points. It's whatever the last number is your points. And they range from -19 to +50. So the other rule is, let's say Yanni does this, and for example, let's say he got the 50-pointer. I'm not saying that is, I'm not saying that's not. If you if you complete a box, do you know what you have to do after you complete a box? Yes, you have. So Yanni would have to go again. So let's say Yanni goes, I go, Yanni goes, I go, and then Yanni goes here, completes it, gets another +10. Then he gets to go again here. He could complete that. And let's say it's a -40, and then he gets to go again. You're right. So every time you complete a box, you get to go again. So just think about that as you're going through them, that you're not setting yourself up to having to do half the sheet in one go. What do you want to do? Questions? Great. Let's see here. I'll have 3, 2. I'll have you go with Mr. Martin and then Xander and Owen. I'll have you guys play against each other. Yeah. All right. So go ahead. I'll come around. I can check answers. I can help you if you're stuck. All right. So Riley, what I have for you is it's just a math assignment. Excuse me, of the same problems that these guys are working. So it should be about 3 problems. It's synthetic division. You're welcome to stay on if you like, in case you have some questions. But if you feel pretty good about it, you can hop off too if you like.
All right, I'll just.
Okay, sounds good. It's fun. There's kind of like 2 parts to it. There's like a little bit of strategy to figure out which one it is, but there's a little bit of luck, because some of them are negative. You guys can all play on the same board and just keep track of each scores. So then one person would go first, and the next person would go, and the next person would go.
So for these guys right here, I'm going to break these down piece by piece. So we kind of already started the first one. This was 2, well, this is 2, and this is 4th root 256, and this is 4th root 3. This next one would be square root of 4, square root of 5, and there's nothing I can do with the last one. All right, any questions on that first step? So your goal is always to pull out the powers according to the index. So I want to pull out powers of 4. So I got 256, powers of 2, and then I look for powers of 4, but there's no powers of 4 that could come out of a 3. So at this point, just look at it one piece at a time. What's the 4th root of 256? Yes, 4. Yeah, great. If 4 times 4 times 4 is 256. So the root is just the reverse operation, getting us back to 4. So I know this is going to be 4. What's 2 times 4? Good. So I have 8, 4th root 3 for my first term. What can I do for this second term? Trinity? Yep. That's a 2. And what's 2 times -3? -6. That's right. So this would be -6. Root 5, and then there was nothing I could do with the last one, so I'm just going to bring him down. Now, these and this, these are both like terms. Both of them are 4th root 3. So whenever you have the same radicand and the same index power, it has the same property as if I had something like this. What's 8x plus 7x? It's just 15x, right? And so you're going to do the same thing, except instead of x, it's just some root stuff. So your final answer would be 15, 4th root 3, minus 6, root 5. Sam.
How did you return the 3 to? So I'm guessing that for the way you turned the -3 to -6. So did you pull the 2 from the square root of 4?
Yep.
And then you multiply them?
Yep. Just because that's what's connecting these two. It's 3 times square root 20.
Oh, so you completely got rid of this. Understood.
Yeah. So the whole reason I pulled out 4 is because I know the square root of 4. If you're not pulling out numbers you don't know the root of, then you're wasting your time.
Wait, so that's not the final answer.
This is the final answer.
Okay.
Yeah, Reese,
So
question?
It feels like 8 for square root 3 and 7 for square root 4. Could you combine those?
Mm-mm. The 3s have to match and the indices have to match. Yeah, good question. Anna? I would look in the content library at OneNote, and we're just going from ratios up till radicals. So, yeah. Yeah.
5.
All right, so this next one here, I want you to take special note of this. This is a tricky question. How many terms are in this problem?
2.
Close.
What?
Less close. 1. There's
What?
1. Yeah, so this is one entire term. A term is separated by adding or subtracting. This is a times -2. So this is all one term. There's no addition or subtraction here. So this is Frankenstein's monster of a term, more or less. Yes. So it's just one term. If there's just one term, you don't need to worry about like terms, because like terms is plural. It's where you find multiple terms, see if they match. This is not multiple terms. It's one term. So all we need to do is say, okay, if you get along, you go together. Meaning 3 and -2. Do those get along? Yeah. What's 3 times -2? Good. Yeah. So this would be, okay, -6. Notice how I always look at this in pieces. I say, I just look at the numbers first. Okay, got that taken care of. Now, these are both cube roots. So I can combine, so let's say the inside stuff here. So what's 4 times 14? Double it and you're good. Good, so I have 56. And then P5 times P6. Yes, good, so P11. All
Is
right,
there gonna be questions like this on the quiz?
Yeah.
Oh,
not this hard, but yes, these types.
This is like.
We just have all the.
I think so,
This is less
except
than
the
a-
5. I don't think the 5's harder. So
I think
the
it's
first
not-
one. So now I'm just gonna look to see if there's any cube roots I can pull out. I'm done. So here I have 56. Is there any perfect cubes such as 8 or 27? Does 8 go in there? Yeah, it does. And if you're ever wondering, okay, what are the perfect cubes? You just cube your counting numbers. You can just do that in your calculator if you want. You don't have to memorize them. So I know that's 8, I know that's 27, this is gonna be 64, so forth. So I know that 8 comes out. So I have cube root of 8. And then P11, this is kind of from a little while back. The doorman is 3. The cost to get out is 3.
Yeah, so
Wait, one second, Trinity. 3 can get out, right? How many are left behind? So I'm going to kind of separate these here. So I'm going to say, okay, this is going to be cube root P to the 9. And then I'm going to have your cube root P to the 2, because 9 plus 2 is 11. So I know groups of 9 get out. You don't have to write this step if you kind of see it differently and just kind of skip to the next step. That's totally fine with me. And then I have my 7. So I have everything here. I'm just going to do it one piece at a time. What is cube root of 8? Good. So this is going to be 2. What's 2 times negative 6? Okay, so I got those taken care of. What is cube root of P to the 9? Another way of writing that would be P is 9 over 3. So you can write it in both forms, doesn't matter which one for now. So that would be 3, P to the 3. Does P2 get out? No, he stays in. So I'm gonna have some stuff that stays in. Does this 7 get out? Nope. So I have my 7 and P2 is my final answer. Yeah, so what I did is I put everything together and then I saw who couldn't get out of the cube root. Those are my 2 thinking processes to kind of get those. All right, last one is just a FOIL. And I don't mean to say that lightly, but I think we're pretty good with FOILs. And so I just want to see if we can do them with this. So what's first times first? 6 times 1, right? So that's just 6. So that's first times first. What's the outside? Very good. Yeah, 6 times square root 5. So that's the outsides. The inside? Yeah, so multiply by the 1, so it doesn't change anything. So it's just a negative 4 root 5, and then lasts. That's the tough one. Oh, guys, I'm gonna write every step out, but what you said is right. So I have negative 4, what's root 5 times root 5? Yeah, it's just 5. Just to show you why, the square root of 25, that's just gonna be 5. So this would simplify to 5. And what's 4 times 5? Yeah. And then, do these get along? Yeah, both are square root 5s. So what would come of that?
Oh, it's like.
Yep. Yeah, be like 6x minus 4x. Same exact rules. That's right, Sam. All right. And does anything else get along? Yeah. So you could write the negative 14 before or after, doesn't matter. You wrote it like this would be okay too. Loif? You loifed it? Oh, all right. Okay. So just to kind of go over, I'm fine if you want to have a little note card for tomorrow. It's been a while since we've had a quiz. So the things to cover, the rules are all in your content library and your notes, but you have your rational to radical. So rational means if I had x to the 1/2, let's actually make that 3/2. What would that be in radical form? Reese?
Square root x cubed.
Yes, square root x cubed. Technically, there's a 2 right there, but we don't need to write that for square roots. What if I had something like 4th root x to 5? Could you do that to rational form? Dylan?
X5.
Yes, x5, yep, over 4, powers up top, roots down below. Think powerful, you're powerful, you're on top, the roots of a tree are down below. I hope that helps some of you. The other thing is, you gotta remember, if I had something like x to the 3/2 over x to the 1/2, what would I do there? When you're dividing bases, what do you do to exponents? Subtract, good. So this would just be x to the 3/2 minus 1/2. So that would just be, yeah, so it'd be x to the 2/2, but we don't need to write that. You just write x. The 2 over 2 is just 1. You don't write power to 1. And then if I had something like, let's say I did x to the 1/3 over x to the 1/2. Yes, good. So this would be, you want to have a common denominator. So this is 1/3 minus 1/2, or as Trinity said, 2/6 minus 3/6. What's 2/6 minus 3/6? All right, is it okay to have a negative for a final answer? Yeah, flip it, good. It's a flipper. And so this is 1 over x to the 1/6. It is ugly. Technically, there is something a little further that you can go, but we haven't gone there yet. We won't go there this week. What's another way to write 1/6 down there? If I want to write it in radical form. What was it? Yep. Can we have square roots down below? No, you can't have square roots down below, can't have fractions in the square root, no perfect squares in there. But just to say, we don't have to go further yet, but if that looks ugly to you, that's because there is more you can do, but not for tomorrow. Okay, so it will have some rational questions like this. Rational to radical, radical to rational, simplifying radicals. There will be some questions on domain and range, as well as end behavior. So does it look to the right? Is it going up and down? Does it look to the left? Is it going up or down? Yes? Let me hold off on that one. Yeah, just because I think it's a lot to take in, and it's not going to be on the quiz tomorrow, but I will show you, just not today. So we have domain, range, in behavior, and then you're going to have some questions on square roots, fourth roots, cube roots, the stuff that we're going to really practice today. Any questions about the quiz stuff? So you can have, oh, and then there's going to be movements. So, the inside, left and right, outside, up and down. So those might be really good things to throw on your note card, unless you have the movements memorized. Reflections, moving up, moving down, stretching, compressing, that sort of thing. Okay. Okay. All right. So that's what the quiz will cover tomorrow. There is one thing I want to show you with the square roots. It's something we've gone over briefly, but I wanted to kind of bring it back again. So it's this guy right here. So if I have 1 plus, we'll do a really small number. So if I have 1 over 1 plus square root 2, what's wrong with this? No square root down below, right? So there's something called a conjugate. What is a conjugate? If they've heard that before. Trinity? Yeah, it's the same thing, but an opposite side. So if I have 2 terms here, it's 1 plus square root 2. The conjugate of that would be 1 minus square root 2. So when you have these guys, because this is your problem, so whenever you have 2 terms, you want to use a conjugate, fancy one. And these are nice. This is basically what you're doing is you're foiling, but no oi. I don't know if you guys remember that before. There's no oi, so it's just full, or fluff, as the other class calls it. So because of that is, the reason for that is because that's a property of all conjugates. So I'll show it to you the long way, but you're welcome to do it the short way from here on out. So if I'm foiling this, the top's pretty boring. That's just going to be the same since it's 1. But if I'm foiling the bottom, what's first times first? 1. What's outside times outside? Yep, negative square root 2. What's the insides? Yeah, so right there, and then the last ones is just going to be negative square root 2 times square root 2 So that would be this. But what happens right here in those middle terms? That always happens every single time. That is a property of every conjugate. It cancels out the middle. And the reason that we like that is because it's canceling out our square roots. So our final answer here, this, I know the square root of 4 is just 2. So what's 1 minus 2? Yep, and then the top would be this. So you could write it like this, or you could apply the -1 to each of those. So that's how you take care of those. It's gonna be one of those problems today in the activity. So just to make sure we got the setup right, if I had, let's say 2, 3 plus square root 5, what would be the fancy one that would solve my problem? Raise your hands. Ruth? I like the 3 and the 5. Yes, perfect. Yeah, you're good. That's it. Yeah. And so then you do the first, and I'll do this a short way this time. So this would just be, so you do the conjugate of your problem. So if it's 3 plus root 5, 3 minus root 5 will cause the insides to cancel out. It'll get rid of our square root. So you FOIL, but you don't need to do the O and the I because they always cancel out in every situation. Do you have a question? Okay. So here I just go, what's first times first? Good. What's last times last? Yeah, what's square root 25? So you're welcome to kind of, since these are both the same, square roots cancel out. Yeah, so this would just equal 4. And then the top would just be 6 minus 2 root 5. Do you see anything in common? 6, 2, 4. Yeah, so it'd be 3. Nice work, Dylan. But the big idea here is just you pick the conjugate and then you do an F and an L FOIL to solve your problem. All right. Okay, so here's what we're gonna do. We have the things all over the room. I'll circle the room to kind of help you guys with the problems. 10's the hardest. Well, 10's one of these. And then the ones, the easier ones. And I'll kind of circle around and help you guys, but that would be what we do for the rest. Yanni, I have yours. Let's see here. I'll show you here. So share. Yours is right in the homework section. So this is kind of the room activity that everybody's doing. So if you go to
This is less of a warm up and more like a straight to the end.
yeah, it was kind of intentional. All right, so Yanni, these are what's around the room, and you can either write them on your own paper or write them on here, whatever is easiest for you. But these are the problems. I'll have the volume up, so let me know if you have some questions on some of them. All right, guys, go around, start whatever number you want. Yes, question. Yes. Yes. Other questions? Do I have what? Yeah. Are you okay?
Yeah.
Okay. Need someone to go with you?
Wait, I need to go get iPads.
Yeah. All right.
That thing is just so dandy.
So this
Has
is,
no
this is
hole.
that,
Yes.
but hard. Little.
You want to get started? Yeah.
I don't know if it's available, or there's a class. You should probably stop.
Relax.
Yeah, like I'm gonna cut the corner, but inside it.
No,
Inside.
make that noise.
What do you want?
Just for not interrupting.
It's so cool. No, it's not. That's awesome. Just get your muffler off. That's good. That's what I.
Ready?
It's basically. So you so this calendar. He didn't have a muffler. He just had a calendar. Oh, thank you.
Yeah, you play a good young Alfred. Young Alfred, oh, thank you. Are they ready?
Oh.
Okay.
One more. Yeah,
Oh.
take a break.
I don't know if you guys have some questions.
I contemplated just like this is too cold. I'm so cold.
I don't. Oh, sorry. You can head to the bathroom if you want.
Recording star.
Yeah, there's not gonna be a way to do this. Okay, all right, it's gonna do it like this. That's fine. Your choice. It's just in case we do a second round. You choose one of them. Okay, so I have 2x and that's 3x minus 10. That's the answer to that one. So it's just pulling out a GCF on that one.
Are you gonna give us the answer to all of it?
Just the first few. All right, here's the next one.
Yes.
What form is this?
Different oil.
Difference of squares. Very good. You can have your forms out if you like on your notes.
I don't think this one is solvable.
It is. Yeah.
I'm just gonna wait for the.
Oh, it is.
Yeah.
I have that one.
Nice.
That's so keen.
Oh, what we got?
All right. Just for your reference,
This one is.
that was the answer to the last one, so you can check to see.
This one's 4.
Yeah, this is an oldie. So this one right here, this is excuse me. Let's use, oh, I'm allergic to this problem. You can use box method or method 2. And so it's just an oldie one. So your first method is going to do method 2. For step B, you're going to multiply this over here. So you'll have x squared minus 11x minus 12. Then you want to factor that. The step you don't want to forget is bring that 3 back.
Yeah, you can click that. I don't think I have.
All right, steps are on the board there if you want to see. And that is the answer.
Oh, how did I miss that? Wait a minute. I'm getting pretty
No, it
close.
doesn't have to.
4 more to go.
All right, this one's up here still. If you want to take a look at it. What form is this?
I know. Some are cute.
Some of cubes. Good.
Thank you, let us know. It's x plus 5 and then.
Say macro, and you have all of them filled in.
Every single one.
Just a row, or a column, or a diagonal
4, 5 or so.
in a row. You have on the board too. Oh my gosh.
Oh, no.
This one
Listening back to you.
is a faker. It looks hard and big and complicated.
I can
Don't believe it.
Oh.
GCF. No special method here. Yeah. Yeah. So this one, is sum of cubes. So the sum of cubes. So the second part's gonna be a 3 part.
What's the answer for the one, the number 4?
It's in that form of blue.
Easy.
I don't know if that's true. There's the 4 is involved, thank you. All right, that one's written on the board, remember. What method is this? Algebra. What was it? Grouping, good, yes. So
What does grouping mean?
means you have groups that you find GCFs of.
Where about? Corey got that stuff like.
Corey.
Like that.
Nope, it's grouping. It was only did yesterday. Right, so your GCFs out. Ever seen anything here? You actually undistribute. this
Oh, yeah.
actually. So both of these are common, right? So they get undistributed to be. Huh? Oh,
So I've gotten to that space, like, we're totally not even supposed to be actually.
so. Yeah, right, so what you do here. This, right?
Yeah.
Do that with these.
So we don't have almost.
Well, say square this y.
Oh, no.
Nope, so don't square those. Because if I multiply this to here, and then this to here, I have the same thing as her. All right. Yanni?
I'm getting dangerously close to one, 4 more.
All right, well, here is a toughie. Hopefully not too tough.
So we don't have seven? That's the answer, please.
More than one.
More than one. Ooh.
Number one.
Yeah, that one's easy.
Yeah, what multiplies to this, it adds to that.
Those were two, good. Thanks, my big brain. No. That loans across Africa.
Johnny doesn't say a whole word for the next rest of the class, they would just not have points for that.
Yeah.
Yeah, we think better, or maybe like just 1 point off, like, I mean, 1 point, like,
For everyone.
yeah, that we don't have to do.
Sorry.
Except Johnny.
Oh, it's definitely that.
Oh.
Looks like you're not
Come on,
gonna be there.
again.
Yeah, he got you there.
I mean,
What form is this? Good, if it's a square.
Not that I know.
What was that?
I don't know how to do it, but that's the rules.
So this one's A plus B, A minus B. So all you gotta do is find your A and your B.
oh my gosh, what if more?
We need 2 more.
How exciting. My heart is racing. What is it?
I need.
Parties are racist.
Yeah.
Oh, it's that's funny.
Good eye, good eye. Jamie never had that in baseball.
Oh.
Why did nobody lie? In the land down under. Yeah, I did.
Brothers, one house, every.
Oh, wait.
There's one person every 20 square kilometers.
Oh, yeah, not my fault.
Yeah, but we have a.
Does anybody have any in a row?
Not yet.
We'll get them.
You want kind of close?
I got it. Yeah, I need more.
Okay, good.
Yeah.
You read one? Ooh,
No,
very
I-
close.
No, I have, I need 2 more.
I need literally anything. A word?
Can you do like 4 diagonals? No, 5.
Can you get 5 diagonals?
Oh, yes, you can. Wow. I'm not close.
I just need 4 more in a row to get things up.
That's it, huh?
Yeah.
Nice.
What's that?
Say 4 of them. Yeah.
No, this one's easy. 6x cubed.
Honey.
Can you kick him out?
Please remove him.
So the method here is just GCF.
This like that.
Yes?
Can we do the deal? That if I don't speak, then I won't get
Please.
No.
Or just see
Or
if you can do it.
That's a good one.
Silent game?
Wait,
My mom loves that.
what's that from?
Yeah.
That's right, Russell.
Fuck that.
Yeah.
No, we should.
No, we should watch
Yo,
Monsters.
guys,
Monsters
three
is
people.
so good.
Okay.
Can we like come in on like Wednesday and like get.
I mean, theoretically.
We just come in and watch a movie.
I think we suits in your open. If they're not suits in your open.
I'll come in on my break.
Yeah, what form is this?
Standard cube.
Some cubes, good. Some cubes. Now, tomorrow on the quiz, I'm gonna give you all the forms. So you don't have to memorize them, but you do need to know how to use them, and you do need to know the method of grouping.
All right, how do you do this one?
So your first step on this one is going to be to identify your A and your B. And then once you identify that, you'll just throw it into this one. That's
We have 3, I'm getting 3 in a row.
Yeah, so again, just find what cube equals 64x cubed, and then what cube equals 1. And then once you have those, plug in and you can go.
Nope.
Are we
Can you show us the answer for the last one?
Sure.
What? What? This one? Oh, this is the next. You try to make it so I get it. I need one more, but I am just too quick. Oh, this is one of the ones that I have.
two that have the same? Like, I have I have two of the same answers.
Where?
You can't back this.
Nice.
What?
That's lucky.
Oh, Mr. Macbeth. Oh. Oh. Oh my God. That looked like the one I had.
Oh, I'm one away on three different roads. Mr. Macbeth.
Me too.
I'm one away from that. Three different ones.
Oh.
That's really
Can't do 8. I mean, you can't,
It's not an answer. Yes, it is.
Okay.
One of them, yeah.
It is gonna say that. What is it that?
It's a very tiny number.
yeah, it's 2.
Oh. You're right. Can you show the answer? Yeah, can you show the answer?
I'm gonna wait a minute though. I'll come back to showing the answer. Sure.
What? Oh, this might be the first one I don't have a thing for.
What? Oh,
this
never.
But the answer, click for.
Click
answer.
it.
Click it.
Are we okay for answer on this one?
Yeah,
Consensus?
yeah.
What?
Oh, I knew it. I knew it.
So your A is just going to be 3 times 3 times 3 is 27. So that's my A, and then it has to have an X with it. And then what is 8? 2. So once you have those two pieces, you just plug into this form right here.
Oh, I still don't have that one.
Oh, all right. Let's see. This isn't a trick one.
I know, it's just.
Johnny.
Funny.
I don't have this one.
Just feel like every time anybody talks, then they will say that point. A little hard.
No, I bet you, yeah.
Well,
Oh, yeah, we need to be. You looked at my car. Oh, this is the difference. He's trying to go to the clip.
So this is either box method or method 2.
Oh, I know this one.
So you're
It's no. 3x minus 3x.
2. It starts out with -12. Oh no, I think it was with a 3 before.
It
Let me look.
Yanni, you're killing me.
Click the answer for answer, yeah.
No, it's too easy. Wait, can I just tell everyone?
No, we didn't do this one before. We had -11 before.
I believe that I got it right. Dude, I didn't get it right. No, I don't have it. I did.
Owen?
Oh, I didn't get it right.
Question?
I'm just kidding, I did. Can you answer it? Sure. Oh, you almost done? I wanted to get 8 more. Total. 8 more black.
It's so sad, we work so hard on college, we don't have
This one is the double one.
Is it?
Yeah.
Oh, nice. All right, we'll check this one, kind of see where we're at.
I only need one more.
I knew that one.
one tiny problem.
Nice. All right.
I don't know.
Did we?
Yeah, we've already done this one.
No, we haven't.
Yeah, we have.
No?
It was.
No, we haven't.
No, we haven't. No, we haven't.
I don't think we have.
Why did
No, we
you have
haven't.
to ruin my surprise part?
We did one similar to this. Maybe we did this one. Okay.
Yanni,
No yelling answers.
you're literally driving me up the wall.
Well, then come down off the roof. Say it, drive these beats on. Why
Oh,
does nobody laugh?
because you're not funny.
It is actually.
What? Just need one more.
I think
Why does it say wedding?
Oh, I got a math though.
Math
What?
though? See? We checked.
I've done so.
Here.
He cheated.
You just said he's lying.
Yeah, he just said he was lying.
That's good. That's good. That's good. That's good. Got a math though.
Math done. I math done. Look, I got math done too. Let me just X out all of my.
Can we get 2 minutes for this one?
I
literally-
1 minute per round. That was what.
No, there are literally 3 places where I could have a.
Blackout.
Oh, I'll go for a blackout for another one. I'd be up for that.
Yeah, I just got it.
Did you?
Yeah, I just.
Did you really?
You just X'd out all of them?
I don't think we should do blackout. I think we should because
I think we should.
do bingo.
I think we should, because it's a.
We've only got
1 in
15
14.
minutes, folks. Yeah, the
There's,
last
Yeah.
one took a while, and so
yeah,
let's just continue.
blackout would be shorter than doing a new round.
Well, then
Yeah.
let's just
Sandra?
do that. Blackout on all of it.
Oh, no, I just.
Is that
X'd
this
out all
one?
the ones that I had.
That was.
Dang it.
Or can we do 4 corners?
Is the exact
12.
place to click out on the other side? Look, I just X'd out all of it.
I'm not, oh, this one? It's this one, right?
No.
This one? This one?
Oh, the rush one.
This one? This one? I don't know. All right, we'll go for blackout.
On the same page?
Yep,
I
same
just X'd out all of mine.
That's too bad.
Oh,
shut.
Uh,
No, I never will
All
put
right.
anything.
You know what that means?
Here is a grouper.
It means.
Oh, this is a good one.
Get
Yeah.
the-
This one you might see tomorrow.
Oh. Another day.
What? Oh, yesterday?
Uh-oh.
The grouping? Yeah. Sure. This one would be a good one to show the answer on.
Oh, I know this one.
I've come to the conclusion thinking that this problem is unsolvable.
It's very solvable.
This is very confusing.
This one has more answers than even we've come across.
Mr. Beth, I think we should not have this.
Oh, sorry.
Group is maybe on there.
I was gone for one day and I missed the one thing.
There'll be more than just this on here. We come see me advisory or something, I'll help you.
I
I'll
don't
walk
have
through this one
advisory, I
too.
have, knowledge.
I'll be here after school too. Or during lunch.
There's no way I don't have. This is so hard.
There's
to
also
find the
recording too, if
answer.
you want to watch that.
It's too hard to find the answer. I X'd out a whole thing.
Yes, you did.
Mr. Beth, have you seen that math video about like the guy with the math professor with the chalkboard who can do like dotted lines like incredibly fast?
It's in the perfect circle. There's a world championship they hold in Las Vegas for the person that can draw the most perfect circle. They're pretty intense.
I won.
And it's pretty impressive, the one who won. I was like,
I
that's
won.
perfect circle.
I won it.
All right, first step for these. Let's walk through this real quick.
Put it in.
Good, yeah, I'm just looking at one piece. and the
Oh
other
my
piece,
gosh, every
Right?
time.
So I want to look at the GCF just on this side. What's the GCF just on this side?
X squared.
Yes, good. So I have an x squared, leaving me with a 3x plus 2. What's GCF on this side?
Nothing. Negative one.
Nice, yes. 3x plus 2. Okay, so to reference old idea, this is not a new idea, it's a new form, but it's really an old idea. If you had something like this, what could you do with those y's? Yes, undistributed or factor around, both work. So my y would be out here, and I'd have x squared minus 1, right? Okay, that's all I'm doing right here. These are my y's. Doesn't matter, there's multiple terms. I'm going to take each of these, and I'm going to put them on the outside, just like I did with this y. So on the outside here, I'll have 3x plus 2. And on the inside, what am I left with? Good. So all I did is I undistributed the y, or I undistributed these two things to be on the outside, just like I did with this y. Anything else I can factor here?
The X minus 1.
Good. What form is that? Difference of squares. So this would be x plus 1, x minus 1, 3x plus 2.
I swear.
All right.
So, I need 12 more for a blackout. Okay.
All right, this guy.
Let me do this. Yeah, this one's pretty tough.
I hope it's not super tough.
Then you have to work on that.
Yeah, this one's pretty
Oh,
Math. I'm gonna assume that I don't have this one. Did you watch this big one? This big one last night?
No.
Oh, look, this is the one I needed for a math.
Somebody's got a current phrase.
Oh, okay.
Wait, go back. Sorry.
You're right on the board.
Oh, sorry.
We're making the game not fun every time now.
Oh, that's true. That was a tough one.
Adam, you're a naughty boy.
That was destined to be your sheet, Dylan.
I need 13 more. There's one other one.
That makes more sense.
Oh, right. Well, you look at that, a math though. All right, what's the answer to the last? It looks so easy.
This one right here?
Yeah.
Yeah, what's your A? X. What's your B?
Is
What
this
form
one a
is it?
new one?
Oh.
Is this one a new one? So then it's this.
New-ish.
Oh, another math though. No, what do you know? I just need 1, 2, 3, 4.
What's the answer for 16?
That's right, Beth, are you recording?
I am.
Can you rewrite it?
What's the answer?
I'm not gonna tell you.
Why? Could be the chance between you getting blackout and not.
You're that close?
No.
You don't-
he
you
definitely has to be
Yeah,
cheating.
blackout, that's fine.
He definitely has to be cheating. There's no way he just remembered all of
Dirty rotten.
I'm pretty sure it's That's really bad.
Yeah.
What's the answer for 16? Hey, Dylan.
What do you think answer for 16 is?
4.
No?
A.
What's your A?
A.
Mhm.
A is X cubed.
I just did it backwards.
What's the answer for the last one?
I'm.
It's not a big one. That's method 2 for the last one.
What's this one?
This is method 2. On method 2, I write it down. Yeah, that's right. Let's see, so 17, I'll ask you the other special ones. Not memorizing, I'll give you tomorrow, but that's 17.
Yes, I got this one. X minus 17. Oh, another method. 7.1111. I've done 3 methods so far.
17. What square root is this? Yep. X. And this would be 8. Let's take the squares. Yeah, this is squares, and then you go plus B, A minus B.
What's the answer for 16?
Plus 8.
Oh.
Yes, minus 8.
Bad.
Yeah. It's up there.
16.
That's not-
Just like that.
Yes.
I think I know the answer for 16. You got like 8 minutes left.
This is it.
Yeah.
Is it X
Are you
minus
gonna
1?
have the, you're gonna have all the forms like,
Yes.
are you gonna write like the A plus B, A squared plus B?
Yeah.
A, B.
Yes. Yeah. The only thing that won't be on there is how to use grouping.
Okay.
That won't
But
be on there.
you'll write like sum of squares is a. That's
Yep.
all.
Yep, you'll have the difference of squares, the sum of cubes, and the difference of cubes. You guys just want like a brain break for the last 10 minutes?
This is
Okay.
right. There's literally 5 seconds.
Whoever's closest.
But if you're down for that. Oh, yeah, yeah.
I'm just gonna choose all 4 of these seconds.
Okay, whoever's closest
No homework tonight?
Whoever's closest wins. I have 3 now.
Liar.
There's to make bets and check mine.
We'll see, I mean,
All of the
highly
highlights.
suspicious.
No, the other one.
All of them. They're all. NBA.
The highlighted ones are the ones that. One. And then I just. And then this one's where.
All right, guys, have a good Thursday.
Ready for my extra credit point.
I'm sure you are.
The one that you're not gonna receive. Or the one that you're not gonna receive. Oh, what he got you children.
What? Reese is out there, you gotta
Yeah, he is.
roll.
Yeah, he is. Yeah, he is. Okay, so right here, I need you guys to dial in. Today is kind of a hard lesson, so it's going to take a bit of brain work on this one. So 1/2, that is just another way of writing square roots. We are leaving square roots behind. Eventually, square roots will be just not a part of the equation anymore, and we'll only be dealing with them in this, whether it be in a future science class or a future math class, whatever it might be. That is a limited way to do difficult mathematics. So this way, it's a different notation, but you're going to find towards the middle of this unit, it makes hard things way easier than dealing with lots of different square roots. So this right here is just saying that everything in here is square rooted. So if I want to write this just in radical form, it would be something like square root of 9x. Now, do I know anything in there? What do I know, Adam? Yep, I know that square root of 9 is 3. So my final answer would just be this. All right, any questions on that first one? Okay, let's go through a few of these here then. So this next one, so I have 7/4. This is where the idea is starting to get a little trickier. So 7/4, something to note about this, come on, focus. There we go. So 7/4. So this right here, there's one whole y plus 3/4 of another one. How did I get that? How can I say that there's one whole y and 3/4 of another one? Dylan?
Because I'm not as bad at it.
Yeah, so here, I'm gonna write it like this. So I have 4/4, and then this is gonna be 3/4. Because when you multiply bases, what do you do to the exponents? Hey, fellas. Hey, dial it in, please. So if I multiply bases, what do you do to the exponents? You add them, right? And so I've kind of unadded them. I just pulled them apart because I have a whole one right here. And if you have a whole one, then that's just a y. So here is just y. So I have a y on the outside. And then this part would just be, let's see, which one of these is the power?
The 3.
Yes, the top one, right? So the 3 is the power, the 4 is the root. So this would be 4th root y3. So basically what I did is I used fractions to figure out what y could come out of the square root. So remember before in square roots, we always pull out perfect squares. Well, you can do that in 4th roots and 5th roots and 10th roots, but it's really easy is you just figure out, okay, how many whole numbers can I get out of this fraction? So if it's an improper fraction, at least one. Adam?
So the 7/4, you pulled out 4, 4, and 3/4.
Mm-hmm.
And then if it was just y3/4, then it would be 4 square root y3. Since you have a y4/4, you just put a y on the outside.
Yep, because what's 4/4? 1, right? So this is a whole y that got out. So another way to look at this is, one sec here, Reese, is I have, let's see here, if I wrote this originally as 4th root, and then I have a y to the 7. So I just rewrote it this way.
Oh, yeah.
So you got to think of it like, this is the doormat. And this is what it costs to get out of the house. So square root costs squares to get out of the house. The 4th root costs 4s to get out of the house. So if I want a y to get out of here, it's gonna cost them 4 to get out. So I'll have one y that gets out. And since it cost me 4, I just have 3 left over. Yeah, so both ways are kind of ways to describe it. I'll try to think of a third way. Yanni?
Can I get a drink? I did all of mine.
No, I'm gonna have you watch this one for now. After we do the work part, you can. Sound good? Okay, yes.
Could you go from 4 square root y7 to y square root 4?
Oh, it's supposed to be a 4 here,
No, no,
sorry.
but like-
There's supposed to be a 4 right there
Oh,
still.
okay.
Sorry.
No, it makes sense.
Yeah, you're right, Reese.
And
Okay.
you gotta-
Let's try another one like this before we do another example here, just to see. So I want to see if we can really get there. So if I had, let's say, y to the 13 fourths. So first thing you got to ask yourself, is that an improper fraction?
Yeah.
I'm just making it up. Yeah, I'm just doing another example so I can explain this a little better. How many whole numbers are in there? Good. Okay, so then what I could do here, you don't have to show this step, but this might be another way to kind of show this, is I know that there is 3, I'm assuming that's where you got your 3 from, and then I have 1 left over. So one guy didn't get out, but 3 did. So this would be y cubed, 4th root y, if I wanted to write it in radical form. Let me try another one. So what if I did x to the, let's do 10 thirds. Is that an improper fraction? Okay, how many whole numbers are in there? 3. Yep, so 3 get out. Good, good. I was trying to get this. So this would be, just to show you, I have 9 thirds. That's where we're getting the 3. And there's the 1/3. So 3 get out. So this would be x cubed. But this guy is a cube root that stays in. Another way of looking at it is if I wrote this the other way right off the bat. Let's see. This would be x to the 10. So if it costs me 3 to get out each time, so it would go to 7, then it will go to 4, and then it will go to 1. So 3 of them got out, they were able to pay the charge, causing this just to be x. How are we doing with this? 0 to 5, I gave you one just like this. You're doing okay, some thumbs up. Okay, sideways. Okay, let me try one more here then. So, hey, thank you. So if I had, let's say, let's do z, and then we'll do 15 halves.
Oh, 7 could get out.
7 could get out with 1 left over.
Good, yeah, that's it. And so I have right here, so I have z, so I can go 14 halves, and then z 1/2. So the 1/2 is my square root, so that stays in. That's z. And then 14 halves is my guy that got out.
Do we need to write the z 14 halves and z 1/2?
Nope.
Yeah.
Nope, you can skip right to this.
Z7 and then square root.
Totally. I'm fine with that. As a step, if you wanted. Yeah. You wouldn't want to leave anything unreduced. So this would be what your final answer would look like if you want radical. Okay. Do we want another example or do we want to go on with the warm up?
Go on.
Okay.
Then I go get
We'll
a
work
card.
we'll just work with these today. That's our plan for today. Can I add these exponents?
Yes.
No.
How
They're
come?
different variables.
They are different variables. Okay. Now let's just look at the m. Is it improper?
Yeah.
How many m's get out?
3.
Good. So this would be m cubed, and then I'd have a cube root m. What about the n's?
1 gets out.
1 gets out.
1 left over.
See, I'm picking up quick. So this would be, I have 1 n gets out, and then I'd have another one inside. And technically, if you wanted to write this in proper form, you'd put the ones on the outside together, and then you could put the cube roots together. Clean it up a little
That
bit.
looks more mathematical.
Yeah, cleans it up a little.
Are you allowed to put n m to the power of 3 and then the cubed root mn?
Yeah.
No.
But you put the
no.
m and the n.
No, because that doesn't cube root to n.
Uh,
I don't- There's a cube.
If he did m, n, and then put the cube. But that one.
oh, the power?
That one cube to m.
Yeah, only because the n doesn't have a cube. This 3 right here goes with the square root. Okay.
Good try. Ian. It's good that you didn't go get that water.
Okay, if I want to write this in exponential form, meaning rational form, what would I do?
Instead, I should just die. That's my punishment.
No,
So 3K.
exactly.
Macbeth was thinking about it.
3K, no, it wasn't, 3K is 1/4. You get water in a minute. You're not gonna die from not having water for a few minutes.
You're right.
All right.
I will if I die
And that's it.
today.
That's the answer to that
Well, that one's fine.
one. Now, here's one.
Oh,
This is in the other way. Does
yeah.
anybody get out? Can anybody
Oh,
afford to pay free?
yes, yes.
3 people.
Three people can afford to get
Try
out. Good.
Change the
What?
tone of your voice, teacher, 'cause-
So first I'll write it like this, see if that helps you. Is that an improper fraction?
Yeah,
How many holes are in there?
3.
Like 3, I think.
3 holes equals 1/2.
Yeah, so I have P to the 9/3 and then P to the 2/3.
Triple P.
So then is it P3 square root P2?
So it'd be P3, and then this one wants an exponential form, so I would just leave it like this.
Oh.
Yep. All right, guys.
The switch is like easy but hard to.
It is, yeah, we're just gonna practice these. We're gonna do a little puzzle today with these things.
So it's right there.
Yeah.
When you split them, why is it 9 and 2?
Because 9/3 divides to be a nice whole number.
Oh,
And that's what I'm looking for, whole numbers.
okay.
And that's the biggest whole number that I can pull out of there.
Okay.
Hey, Xander, dial it in, please, bud.
Sanders distracting me.
Donnie, that's ironic. Okay, so how about this one right here?
Wait,
So-
wait, let me solve.
Okay, yeah, try this one. I want you to think, can anybody afford to get out?
Yeah. Easy,
Yanni, shut up.
easy.
Oh,
So easy. that
so what if
it's
there's no
easy.
leftover?
Then everybody got out,
So there's no square root symbol.
correct?
Correct.
Did you write what? So for the A, would it?
Oh, that's not what I.
That's not what I.
put.
Let's see.
I put
So-
A.
One second, nine. Take turns here. So I have 5/4, so we okay with that?
Yeah.
A to the 5/4, that's the radical form. How many holes are in 5/4? You get one hole, right? So then what's left over?
One.
Yeah, good. So 1/4 is left over. That one gets out. So that's why, just looking at the A's, here's my 1A that's out and 1A that's stuck in there. Now, the B becomes 8/4. What does that become?
2.
2. Is there any leftovers? No, so everybody got out of
I
that one.
wrote that just.
That's why you have B squared. Trinity?
Yeah, that's what I was
You
thinking.
change it to a, 1/4.
Yeah, there's one other step we have. Yes, we gotta go to the exponential part. So the last piece then is I just need to write this as 1/4. Good catch, Trinity. This would be A, B squared, and then A to the 1/4.
Mr. McDowell.
Yes, Mr. Martin.
I put A and then A again, 1/4, and then
That's
B
good. That's what I
squared.
had.
That's fine. Technically, the notation, there's nothing wrong with that. That's just like writing x2 instead of 2x. Like, they're both fine. The general rule of thumb is square roots or of any form go on the end. And the only reason is because if you switch it to this form, so if I had, x2, it could be debatable if that 2 is in there or outside. But if you make this always the last, when it's in that form, there's never any doubt if there's anything supposed to be underneath there or not. So technically, they could do any exponential fractions or radicals at the last. I won't mark it wrong.
You did the same thing.
Okay, last few here. So 7/8 and 3/8.
And you can add.
I can add these. Good, Sam, you got this. Good.
It goes to 10/8.
Right. So this goes to 10/8.
It's simplified.
Yeah,
One did
one.
now.
5/4.
Good. So this would go to 5/4.
75 before you combine.
I recommend if you can reduce at any step, always reduce. So it just makes things easier for you. So I got 5/4. Is that an improper fraction?
Yeah.
How many holes are in there?
1.
Good. How's left over?
1/4.
Yeah, so I have y
Y,
and then y. And it doesn't say radical or exponential, so you could do this or you could do it with the 4th root.
Free the wise.
All right. Now this one is a little interesting. So I have 11, 6 and 1/2. What do I do with those two things?
You make them both 6.
You make him pay.
Yes, you make them both 6, and then you're going to do a division thing. So when you divide bases, what do you do to the exponent? Subtract. Good. So this would be 2m. This is going to be 11, 6 minus, I'm just going to do a jump here real quick. 3, 6. Whoa.
That equals 8/6.
Why did I do 3, 6?
Because you.
Because you
need
multiply
a
it by 3,
negative, so then
and so the 1 turned into a
add
3, and then it's 8/6, which leaves 2.
Yes. And just be careful with notation. Don't forget parentheses. I'll make sure that 2 has that as well. And so then this would just become 2m, and that's just 8/6. And you always want to reduce whenever you can. So this would be 2m, and this would be 4, 3. Is that improper?
Yes.
Is there a hole in there?
Yeah.
Good. So then I have, what would this would look like then? Is you'd have 2m on the outside, and if I wanted to do the other notation, this would be cube root of 2m on the inside. To kind of mix it up a little.
Okay, so what's the final answer?
I would take, yeah, so this would be a final answer if you did radical form. If you did rational, it'd be 2m, and same thing, except you'd have just a little fraction. Either of those would work because it doesn't say which type, so both those are fine. Yes,
Are you recording?
I'm not, but I recorded last. Oh, no, I am recording.
1/3.
Yes. Sorry, guys. All right.
Also,
Reese?
This one's just.
All right. I know it's really badly written, but there's technically a little negative there. And so I'll make sure they're more clear when it comes to anything that's being assessed. But that's a little negative. And so when I have a 2 here and a 3/4, what do we do? You multiply them. Do I have to have common denominators to multiply? So that would just be 4, and this would be a negative, so 2 times 3 is 6/4. But I can always reduce. So this would be 3/2. What's a negative do? Flips it. Yeah, it's our flipper. So that flips it. So this would just be 1/4, 3/2. So I have this guy right here, and this is almost it. We actually know this number. I'm going to try to help you kind of get trained to be able to read these. It'll take some time, but you'll get it. This 2 down below, what is this 2 doing? Square rooting, yes. So what's the square root of 4?
2.
Okay. What's 2 cubed?
That's something.
Good. So you can do the square root first. So this is 1/8. So I can square root it first and then cube it, or I can cube it. What's 4 cubed? What's the square root of 64? 8 again. So it doesn't matter what direction you go. You can do the top one or the bottom one first.
I cubed 4, which is 6.
No, so we got the 1/4, 3/2.
Yeah.
What do we do?
That's what he's telling us.
To get from this
I
spot.
got lost in me. So we have 1/4, 3/2, right?
Yeah.
We're there.
Yes.
Now what do we do with
He's
that?
square, so. since
Yeah,
it's
so
3/2,
the-
that? You can either cube the 4, which makes it 64, and then square root it because of the 2.
Oh, so you cube the 4 and find the square root
But
of
that's
that.
harder.
Or
So
you can square it
root.
and then find.
You can square root it, which is 2, and then cube the 2, which is 8.
Yeah, I always recommend going smaller.
There you
Yeah.
go.
So then
Yeah.
this would be 1/8.
It'd be 1/8. But I just wanted to show you that there's different ways to do this. I just recommend going smaller. So square root of that would just become 2, cube of 2, that's 8. And the way of looking at it is like this. So if I square rooted this 4, that would just be 2. 2 times 2 times 2 is 8. You guys want a couple more examples, or we want to kind of wrestle through these on our
I
own?
want a drink.
Go grab a drink, Yanni.
You know.
Okay, all right, guys. So I would like you can see here.
You know
Here
the
is our
problem.
groups.
Reese is not in there.
He is. He's right there. So let's see.
Yanni again?
Reshuffle.
Here we go.
Oh, you reshuffle?
Sam and Yanni. That's quite the group. Yeah, so that's our groups. You guys can split the work. When you get the first one done, I will tell you where it's at on the map. So kind of give you a nice starting point.
Mr. McBeth,
You gotta re-roll, not in there.
Who?
Adam isn't in there.
Adam's not in here?
Oh,
Adam's
reshuffle.
reshuffle.
Yes,
Roll.
reshuffle. Oh, can I stay with Yanni?
No, reshuffle.
Shuffle.
We need to change the balance of power. in the
Adam, you can just join whatever group you want.
Let's
Oh,
go.
no.
Yeah.
All right, guys. All right, guys.
That doesn't seem fair at all.
Life's not fair.
Why do I always get Sam?
I don't know.
I've got him in like 8 times. I'm not complaining.
You know,
or
the
anything.
math is hard when you start keeping your warm-ups.
Sam doesn't
This was
have
a hard
last
one.
name.
It kind of goes ebb and flow. Hard, easy, hard, easy.
Sam doesn't have a. It's
Well,
making
this
him
is
feel a
both,
bit
like-
sad.
Kind of makes sense, but it's
But
also
Sam lost
so.
it. But Sam lost it.
All right, guys, go to your groups.
Mr. Cliff, can we get something
But
from my
Sam
locker?
Carrier.
Can I get something from my locker? really?
Yeah, that's fine.
They
I got
give-
scissors up here. We got tape up here. So the bold are the questions, the unbold are the answers. It might be. It'd be my best if you guys are each working on one, but if you want to turn one in, that's fine.
Oh,
So
yeah.
you have some problems, with some, so set one up.
Yeah.
I got a paper cutter back there. So you're matching up questions with answers. Doing stuff like we
Turn
did
the
with
light
the-
off.
And I'll come around and help you guys too.
They use a paper cutter.
You can, just watch your fingers, please.
We're gonna cut my fingers off.
You said the bold is the what?
The questions.
Yeah.
Dave, it's like this, it is. Oh, this is what? Just like that, why do you have PS5 right over?
Because esports has PS5.
What?
Yeah.
I'm thinking of PS5.
I got it for him.
How'd you get one?
I just followed people on Twitter that were announcing drops. They announced a drop and got it.
I want a PS5. Can you do that for me? I'll pay you back.
I'll show you who I follow.
Okay.
I'll pull up later. Let's see. Bo. Oh, so do you got Bo on there? Okay, cool.
I did all that time just for nothing. Mr. McBeth.
So for this first one, I'm gonna go through just 2 examples with you guys, and I'll set you loose on the one. Yep, the loose. Okay, so first guy right here. If I'm looking at this. There we go. Okay. If I look at this first one here, what's a common base I'd want to aim for, you think? Oh, and what do you got? Yeah, I think 3 is a great one. Okay, so on the right side, I see 1, 3. I love that. It's all by itself. Nothing really to do there. Left side, I don't see any 3s. You want to kind of take us home on that one then? Nice. Way to explain each step there. Well done. All right. Can I cancel 3s now? Yeah, I can. So then I just have a -2, 5n minus 12. And I'm really on the home stretch. I'm just going to add this little 12 to each side. And what would n be? 2. Yeah. So that'd be my final answer. Not that you had to do this, but let's say it was on a quiz or test and you got that and you're like, feels wrong. I hear somebody else saying something different. How could you check? Oh, I know. Please? Yeah, plug it in. Good. Yeah. Yeah, so you just plug it back in to see if that works out. And you can use your calculator for that too. Thank you, sir. Okay, so next one, common base. Raise your hands. What would you aim for? Reese, what do you got? 4. 4, yeah, 4 is great. I'm curious, could you go for a different base? Yeah. What would be another one? 2. Okay, great. I'm curious again, could you go for another base? No. Close. This one, there is one more base. Do I have one up here? I do. There is one more base. So we have 4, we have 2, and I heard you first. I'm gonna work my way around. Oh, you smell fruity. What do you got? Close. I can't get 4 to 8, but I like the guess. Dylan, I saw your hand next. 2's been mentioned, but I like it. I know. I'm just going by what I saw here. Let's see. I saw Owen, Sam, Reese. Owen? Close. Sam? Ooh, that's your guy. You could flip those to be negative. Yes. Can anybody get another one? There's one more. Reese? Yeah, if I could get 4 to 16, Owen, you can't.
What happened?
It's one. Nice. Okay, all those are options. Those would all give you the exact same answer. It doesn't matter which one you do, just so long as you make them common and then you subtract them. Do you guys want to see one of those? That's a bad question. Which one would you like to see? How about that? 4. Okay, 4 I think would be the most straightforward one. So I have 4, 3p. I have 4, -3, and I have 4. And I'm gonna go ahead and just distribute this. 6p minus 9. Yes, thank you, Ruth. Minus 18, and then I can cancel the 4s. Thank you. Yes. No, it cannot. How come? They're all 4s. Yeah, Anna?
Because you have to make it one form of size, so you have to add them. which, yeah.
Yes, they must be common, and there must be 1 on each side. So would I make this, so 3p minus 3, that's nothing, right? What is it? Yeah, but they're both 3s. Why aren't they getting along? Yeah, one doesn't have a p, or the other one does have a p. So then this would just be 4, 3p minus 3 equals 4, 6p minus 18. Now I can slash those 4s, giving me my final step, which would just be 3p minus 3 equals 6p minus 18. And at this point, I just need to do one thing. What is my goal from this point forward? Sam. That's right, get your unknown, make sure it's alone. So I'm gonna go ahead and just add 18 to each side. And then I'm gonna subtract 3p from each side. So that would give me 3p equals 21.
What are you talking about?
What is it on this side? What goes over here?
Oh, I know.
Face?
For
Not for this one, sorry, I gotta preface it to make it fair.
that would be like negative anything.
It's double digits, I agree with that part. What's this left side? So I have 3p on the right side.
Wait, what's that number?
So
Wait, no, what's
18.
that? Oh, then it's just 0.
No, it should be 15, right?
Yes, 15, good.
Look at these numbers. Okay, no, but looking at that, I don't understand I just got 15 by doing my work. I don't know where 15 is at.
So 18 plus -3.
Oh, we're doing it with that thing.
Yep, right there.
No, I see what.
No, because there's two 18s.
Yeah.
Oh, I see. Yeah, so this is for, I'm going vertically.
What?
These guys canceled out this -18. And I have to do both sides because of law of equality. Thank you, Adam. I feel like this is like a good way to do it, but I'm questioning. Glad Adam's on my side. All right, and that one's P. Any questions on that? All right, let me know if you do. Otherwise, I would like you to kind of get just a little practice with these. If you finish early, you're welcome to have just a little brain break and just kind of just relax a little and just do some non-school stuff if you like. But I would like you to kind of work through these, check with those kind of around you to see how you do them. I would like you just to work through the 10 of them. Riley, the assignment is in a OneNote homework. For our last piece here, I'll show you real quick. It is this guy. So it's in your homework section. It's called 429 Exponential Homework, Math Lib. And our plan for today is just to get some practice with that and also to ask some questions as needed. So you guys are kind of welcome to float around, start wherever you like. 10 is the hardest, 1 is the easiest. It kind of spans in between, so wherever you like. I'm a little low. Yeah. Oh, give me 1 sec here.
Maybe some more.